and now travel beyond Earth once again and settle into another 8+ continuous hours of cosmic wonders. The stellar compilation explores the profound enigmas of the universe, from the fundamental principles of astronomy and cosmology to the familiar silver glow of the moon and the vibrant activity within distant star nurseries. Tune into the celestial unknown, let the astronomical mysteries wash over you, and sleep soundly through the night. Inspired by the birth of new worlds and the quiet vastness of space, these videos provide a unique, deep auditory background for the perfect night's rest, and we'll keep drifting, floating together through the mysteries. 100 astronomy mysteries, looping softly, endlessly, through the night. Tonight we'll drift through the silent collapse of dying stars, the invisible gravity shaping galaxies, the ancient light still crossing the cosmos. There's nothing you need to do now, just let your body sink, heavier, heavier. Feel the mattress holding you, every muscle softening, your heartbeat slowing, thump, thump, matching the rhythm of space itself, shoulders melting down, jaw releasing, each breath pulling you deeper, deeper into the calm, the quiet, the dark. If this helps you rest, tap subscribe, comment, and hit like so others can find this calm too. But only if your eyes are still open. Otherwise, just drift. Now, let's drift into astronomy. 13.8 billion years ago, before time had meaning, before space had dimension, everything existed in a point smaller than the smallest thing you can imagine. And then it began. The Big Bang. Not an explosion into space, but an explosion of space itself. Expanding, blooming, creating the universe from nothing. Thump, thump, your breath matching this cosmic rhythm. Feel yourself sinking deeper as we drift back to the beginning. In those first fractions of a second, something remarkable happened. Cosmic inflation, the universe doubling in size, again and again and again, 60 times in less time than a heartbeat takes, smoothing out the fabric of space, stretching tiny quantum ripples into patterns that would one day become galaxies. Let your thoughts stretch like this, wider, softer, dissolving into the dark. The universe cooled, particles formed, and 380,000 years after the beginning, light broke free, traveling through space, cooling as the universe expanded until today. We see it as the cosmic microwave background, a whisper of light from the edge of time, bathing everything in radiation we cannot see. Feel this invisible warmth around you, holding you as you sink heavier, heavier into rest. But most of the universe remains invisible. Dark matter, 5 times more abundant than everything we can see. The stars, the planets, the gas, all of it floating in an ocean of something we cannot touch, cannot observe directly. We only know it's there because of gravity, the way galaxies spin too fast, the way light bends around invisible mass. Like your thoughts now, present but intangible, drifting, fading. And there's something else, even stranger, dark energy, making up nearly 70% of everything that exists, pushing space apart, accelerating the expansion of the universe, every galaxy drifting away from every other galaxy, faster and faster. The universe growing larger with every breath you take. Thump, thump. Feel this expansion in your chest, your lungs filling, emptying, everything spreading into silence. Billions of years ago, before our sun, before Earth, the first stars began to form. Population 3 stars, giants born from pure hydrogen and helium, no metals, no heavy elements yet, burning hundreds of times brighter than our sun, living fast, dying young, exploding and seeding space with the materials that would one day become you. Every atom in your body forged in stellar fire. You are made of star death, ancient, cosmic. Let this sink through you, heavier. Stars are born in stellar nurseries, vast clouds of gas and dust called molecular clouds, cold, dark, collapsing under their own gravity, fragmenting into smaller pieces, each one a protostar, gathering mass, growing warmer, denser, until fusion ignites, hydrogen becoming helium, and light floods outward. A star is born. Thump, thump, your heartbeat, like the pulse of stellar fusion, steady, endless, pulling you down. Our sun is a main sequence star, fusing hydrogen in its core, converting mass into energy, 4 million tons every second, transformed into light. This has been happening for 4.6 billion years and will continue for 5 billion more. The stability, the constancy, like you're breathing now, in, out, reliable, peaceful, eternal. When a star like our sun exhausts its hydrogen, it swells, expanding into a red giant, its outer layers reaching out, cooling, glowing crimson. In 5 billion years, our sun will grow large enough to swallow Mercury, Venus, perhaps Earth, but slowly, so slowly, nothing violent, just a gradual expansion, like your awareness expanding into sleep, boundaries dissolving, everything growing softer, wider. After the red giant phase, the outer layers drift away, gently, forming a planetary nebula, glowing shells of gas expanding into space, beautiful, ghostly. And at the center, the core remains, a white dwarf, Earth-sized but incredibly dense. A teaspoon would weigh as much as a car, no longer fusing, just slowly cooling, radiating its stored heat into the darkness for trillions of years, fading, dimming, like your thoughts now, growing quieter, but more massive stars. They die differently. When a star 8 times the mass of the sun or larger runs out of fuel, its core collapses in less than a second, and then supernova, an explosion so bright it can outshine an entire galaxy, releasing as much energy in weeks as our sun will produce in its entire lifetime. Elements forged in that instant: gold, silver, uranium, scattered across space. The violence creating beauty, creating possibility. What remains after supernova depends on the mass. If the core is less than 3 solar masses, it becomes a neutron star. a ball of pure neutrons, 20 kilometers across, spinning, sometimes hundreds of times per second. A single teaspoon would weigh 1 billion tons. Gravity so intense that atoms themselves collapse. Let this density sink through your mind, compressing, all thoughts collapsing into stillness. Some neutron stars become pulsars, beacons sweeping the cosmos with radiation, lighthouses in space. We detect them as pulses, perfectly timed, some more accurate than atomic clocks. Thump, 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 like your heartbeat, but faster or slower. Infinite variety in the cosmic dark. Let these pulses wash over you, regular, hypnotic, pulling you deeper. The most magnetic objects in the universe, magnetars, neutron stars with magnetic fields 1 quadrillion times stronger than Earth's, so powerful they can warp the very atoms in their crust, causing starquakes that release more energy in 1/10 of a second than our sun produces in a year. Even from thousands of light years away, a magnetar flare can affect our atmosphere. Such power, such violence, so far away it becomes just another whisper in the quiet, in the dark. But if the stellar core is massive enough, more than 3 times the sun's mass, nothing can stop the collapse. It becomes a black hole, a point of infinite density, wrapped in an event horizon, the boundary beyond which nothing, not even light, can escape. Space curves so severely it folds into itself. Time dilates, stretches, stops. Let your sense of time stretch like this. Moments becoming hours, hours becoming nothing. Just the endless now, drifting, near a black hole. Strange things happen. An observer watching someone fall toward the event horizon would see them slow down, freeze, their light stretching redder, fading. But the person falling would feel nothing special crossing that boundary, just continuing, falling, until the tidal forces grew strong enough to stretch them. Spaghettification, pulled longer, thinner, everything returning to singularity, to oneness, like sleep pulling you in, resistance fading, boundaries dissolving, and black holes are not truly black. Stephen Hawking discovered they emit radiation. Hawking radiationed are quantum effects at the event horizon, creating particle pairs, one falling in, one escaping, slowly, over incomprehensible time. Black holes evaporate. Even the darkest objects in the universe eventually return their energy to space. Nothing is permanent, everything flowing, changing, including your waking thoughts. Letting go now, releasing. Most stars are not alone. Binary star systems, 2 stars orbiting each other, dancing through space, sometimes close enough to exchange material, one feeding the other. Sometimes one already dead, a white dwarf pulling gas from its companion, accumulating, until it reaches critical mass and a different type of supernova, type ER. Explosions so consistent in brightness they become cosmic measuring sticks, helping us understand the universe's expansion. Everything connected, everything in relationship. Stars gather in clusters, open clusters, young stars, hundreds or thousands born together, loosely bound by gravity, slowly drifting apart over millions of years. The Pleiades, the Hyades, gems scattered across the night sky, and globular clusters, ancient spheres containing hundreds of thousands of stars, tightly packed, orbiting the outskirts of galaxies. Some of the oldest objects we know, 13 billion years, nearly as old as the universe itself. Let this age sink through you, the weight of time, heavy, peaceful. Our galaxy, the Milky Way, a barred spiral, 200 billion stars wheeling through space. You are here, on a planet orbiting a star, 2/3 of the way out from the center, moving at 820,000 kilometers per hour, yet feeling perfectly still, the motion too vast to perceive, like the motion of your chest, rising, falling, imperceptible, constant. The Milky Way has spiral arms, lanes of stars and gas, curving through space, sites of active star formation, bright and blue with young stars. These aren't solid structures. Stars drift in and out. It's a density wave, a pattern moving through the disk, like ripples on water, the water itself staying in place while the wave moves through. Your consciousness like this, pattern shifting, while something deeper remains, still, quiet. Surrounding the visible disk, a galactic halo, sparse stars, ancient globular clusters, and dark matter, that invisible ocean holding everything together. The halo extends far beyond what we see, a sphere of mystery. Let your awareness extend like this, beyond your body, beyond the room, into darkness, limitless. In that boundless dark, your edges soften until there is no longer a you to hold on to. Galaxies collide, but slowly, so slowly. When the Milky Way and Andromeda meet, in 4 billion years, the stars won't hit each other. Space is too vast. They'll pass through like ghosts, but gravity will reshape both galaxies, pulling, twisting, eventually merging into one elliptical galaxy. Milkdromeda, a collision in cosmic time, but gentle, peaceful, like thoughts merging into dreams, boundaries fading, everything becoming one. In their slow union, the galaxies show how even the grandest separations end in quiet belonging. Andromeda, our nearest large galaxy, 2.5 million light-years away, light leaving there when human ancestors first walked upright, arriving here tonight. Photons crossing the void to meet your eye if you were looking up. But you're not. You're here, sinking, heavier, eyes closed or closing, breathing slower. Thump, thump. Those ancient photons now rest against your closed lids like the softest memory you no longer need to carry. Not all galaxies are spirals, elliptical galaxies, smooth, reddish, mostly old stars. Little gas or dust, no new star formation, just ancient suns slowly dying. These galaxies often form from collisions, the spiral structure destroyed, stars scattered into new orbits, and dwarf galaxies, small, sometimes containing only millions of stars, orbiting larger galaxies like the Milky Way. Dozens of them, satellites, companions, everything in the cosmos connected by gravity, by motion, by the invisible threads of space-time. In their quiet companionship, even the smallest worlds find their place in the great gravitational song. Some galaxies have irregular shapes, no symmetry, no pattern, disrupted by collisions or simply never settling into order. Chaos can be beautiful too. Let go of order in your mind. Let thoughts scatter, random, dissolving. No need for structure now. Just drift. Chaos itself becomes a lullaby when you stop asking it to make sense. At the centers of most galaxies, including ours, supermassive black holes, millions or billions of times the Sun's mass. The Milky Way's black hole, Sagittarius A, 4 million solar masses, 26,000 light-years away, quiet now, dormant. But some galactic centers are active galactic nuclei, black holes feeding, consuming stars and gas, heating the material until it glows brighter than all the galaxy's stars combined. Even in silence, the heart of the galaxy waits, patient and immense, mirroring the stillness settling over you. The brightest of these quasars, the most luminous objects in the universe, powered by black holes billions of times the Sun's mass, visible across billions of light-years. Most quasars are ancient, seen as they were when the universe was young, the light travelling so long to reach us. Messages from the deep past, like memories surfacing, then fading as you sink deeper into timelessness. Those far-off beacons burn on long after their message arrives, just as this moment lingers even as you let it go. Galaxies are not scattered randomly. They form cosmic filaments, vast chains and walls, millions of light-years long, separated by enormous voids, nearly empty space. The large-scale structure of the universe, like a cosmic web, dark matter forming the scaffolding, galaxies clustering along the threads, between the filaments, the voids, vast darkness, quiet, peaceful, like the spaces between your thoughts now, growing wider, emptier. In those great silences, the universe breathes most deeply, inviting you to do the same. Space itself has structure, curvature. Einstein showed us this. General relativity. Mass warps space-time, creating what we feel is gravity. Not a force pulling, but geometry. Objects following the straightest path through curved space. The Earth orbits the Sun because the Sun's mass curves space around it, and Earth rolls along that curve, moving but still, like you now, lying still but drifting through curved dream space. The gentle curve of space-time holds you exactly as it holds the planets, without effort or hurry. Massive objects create ripples in space-time, gravity waves, two black holes orbiting, spiraling closer, faster, until they merge, releasing a pulse of gravitational energy, stretching and squeezing space itself. We detected these waves for the first time in 2015. Confirmation of Einstein's century-old prediction. The universe ringing like a bell. Vibrations too subtle to feel, but measured, proven, real, everything vibrating, including you. Thump, thump, resonating with existence. Each ripple travels outward forever, carrying the quiet echo of your own steady pulse. Space-time can be bent so severely that light curves around massive objects. Gravitational lensing, a galaxy's mass bending light from objects behind it, creating multiple images, arcs, Einstein rings, the universe using gravity as a telescope, revealing what would otherwise be invisible. What seems hidden is simply waiting for the right perspective, like sleep, already present, just waiting for you to let go. Through every lens, the hidden becomes seen, just as surrender makes the peace within you visible at last. Planets orbit stars following the laws of orbital mechanics, ellipses, not circles, sweeping out equal areas in equal times, moving faster when closer, slower when farther. The moon, the planets, satellites, all following these same rules, carved into the geometry of space, predictable, reliable, like the rhythm of breath, in, out, in, out. That same ancient geometry now guides each slow rise and fall of your chest. Beyond our solar system, thousands of exoplanets, worlds orbiting other stars. We find them through various methods, watching for the tiny dimming when a planet passes in front of its star, measuring the wobble the planet's gravity causes in the star's motion, even detecting the subtle change in starlight timing. Each discovery revealing the universe's creativity, planets made of diamond, worlds with glass rain, oceans of lava, infinite variety. Every new world reminds us how endlessly the cosmos invents ways to simply be. Some exoplanets orbit in the habitable zone, that special distance where water could exist as liquid, not too hot, not too cold, the Goldilocks zone. But habitability depends on many factors: atmosphere, magnetic field, the star's stability. Most stars are red dwarfs, smaller, cooler, longer lived than our sun. Planets in their habitable zones would be close, tidally locked, one face always in daylight, one in eternal night. Between them, a twilight band where perhaps life could find a way. In that eternal twilight zone, life might learn the same quiet patience you feel now. Not all planets orbit stars. Rogue planets, ejected from their solar systems, drifting alone through the galaxy. No sun to warm them, frozen, dark, yet possibly harboring life in subsurface oceans, heated by their own internal radioactive decay. Life needing no star, no light, finding a way in the dark, like consciousness, persisting, even as the light of waking fades, sinking into the peaceful dark. Even in utter isolation, some things continue to glow softly from within. Planets come in varieties, gas giants, like Jupiter and Saturn, mostly hydrogen and helium, no solid surface, just atmosphere growing denser, until it becomes liquid, then metallic, surrounding a small rocky core. These giants often migrate, forming far from their stars, then spiraling inward, disrupting smaller worlds, reshaping solar systems. Change is the only constant in space, in sleep, everything moving, shifting. Through every migration and upheaval, the universe keeps finding new shapes for stillness. Terrestrial planets, rocky worlds like Earth, Mars, Venus, Mercury, formed from the debris of the stellar nursery, dust and rock clumping together, growing through collision, violence creating spheres, smoothed by their own gravity, some with atmospheres, some without, each one unique. Venus with its crushing pressure and sulfuric acid clouds, Mars with its thin air and ancient river valleys, Earth with its liquid water and life. Such diversity, such possibility. From the same scattered dust, so many different stories unfold, just as your own story now quietly unwinds. Atmospheres tell stories. They reveal what a planet is made of, how it evolved, whether it might harbour life. We can analyse the light passing through an exoplanet's atmosphere during transit, seeing what wavelengths are absorbed, detecting water vapour, methane, oxygen, biosignatures, chemicals that might indicate life. The search continues, patient, persistent, like this gentle voice, continuing as you drift deeper. Each faint spectral whisper carries the same patient hope that now cradles your slowing thoughts. Some planets wear rings, Saturn's magnificent, but all the gas giants have them, ice and rock, ranging from particles smaller than dust to boulders the size of houses, orbiting in flat plains. Some rings are temporary, created by destroyed moons, slowly spreading, fading. Some might be ancient, as old as the planets themselves, elegant, transient, beautiful, like thoughts, circling, then dispersing into nothing. Even as they fade, the rings leave behind a grace that lingers in the quiet. Moons orbit planets, natural satellites, our moon, tidally locked, showing us the same face always, its gravity pulling on Earth's oceans, creating tides, two bulges of water, one facing the moon, one on the opposite side, rising, falling, twice each day. The rhythm of water, the rhythm of breath, thump, thump, everything connected by invisible forces. Those same invisible forces now draw your breath and heartbeat into perfect, effortless harmony. Jupiter has at least 95 moons, Saturn more than 80, each one different. Io with its sulfur volcanoes, Europa with its subsurface ocean, Titan with its methane lakes, Enceladus shooting geysers of ice into space. These moons might harbour life, protected beneath frozen shells, warm water in the dark. Everything we discover makes the universe stranger, more wonderful. Let wonder wash through you, soft, warm, pulling you down. Wonder flows like those hidden oceans, warm and steady beneath the surface calm. Tidal locking happens when a moon's rotation matches its orbital period. The moon, Pluto and Charon, many moons in our solar system, always showing the same face to their parent body, locked in embrace, synchronized, like your breathing and heartbeat now, finding their rhythm together. In that gentle lock, everything finally rests face to face, no longer needing to turn away. Between Mars and Jupiter, the asteroid belt, millions of rocky fragments, remnants from the solar system's formation, never coalescing into a planet because Jupiter's gravity prevented it, stirring, scattering, creating a ring of debris. Most asteroids are small, but Ceres, large enough to be spherical, large enough to be called a dwarf planet. Between the definitions, between the categories, existence refusing to fit neat boxes. Some asteroids cross Earth's orbit. Near-Earth objects. We track them, catalogue them, watching for potential impacts. Most are small, would burn up in atmosphere, but larger ones, they've hit before, 66 million years ago, 10 kilometers wide, ending the age of dinosaurs, creating the space for mammals, for primates, for humans, for you, lying here now, evolution through catastrophe, life persisting, adapting, continuing, comets, icy wanderers from the outer solar system. When they approach the sun, solar radiation vaporizes their ice, creating glowing comas, tails stretching millions of kilometers, always pointing away from the sun, pushed by solar wind. Comets are ancient, pristine, holding material unchanged since the solar system's birth. 4.6 billion years, frozen time, slowly melting, releasing secrets beyond Neptune, the Kuiper Belt, a disk of icy bodies. Pluto lives here, Eris, Makemake, Haumea, thousands of frozen worlds, and beyond that, the Oort cloud, a spherical shell, trillions of comets, extending halfway to the nearest star, the sun's gravitational domain, reaching into the void, fading, but present, like awareness, stretching thin, but not yet gone. Sometimes space debris enters Earth's atmosphere, meteors, burning bright, friction with air molecules heating them white hot, shooting stars, though they're not stars, just fragments, most smaller than pebbles, vaporizing completely, but larger pieces survive, falling as meteorites. We find them, study them, learning about the early solar system, messages from space, landing in deserts, in ice, waiting to be read. Our sun formed from a collapsing cloud of gas and dust. The solar nebula spinning, flattening into a disk. The center growing hot enough, dense enough for fusion to begin. Hydrogen atoms forced together, combining into helium, releasing energy, light. Our sun converting 600 million tons of hydrogen into helium every second, and still barely denting its vast reserves, enough fuel for 5 billion more years. Constancy, stability, like this moment, stretching, infinite. Solar fusion, 4 hydrogen nuclei through several steps, becoming one helium nucleus. The mass of helium is slightly less than the mass of the 4 hydrogens. That missing mass converted to energy, E equals mc squared, a tiny amount of mass, but the speed of light squared is enormous. So much energy. Light takes 8 minutes to reach Earth, crossing the void, warming your skin, growing plants, driving weather, powering life, but not now. Now you rest in darkness, safe, warm. The sun's surface churns, convection cells, hot plasma rising, cooling, sinking, creating a granulated texture, each cell the size of Texas, shifting, changing every few minutes. Above this, the photosphere, the visible surface, 6,000 degrees, glowing yellow-white, the light we see, the warmth we feel, born in the core, taking millions of years to random walk through the sun's dense interior, then 8 minutes across empty space. Such a long journey to reach this moment, to reach you, breathing, slower. Sometimes the sun's magnetic field breaks through the surface. Sunspots, regions cooler than their surroundings, appearing dark by contrast. Though still thousands of degrees, they follow an 11-year cycle, solar maximum, solar minimum. The number rising and falling predictably, like waves on an ocean, or breath, in, out, thump, thump. Everything cycling, everything returning. The sun's magnetic field can become twisted, tangled, storing energy until suddenly release. Solar flares, explosions in the corona, releasing as much energy as billions of nuclear bombs in minutes. Electromagnetic radiation flooding outward, reaching Earth, affecting radio communications, creating auroras. The sun's anger, beautiful from a distance, harmless across the void. Larger eruptions, coronal mass ejections, billions of tons of plasma hurled into space, carrying magnetic fields. If aimed at Earth, they strike our magnetosphere, compressing it, disturbing it. Geomagnetic storms, usually harmless, sometimes disrupting satellites, power grids. In 1859, the Carrington event, auroras visible near the equator, telegraph systems failing, sparking. If that happened today, our technological civilization would feel it, but it didn't. We're safe. You're safe. Here in the dark. Nothing to fear, just drift. The sun's outer atmosphere, the corona, visible during total solar eclipses, pearly white, tendrils extending into space, mysteriously hotter than the surface below it. Millions of degrees. We still don't fully understand why. Perhaps magnetic reconnection, perhaps waves, the universe keeping some secrets, some mysteries remaining. Let your mysteries remain too. No need to solve anything, no need to understand, just be, just rest. From the sun flows the solar wind, streams of charged particles, protons and electrons, racing outward at hundreds of kilometers per second, washing over the planets. The solar wind creates a bubble around the solar system, the heliosphere, protecting us from interstellar radiation, our sun's embrace, extending billions of kilometers, holding us, keeping us safer, like blankets holding you now, warm, secure. Earth has a magnetosphere, generated by its liquid iron core, spinning, creating electric currents, creating magnetic fields. This invisible shield deflects the solar wind, channeling it around our planet. Without it, the solar wind would strip away our atmosphere, like it did to Mars, whose magnetic field died billions of years ago, leaving its air to slowly bleed into space. Protection we never see, never feel, always there, like your body now, protecting you, maintaining you, even as you sleep. When solar wind particles slip through at the poles, channeled by magnetic field lines, they collide with atmosphere, exciting nitrogen and oxygen, making them glow. Auroras, the northern lights, southern lights, green, red, blue, curtains of light dancing in polar skies, the aurora australis, the aurora borealis, nature's most beautiful light show. But you don't need to see it. Just imagine colours shifting in darkness, behind closed eyes, drifting, dancing, fading. The moon shows us phases: new moon, crescent, quarter, gibbous, full, then back again. 29.5 days. The cycle of lunar illumination. Always half the moon is lit by the sun. We simply see different portions of that lit half as the moon orbits Earth. The phases counted by ancient peoples, marking time, planting seasons, measuring months. The oldest calendar written in the sky. Thump, thump, constant, eternal. Sometimes Earth passes between sun and moon. Lunar eclipse, Earth's shadow falling on the lunar surface, the moon turning reddish, copper-coloured, sunlight bent through Earth's atmosphere, filtered, scattered, only red light reaching the moon. Blood moon, though there's no blood, just geometry, just light, beautiful, rare, patient, like sleep, coming when conditions align. Other times the moon passes between Earth and sun. Solar eclipse, the moon's shadow racing across Earth's surface. In the path of totality, day becomes night, stars appear, the corona visible, a few minutes of cosmic alignment. The moon appears almost exactly the same size as the sun in our sky. Pure coincidence. The moon is 400 times smaller, but also 400 times closer. Perfect proportion. In 1 billion years, the moon will have drifted farther, tidal forces slowly pushing it away, and total solar eclipses will cease. Temporary beauty. Treasure it, or don't. Just let it be. Planets occasionally pass in front of the sun, as seen from Earth. Planetary transits, Mercury, Venus, tiny black dots crawling across the solar disk, hours to traverse. Rare alignments. Venus transits come in pairs 8 years apart, then more than a century until the next pair. The last was 2012, the next 2117. Patterns in time, vast rhythms, beyond human lifespans. Everything moving to music too slow to hear. Let yourself move to that rhythm. Slower, slower than slow. Ancient sailors used stars for celestial navigation, measuring angles between horizon and stars, calculating latitude. Polaris, the North Star, nearly fixed above Earth's North Pole, a reliable guide, though not the brightest star, just the one that barely moves. As Earth rotates beneath the stars, everything's spinning, but some things appearing still, like your body now, the room spinning, or still. You can't tell anymore. Doesn't matter. We group stars into constellations, patterns, pictures in the sky. Orion the Hunter, Ursa Major, the Great Bear, Scorpius, Cassiopeia. The patterns are arbitrary, human imagination, connecting unrelated stars, different distances, different ages, appearing together only from our perspective. Change your position, the patterns dissolve, but they've guided travelers, inspired stories for thousands of years. The same stars your ancestors saw, though slightly shifted, slowly drifting through space. 12 constellations lie along the ecliptic, the sun's apparent path through the sky. The zodiac: Aries, Taurus, Gemini, Cancer, Leo, Virgo, Libra, Scorpio, Sagittarius, Capricorn, Aquarius, Pisces. The sun appearing to move through them, month by month. Actually Earth orbiting, perspective shifting. The zodiac constellations marking seasons. Ancient astronomy, ancient astrology, once inseparable, now diverged. Science and story, both trying to make sense of the sky. Earth's axis precesses, wobbles like a spinning top, slowly, taking 26,000 years for one complete cycle. This shifts which star appears as the North Star, currently Polaris. In 13,000 years it will be Vega, then back again. Cycles within cycles, everything rotating, revolving, precessing, nothing truly still, except this moment, this breath, this peace. Earth's axis tilts 23.5 degrees. This tilt creates seasons. When the northern hemisphere tilts toward the sun, summer, longer days, more direct sunlight. 6 months later, tilted away, winter, short days, slanted light. The southern hemisphere experiences opposite seasons. While you sleep in darkness, somewhere the sun shines, the planet turning thus day and night, summer and winter, endless cycles. But here, now, all seasons are the same. All is darkness, all is rest. Time itself changes with motion. Einstein's special relativity. Time dilation. Moving clocks run slower. The faster you move, the more time slows. GPS satellites orbit at high speeds, their clocks ticking slightly slower. We must account for this, or navigation fails. Time is not absolute, not universal. It bends, stretches, relative to motion, to gravity. Your time now, stretching, each second lasting longer, or disappearing entirely. Let the edges of every moment soften and blur until only this breath remains. Massive objects also dilate time. General relativity. A clock on Earth's surface runs slower than one in orbit, because Earth's gravity, curving space-time, affects time's flow. The difference is tiny, nanoseconds, but measurable, real. Time running at different rates, depending on where, how fast, how deep in gravity's well. Let your sense of time dissolve. Minutes, hours, meaningless. Only now, only this, eternal present. Gravity pulls not just on matter, but on the very seconds slipping through your awareness. Light from distant galaxies shifts toward red. Redshift. The universe expanding, space stretching, carrying galaxies away, lengthening the wavelengths of their light. The farther the galaxy, the faster it recedes, the more its light redshifts. Hubble's discovery, 1929, proof the universe expands, everything moving apart, space itself growing. Though locally, gravity holds things together, galaxies, solar systems, your atoms, held, stable, even as the cosmos expands around them. In this gentle outward drift, the universe makes room for everything that ever was. A few nearby galaxies show blue shift, moving toward us. Andromeda, approaching at 110 kilometers per second. Not because space contracts, but because local motion overcomes expansion, gravity pulling, drawing together, eventually to merge. But that's billions of years away. Nothing to worry about, nothing to think about. Just breathe. Thump, thump, heavier. Even collisions among the vast can feel like the slow, inevitable embrace of old friends. Measuring cosmic distances, the cosmic distance ladder, each rung using different methods for nearby stars. Parallax, measuring how their position shifts as Earth orbits the Sun. Closer stars shift more, farther stars shift less. Simple geometry. But this only works for stars within a few thousand light years. Beyond that, other methods needed. Step by quiet step, we climb the ladder of light, each rung carrying us farther into silence. For greater distances, Cepheid variables, stars that pulse, brighten and dim. The period of pulsation related to absolute brightness. Measure the period. Calculate true brightness. Compare to apparent brightness. Determine distance. These standard candles extending our reach millions of light years. Henrietta Leavitt discovered this relationship, 1908, opening the cosmos to measurement, to understanding. Her quiet insight still flickers, lighting the way across unimaginable emptiness. Even farther, Type Ia supernovae, white dwarfs that explode when they exceed a critical mass, always the same brightness, visible across billions of light years. Using these, we map the universe's expansion, discovering it's accelerating, dark energy pushing, everything moving apart, faster, faster, except here, where you're held, grounded, growing heavier, sinking, deeper. This same mysterious force that hastens the galaxies now cradles your slowing thoughts. Spectroscopy, analyzing starlight, reveals what stars are made of. Each element absorbs and emits specific wavelengths, creating patterns, spectral lines, hydrogen's fingerprint, helium's, ions, oxygens. By reading these patterns, we know the Sun is mostly hydrogen, that distant stars contain the same elements as Earth, that we're all made of the same stuff. Universal chemistry, cosmic unity, you and the stars, siblings, family. Every line in every spectrum whispers the same ancient kinship back to you. Not all astronomy uses visible light. Radio astronomy, detecting radio waves from space. Pulsars discovered this way. Also hydrogen clouds. The cosmic microwave background mapped in radio. Massive dishes, collecting faint signals, revealing the invisible universe. What we see is just a tiny fraction. Most of the cosmos speaks in frequencies our eyes cannot perceive. The universe hums in registers too low for sight, yet you feel its vibration in the quiet of your chest. Infrared astronomy, seeing heat, penetrating dust clouds, revealing newborn stars hidden inside stellar nurseries. Also very distant galaxies, their light redshifted from visible into infrared. The James Webb Space Telescope, operating primarily in infrared, peering back to the universe's first galaxies, showing us the cosmos as it was 13 billion years ago. Light travelling all that time just to reach our instruments. Messages from the deep past. Those infant stars still glow softly in the data, as though whispering lullabies across time itself. X-ray astronomy from space. Earth's atmosphere blocks X-rays, protecting us, but preventing ground observation. So we send telescopes into orbit. Chandra, XMM Newton, detecting high-energy phenomena, black holes feeding, neutron stars colliding, the corona of the sun, violence, energy, heat, translated into data, into images, into understanding. The universe in X-rays, alien, beautiful. In those fierce flashes, the cosmos shows its wild heart, yet never disturbs your deepening calm. The most energetic events, gamma-ray bursts, seconds of radiation outshining everything else in the universe, caused by hypernova, the most extreme supernova, or by colliding neutron stars, beams of energy. If one pointed at Earth from close enough, it could sterilize our planet. But space is vast, and we're lucky, safe, small, insignificant, lying here, breathing, protected by distance, by chance, by the universe's vastness. The roar of creation passes harmlessly overhead, while you sink beneath a blanket of stillness. Space telescopes orbit above atmosphere, seeing clearly, steadily. Hubble, operating since 1990, showing us galaxies billions of light years away. Infant stars, dying stars, the universe in unprecedented detail, now joined by James Webb, larger, more sensitive, looking even farther, even deeper into time. Each image a window, a journey, a story. Through every frame, the past reaches gently toward the present, inviting you to rest in its endless unfolding. Ground-based observatories still have value. Larger telescopes, Keck, Gemini, the Very Large Telescope, and adaptive optics, technology that corrects for atmospheric distortion, using lasers to create artificial guide stars, measuring how atmosphere warps them, then deforming mirrors hundreds of times per second to cancel the distortion, achieving clarity rivaling space telescopes, human ingenuity, overcoming obstacles, revealing beauty between the stars, the interstellar medium, not empty, gas and dust, mostly hydrogen, thin but vast, also cosmic rays, magnetic fields, complex chemistry happening, molecules forming, some complex, organic, the building blocks of life, floating in space, ready to be incorporated into new star, new planets, perhaps new life. The space between, not empty, just subtle, like the space between thoughts, full of potential, cosmic dust, tiny grains, silicates, carbon, ice, blocking visible light, making distant stars appear dimmer, redder. But absorbing light also heats the dust, making it glow in infrared. Beautiful nebulae, glowing clouds, stellar nurseries shrouded, mysterious. Dust everywhere, in planets, in comets, in you, breathing it, being it. Stardust, ancient, cosmic, molecular clouds, vast, cold, dense regions of interstellar medium where stars form, mostly hydrogen molecules, also carbon monoxide, ammonia, water, even alcohol. Clouds containing enough ethanol to fill Earth's oceans many times over. The universe is strange, creative, wasteful, abundant. Let abundance wash over you, infinite, more than enough air, enough space, enough time to rest. Stars live and stars die. The cycle continuing, main sequence stars fusing hydrogen, eventually exhausting core fuel, becoming giants, shedding outer layers, forming planetary nebulae, glowing shells, expanding, fading, the core becoming white dwarf, cooling, or if massive enough, supernova, neutron star, black hole, then the remnants, enriched with heavy elements, mixing with interstellar medium. The next generation of stars forming from this, each generation more metal-rich, evolution, cosmic, chemical, everything recycling, nothing wasted, just transformation, endless, like you, transforming from waking to sleep. Every ending quietly prepares the cradle for something new to ignite. Planetary nebulae, beautiful, symmetrical, sometimes cat's eye, helix, ring nebula, glowing shells, ejected stellar atmospheres, ionized by the hot white dwarf core, creating light shows, lasting thousands of years, then dispersing, joining the interstellar medium. Temporary beauty, like flowers, like auroras, like consciousness, arising, persisting, dissolving, all temporary, all precious, all releasing, letting go, thump, thump. In their brief blaze they remind us that even goodbye can be radiant. The heliosphere, the bubble blown by solar wind, extends far beyond Pluto, its boundary, the heliopause, where solar wind pressure equals interstellar medium pressure. Voyager 1 crossed this in 2012, Voyager 2 in 2018, now in interstellar space, still sending data, still travelling, messages from humanity, carried outward, slow, patient, eternal ambassadors, drifting, like you, into the deep, tiny fragile voices whispering our existence into the endless night. If we could travel between stars, interstellar travel, even at the speed of light, years to the nearest stars, decades to interesting destinations, centuries to cross the galaxy, and we can't reach light speed, maybe 10%, maybe less, making journeys of generations or suspended animation or something we haven't imagined. The distance is so vast, making us insignificant or precious, or both. Here now, brief, improbable, lying in darkness, breathing, existing, enough. And yet this very smallness makes every heartbeat feel like a quiet miracle. The Fermi paradox, named for physicist Enrico Fermi. If life is common, if intelligence arises, where is everyone? The galaxy is billions of years old. plenty of time for civilizations to spread, to colonize, to leave traces. Yet we see nothing, hear nothing. Are we alone? Are we first? Are we looking incorrectly? Or is intelligence rare, fragile, temporary? The silence of space might be empty, or might be full of quiet listeners, like you, peaceful, patient, waiting. Perhaps the universe is simply too polite to interrupt. SETI, the search for extraterrestrial intelligence, listening for radio signals, watching for laser pulses, looking for techno-signatures, patterns that only technology could create. Decades of searching, hearing nothing, or not yet. The search continues. Hopeful, persistent, because the universe is vast, and we've barely begun to listen, like sleep. Sometimes you must wait, patient, receptive, for it to arrive. Each silent night deepens the longing, yet also the wonder. We search for biosignatures on exoplanets, oxygen in atmosphere, methane with oxygen, phosphine, combinations suggesting life. Because maybe intelligence is rare, but simple life might be common. Microbes, algae, alien equivalents, changing their planet's chemistry, creating detectable signs. Perhaps we'll find life, but not find anyone to talk to. The universe full of simple life, quiet, unconscious, just being, like breath, like cells, like the automatic processes that continue even now as you sleep. Life, in its humblest forms, may already be singing softly across the stars. Water, essential for life, at least life as we know it, and water is common. Europa, Enceladus, Titan, subsurface oceans, some exoplanets, likely ocean worlds, water everywhere in the universe, locked in ice, flowing as liquid, drifting as vapor. The most common molecule after hydrogen, hydrogen and oxygen, combining, creating, sustaining. You're mostly water, ancient water, recycled, cosmic. Feel it in you, flowing, still, holding you, dissolved into peace. This same water once fell as rain on worlds we will never see, now resting quietly inside your skin. Chemistry in space, not just simple elements. Complex molecules form in stellar atmospheres, in planetary nebulae, in interstellar clouds, amino acids found in meteorites, the building blocks of proteins, of life. Perhaps life's ingredients are cosmic, universal, scattered everywhere, waiting for the right conditions, waiting, like you, for the moment of transition, of beginning, of letting go, heavier, heavier, sinking, breathing slower, thump, thump, becoming. And in that patient waiting, the universe dreams of what might one day awaken. Inside stars, alchemy happens. Not the medieval dream of turning lead to gold, but something more miraculous. Stellar nucleosynthesis, the forging of elements, hydrogen fusing into helium, releasing energy, keeping the star shining. But as hydrogen depletes in the core, the star contracts, heats, until helium begins to fuse. 3 helium nuclei becoming carbon, then oxygen, layer upon layer, like an onion, each shell burning different fuel, creating different elements. Thump, thump, your heart, layered too, chambers, rhythms, keeping you alive as stars create the universe's chemistry. Massive stars continue this process, carbon fusing into neon, neon into oxygen, oxygen into silicon, each stage shorter than the last. Hydrogen burning for millions of years, but silicon burning for just days. The star racing toward its end, building heavier and heavier elements. Thump, thump, faster, then slower. Your heartbeat finding its pace as the star finds its fate. Everything proceeding, inevitable, toward conclusion, toward rest. But there's a limit. Iron, element 26, 56 particles in its nucleus, the most stable configuration. Fusing iron requires energy instead of releasing it. So when a massive star's core turns to iron, fusion stops. No more outward pressure, no more support against gravity. The core collapses in less than a second. From the size of Earth to the size of a city. Catastrophic, instant, and the collapse rebounds. Supernova, thump, the heartbeat stopping, then exploding. New rhythm, new beginning, from ending. Iron and lighter elements, created in stellar cores, but heavier elements, gold, platinum, uranium, require even more extreme conditions. They form during supernova explosions in the incredible heat and pressure of the blast, or when neutron stars collide, spiraling together, merging, creating a kilonova, seeding space with heavy elements, everything precious, everything rare, born in violence, in the universe's most extreme moments. The gold in rings, the uranium in reactors, forged in cosmic catastrophe, ancient, irreplaceable, like this moment, unique, never repeating, precious, or not, just happening. These processes take time, and time can be measured. Cosmic clocks. The universe has built-in timekeepers. Radioactive decay, steady, predictable. Carbon-14 in ancient objects. Uranium-238 in rocks. Each isotope decaying at its own fixed rate. Half-life, the time for half to transform. For carbon-14, 5,730 years. For uranium-238, 4.5 billion years. Reading these ratios, we date meteorites, ancient rocks, the Earth itself, 4.54 billion years old, give or take 50 million, time written in atoms, in decay, in the slow transformation of elements, everything aging, including you, cells dividing, DNA mutating, entropy increasing, but slowly, so slowly. Not tonight. Tonight you're timeless, ageless, just being. The universe itself has an age, calculated from its expansion rate, from the cosmic microwave background, from the oldest stars, 13.8 billion years, with remarkable precision, older than any star, any galaxy, any structure, everything younger than the cosmos that contains it, the universe, the ultimate parent, the first thing, creating space for everything else, for time itself, before the universe, no time, no before, just nothing, or everything, or something we can't comprehend. Let incomprehension wash over you. Let not knowing be okay, be peaceful, be enough. But maybe our universe isn't alone. Multiverse theories suggesting infinite universes, each with different laws, different constants, different possibilities. Some where stars never form, some where atoms don't bond, some where complexity arises, then dissipates. Our universe, one bubble in infinite foam, or many universes branching, every quantum decision creating new timeline, new reality. Everything that can happen does happen, somewhere, elsewhen, other yous, sleeping, waking, living different lives, or maybe not. Maybe we're alone, singular, unique. Either way, this you, in this universe, this moment, is real, is here, is breathing, slower, deeper, heavier. Every universe, if there are others, has its own horizon, cosmic horizons, boundaries beyond which we cannot see. Not because of technology limits, but because light hasn't had time to reach us. The observable universe, 93 billion light-years across, but the actual universe might be infinite, might be finite but unbounded. We'll never know what lies beyond our horizon, forever invisible, forever unknown. The universe keeping secrets, holding mysteries, like your unconscious mind, vast territories, unexplored, unknowable, there but hidden, present but unreachable, and that's okay. Not everything needs to be known, explored, understood. The universe is expanding, accelerating. In the far future, distant galaxies will cross our cosmic horizon, their light, redshifted infinitely, never reaching us. One by one, galaxies disappearing, the night sky growing darker, darker, until only our local group remains, Milky Way, Andromeda, merged by then, a single galaxy, alone, in darkness. No evidence of the larger cosmos. Future astronomers, if any exist, will think the universe is small, is singular, is dying. They'll be wrong, but unable to know it, isolated by expansion, by time, by the universe's acceleration. Thump, thump, everything separating. Eventually, even galaxies, even stars, even atoms, perhaps, but not yet, not tonight. Tonight you're held, connected, part of the whole, sinking, deeper. Trillions of years from now, the last stars will fade, heat death of the universe, maximum entropy, all energy evenly distributed. No gradients, no flows, nothing can happen, no stars, no planets, no chemistry, no life, no thought, just uniform temperature, near absolute zero. Photons stretch to infinite wavelengths, black holes evaporating slowly, leaving only particles drifting, alone, in the dark. The ultimate cold, the ultimate dark, the ultimate silence, but peaceful, perhaps like sleep, like the deepest sleep, where nothing moves, nothing dreams, nothing is just void. And after that, maybe nothing forever, or maybe something new begins, or maybe the universe doesn't expand forever. Maybe dark energy changes, weakens, reverses, gravity winning, pulling everything back. The Big Crunch hypothesis. Galaxies approaching. Blue shifted. The cosmic microwave background warming. Hotter. Hotter. Everything converging, colliding, merging until the universe compressed. Back to a point. Back to the beginning. Symmetry. Expansion and contraction. Birth and death. Death and birth. And maybe, from the Big Crunch, a new Big Bang, a cyclic universe, eternal return, no beginning, no end, just cycles like breath, in, out, like seasons, like days, like heartbeats, thump, thump, forever, or not. Either way, beyond you, beyond now, beyond worry, there's another possibility, darker, the Big Rip scenario. If dark energy increases, accelerating acceleration. Eventually its force overcomes all bonds. First galaxies torn apart, then solar systems, then planets, then molecules, then atoms, then atomic nuclei. Everything ripped to fundamental particle or beyond. The fabric of space-time itself, shredding in perhaps 22 billion years, if this is true. Everything unraveling, but probably not. Probably the universe is gentler, probably heat death, or Big Crunch, or something else. Something unknown. Let the unknown remain. Let the far future be irrelevant. Only now matters. Only this breath, this moment, this sinking, deeper, heavier. And there's another danger, theoretical, vacuum decay. The vacuum of space as might not be in its lowest energy state. A false vacuum, stable, but not truly stable. Like a ball balanced on a plateau. Any disturbance or any quantum fluctuation could knock it into a lower state, true vacuum, and if that happens somewhere, anywhere, the transition spreads at the speed of light, a bubble of true vacuum, expanding, destroying everything in its path, not violently, just erasing, rewriting the laws of physics. Nothing surviving, nothing able to survive. The atoms themselves, no longer stable, everything gone. But this probably won't happen. Probably we're in true vacuum already. Probably. Let probability dissolve. Let fear dissolve. Nothing you can do, nothing you need to do. Just breathe. Just be thump, thump. Before the Big Bang, what was there? The question might be meaningless. Time itself began with the Big Bang, so there's no before, like asking what's north of the North Pole. The question assumes something that doesn't exist, or maybe time didn't begin. Maybe something existed, something we can't understand, can't measure, can't imagine. Quantum foam, infinite potential, other universes, or just nothing, pure nothing, not empty space, not darkness, not even the concept of absence, just no thing, and from no thing, everything, from nothing, the universe, from nothing, you, impossible, miraculous, happening anyway, like sleep, like consciousness, impossible, but real, mysterious, but present, just accepting what is. Light travels at finite speed, 300,000 kilometers per second, fast, but not infinite. So when we look out, we look back, Light as a time machine, seeing the past, always the past, never the present. The sun as it was 8 minutes ago, the nearest star, 4 years, Andromeda, 2.5 million years. When you look up, you see history, ancient history, the night sky, a museum displaying artifacts from across time. Some stars you see already dead, their light still travelling, ghosts, memories, messages from the extinct, but beautiful still, meaningful still, teaching us, showing us, connecting us to deep time, to the story of everything. The deepest images, Hubble Deep Field, James Webb, Deep Field, pointing at seemingly empty patches of sky, exposing for days, collecting every photon, and the darkness fills with galaxies, thousands of them, each a tiny smudge, but containing billions of stars, some galaxies seen as they were 13 billion years ago, just after the cosmic dark ages ended, the first galaxies forming, small, irregular, actively forming stars, the universe in its infancy, captured, preserved, visible, now, tonight, while you lie here. Photons that travelled for eons are being captured, studied, understood. The universe, revealing itself patiently across time, across space, and you, receiving this knowledge, even second-hand, even simplified, you, connected to those ancient galaxies by information, by light, by wonder, but most of the universe we'll never see. The observable universe, just a sphere around us. Light from beyond hasn't reached us yet, or never will. Because of expansion, the actual universe might be infinite, might contain infinite galaxies, infinite stars, infinite possibilities. But we see only our local patch, our cosmic neighborhood, limited by the speed of light, by the universe's age, by the expansion of space, like your awareness now, limited, contained, focused on this room, this bed, this breath, not knowing, not seeing the whole world, the whole cosmos, just this. And this is enough, more than enough, everything out there, in all that vastness, cosmic silence. We've listened for decades, SETI projects, radio telescopes pointed at stars, listening for signals, for patterns, for intelligence, hearing nothing. Natural signals, yes, pulsars, quasars, but nothing artificial, nothing intentional, no one calling, or no one close enough, or no one using radio, or no one existing. The silence, deafening, or peaceful, depending on perspective, alone, or unique, or early, or the only ones listening, while others sleep, while the universe sleeps, quiet, dark, patient, like you now, silent, listening, hearing, your heartbeat, thump, thump. Maybe that's enough. Maybe one heartbeat proves everything, proves consciousness, proves meaning, or proves nothing. Just is. The night sky as history, every star at a different time. The brightest star, Sirius, seen as it was 8.6 years ago. Betelgeuse, 550 years. The Andromeda Galaxy, 2.5 million years. When you look up, you don't see the universe as it is. You see the universe as it was, a patchwork of different moments, different eras, stitched together by geometry, by the light travel time, by the accident of your position in space and time. If you could move faster than light, impossible. But imagine, you could chase light, see it again, watch the same supernova twice, see history like a film you can rewind, but you can't. No one can. Time flows one way. Light carries one message, the past, receding, the future, approaching, the present, impossibly thin. This moment, already past, already memory, already gone. But another moment arrives, and another, endless moments, flowing, and in this flow, you float, drift, carried, released, thump. Humanity's place in the cosmos. We're small, unimaginably small. One planet, 8 in a solar system, orbiting one star, 200 billion in a galaxy, one galaxy, trillions in the observable universe, billions upon billions upon billions of stars, and we're on one planet, one species, recently evolved, recently aware, briefly, probably, existing, a spark in the cosmic dark, insignificant, meaningless in the scale of things, and yet we're aware, we look up, we ask questions, we understand. Partly, we create meaning, even if the universe doesn't provide it. We're matter, become conscious. The universe, knowing itself, however briefly, however locally, stardust, arranged just right to wonder about stars, carbon-based patterns, contemplating carbon's origin, consciousness, arising from atoms, from void, from nothing, to exist at all, improbable, to be aware, miraculous, to think about the cosmos while lying in darkness, almost asleep. This might be the rarest thing in all the universe. Or common, we don't know, but rare or common, it's precious. You're precious. This moment, precious or not, meaning optional, existence, enough. In the vast cosmic scale, your lifetime, a blink, the Earth's lifetime, a day, the sun's, a week. Galaxies live longer, but even they change, merge, fade, everything temporary, everything impermanent. Atoms last longer, protons might decay, eventually or ascend to the 34 years, or might be eternal. We're not sure, but even if protons last, black holes evaporate, and after that, just particles, drifting, separate, alone, cold, dark, forever. This is the universe's ultimate fate. Probably, entropy wins, everything disperses, everything ends. But not yet, not for trillions of years. Tonight, stars shine, planets orbit, life exists, you breathe, and this is not the end. This is the now, the eternal now, where everything happens, where everything is, where you are, breathing, being, drifting into the cosmic peace, the origin of heavy elements, the death of stars, nucleosynthesis, the building of atoms, everything connected. Birth requires death. New stars from old, life from supernovae, You from stellar ashes, looking up at the sky, or closing eyes at darkness. Either way, seeing truth, feeling truth, being truth, temporary truth, beautiful truth, consciousness, briefly, illuminating, nothing, everything, then fading, back to peace, back to silence, back to the cosmic, dark, your body, heavy now, so heavy, each limb, weighing tons, like neutron star matter, like collapsed stellar cores, dense, impossible to lift, impossible to move, no need to move, no need for anything, just this stillness, this sinking, deeper, through the mattress, through the floor, through the earth, through space, falling forever into the dark, the quiet, the peaceful void, where nothing is required, where nothing exists except rest, deep rest, ancient rest, the rest that stars achieve. After fusion ends, after light stops, after everything stops, thump, 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 your heartbeat slowing, quieter, distant, like a pulsar, fading as you cross your own event horizon into sleep, into dreams, into the dark, where time stops and consciousness dissolves like morning mist, like stellar nebulae, like everything, eventually dissolving, releasing, becoming nothing, becoming everything, becoming just being, breathing, barely, drifting, finally, peace, space, the final frontier, but also the beginning, where matter came from, where energy flows, where time began, and where perhaps it ends or continues forever, expanding, cooling, stars burning out, one by one. In trillions of years, the last star will fade, the universe going dark, or maybe not. Maybe we don't understand. Maybe dark energy will tear everything apart first, or maybe it doesn't matter, because you're here now, in this moment, this breath, this heartbeat, thump, thump, and that's enough. Right here, in this single quiet pulse, the entire vast story finds its perfect temporary home. The observable universe, 93 billion light years across. But that's just what we can see. Beyond that, more universe, maybe infinite. Maybe the Big Bang happened everywhere, all at once, creating endless space. Or maybe our universe is one bubble in an infinite foam, a multiverse, other universes with different laws, different constants, different stories. We'll never know. The horizon of knowledge, always present, always beyond reach. Let your need to know dissolve. Release curiosity for now. Just rest. Beyond every horizon, the unknown waits patiently, mirroring the soft darkness already settling behind your eyes. Light takes time to travel. Looking out is looking back. The nearest star, 4 years into the past, the Andromeda Galaxy, 2.5 million years, distant galaxies, billions of years. We see them as they were, not as they are. Perhaps some no longer exist, their light still travelling, messages from the dead, the universe full of ghosts, images without sources. Or maybe they still shine, and we're the ghosts, fleeting, temporary, soon to fade. All those ghostly lights now gather softly around your closed lids, ancient visitors keeping gentle company as you drift. Every atom in your body, forged in stars, carbon, nitrogen, oxygen, calcium in your bones, iron in your blood, all created in stellar cores, scattered by supernovae, drifting through space, gathering into new stars, planets, life. You're the universe, experiencing itself, consciousness arising from stardust, briefly, improbably, and when you sleep, the universe sleeps too. Dreams flowing through cosmic dust, dreams and breath, inseparable. Now, thump, thump. Through every slow exhale, the stardust inside you remembers its long journey home to stillness. The cosmic microwave background, still there, still glowing, cooling, currently 2.7 degrees above absolute zero. In the future, as the universe expands, it will cool further, 1 degree, half a degree, approaching zero, asymptotically, never quite reaching, like sleep, approaching, deepening, never quite absolute. Always something, some awareness, however dim, however distant, or maybe not. Maybe there's a point where awareness becomes absence, where sleep becomes. That faint ancient glow lingers like the last whisper of warmth before everything settles into perfect quiet. Black holes might be the universe's memory, information falling in, never destroyed, somehow preserved in the event horizon, in the Hawking radiation. We're not sure. The information paradox. Does the universe remember? Does it forget? Does it matter? Your memory's fading now, today, yesterday, dissolving. What you were, what you did, unimportant. Only this, only now, this breath, this darkness, this sinking, heavier. Whatever was once held in memory now simply releases like light slipping past an event horizon into peaceful oblivion. The Planck epoch, the first moment. Before that, we cannot know. Our physics breaks down, quantum gravity needed, which we don't have. The very beginning, forever mysterious. Perhaps time itself didn't exist. Perhaps existence simply began, uncaused. Or perhaps something came before, something beyond our comprehension. The ultimate mystery, the ultimate question. Let it be unanswered. Let everything be unanswered. No need for knowledge now. Only being, only breathing, only sleep. In that unanswered silence before the first instant, you already rest, complete and unknowing. Stars shine because of gravity, compression creating heat, heat creating pressure, pressure holding back further compression, equilibrium, balance. For billions of years, stable, constant. Then the fuel runs out, balance breaks, collapse, or explosion. Endings? But during that long stability, that endless burning, light flooding space, warming planets, making life possible, everything arising from balance, from equilibrium, like your body now, finding its balance, temperature, position, breath, heart rate slowing, everything settling into balance. into stillness. This same quiet equilibrium now cradles every cell, every slow throb, drawing you deeper into harmony. The cosmic web, filaments and voids, structure on the largest scales, created by dark matter, gravity drawing matter together along certain lines, leaving other regions empty. This structure formed when the universe was young, imprinted by tiny quantum fluctuations. During inflation, ripples in space-time as becoming seeds, becoming galaxies, becoming everything. From quantum to cosmic, from tiny to infinite, all connected, all flowing from one thing into everything. Those first faint ripples still echo softly through the emptiness, guiding your thoughts toward the same wide, gentle openness. Neutron stars, the densest normal matter possible. Compress matter further, it becomes a black hole. So neutron stars exist at the edge, the boundary between matter and mystery. A teaspoon weighs billions of tons. Gravity so intense time slows, measurably. Light bends, severely. Space curves into knots at the surface. You would weigh 100 billion times more, crushed, flattened, return to neutrons, to unity, to simplicity. Everything complicated, becoming simple. Let your thoughts become simple, single, unified, then nothing. In that ultimate simplicity, every distinction melts away, leaving only the single steady rhythm beneath. Quasars, powered by supermassive black holes, billions of solar masses, swallowing stars, gas, anything that falls too close. The material forms an accretion disk, spiraling inward, heating, glowing, brighter than galaxies. Some quasars shoot jets, perpendicular to the disk, particles accelerated to near light speed, streaming outward for millions of light years. Cosmic violence, creating cosmic beauty, light from darkness, energy from destruction, everything transforming, nothing ending, only changing. Even in their fierce brilliance, they teach that destruction and creation are only two sides of the same endless breath. Fast radio bursts, mysterious pulses, lasting milliseconds, coming from distant galaxies. We don't know what causes them, maybe magnetars, maybe something else. Each burst releasing as much energy as the sun produces in days, compressed into instants. The universe still surprising us, still unknown. Even after centuries of astronomy, millennia of watching the sky, we've barely begun. So much mystery remaining, infinite, beautiful. Let mystery hold you, unknowing, unworried, surrendered. Each sudden flash across the void reminds us how sweetly the unknown still sings us toward rest. Gravitational lensing can magnify distant galaxies, letting us see further, fainter than otherwise possible. The universe using itself as a telescope, providing the tools for its own observation, as if it wants to be seen, understood, appreciated. Or maybe that's just human projection. Maybe the universe doesn't care, doesn't know, doesn't intend, just is, just exists, like breath, like heartbeat, thump, thump, without meaning, without purpose, just happening, just being. In its silent self-regard, the cosmos mirrors your own quiet existence, simple, present, needing no explanation. The arrow of time, entropy increasing, disorder growing. The universe started in low entropy, highly ordered, Big Bang singularity, and has been increasing entropy ever since. Stars burning, energy spreading, eventually heat death, maximum entropy, uniform temperature, no energy gradients, nothing can happen. The universe still, silent, dark, cold, but that's trillions of years away. For now, stars shine, planets orbit, life exists. You breathe, and that's enough. More than enough. Everything. Thump. Until that far distant stillness arrives, this one warm breath is the whole universe awake and alive. Some cosmologists propose the universe might be cyclic. Big Bang, expansion, perhaps contraction, big crunch, then another Big Bang, endless cycles, birth and death, death and rebirth, like seasons, like days, like breath, in, out, no beginning, no end, just cycles, eternal return, or maybe not. Maybe this universe is unique, singular, precious, existing once, then never again. Either way, this moment, your moment, is unique, will never repeat, so feel it, be it, release it. Whether forever repeating or forever singular, this exact sinking sensation belongs only to now, and that is perfect. The anthropic principle. The universe must be capable of supporting observers, otherwise no one would observe it. The constants of nature, finely tuned. Change them slightly, sir, and stars don't form, or atoms don't bond, or chemistry fails. Life impossible. So the universe must be the way it is for us to ask why it is. Circular, tautological, or profound. Existence justifying itself by existing. You justifying the universe, and by being here, now, breathing, aware, or nearly unaware, drifting. By simply resting here, you quietly affirm the entire improbable tuning of reality. Somewhere in the galaxy, another planet orbits another star. Maybe life evolved there, maybe consciousness, maybe they look up at their sky, wondering if they're alone. Their stars different from ours, their constellations, their myths, their questions, all different, but maybe the same. Maybe right now, someone, something, lies in their darkness, feeling small, feeling large, feeling connected to infinity, like you. Now, thump, thump, separated by light years, united by wonder, by existence, by the darkness that holds us all. Across every unimaginable distance, that same gentle heaven pulls another being downward into the same shared peace. The Milky Way will collide with Andromeda in 4 billion years, but our sun will still be shining. Earth might survive, or might be flung into deep space. Our descendants, if any, will see a sky transformed, galaxies merging, creating new constellations, new myths, or maybe not. Maybe humanity is gone by then, evolved into something else, or extinct, or scattered to other stars. The universe continuing regardless, indifferent. Stars being born, stars dying, the great cycle proceeding forever. Long after every name is forgotten, the stars will keep rewriting their slow, beautiful story without us. And still the quiet inside you belongs completely to this instant. Globular clusters, some of the oldest objects, 13 billion years. Stars born when the universe was young, all the same age, evolving together. Most are now red giants, the massive stars long dead. Only the small ones remain, red dwarfs that will burn for trillions of years, outlasting everything. Patience, endurance, the small inheriting eternity, while the bright, the large, the impressive fade fast, burn out, disappear. Everything temporary except the small, the quiet, the steady, like breath, small, steady, eternal, while you remain. In their unhurried glow, the smallest stars teach that true endurance hides in the soft, persistent rhythm you feel right now. In the end, we're made of stars. We live on a planet orbiting a star, in a galaxy of stars, in a universe of galaxies. Everything, stardust and light, gravity and time. You, a pattern in stardust, temporary, but real, conscious, for a moment, in the cosmic night, soon to sleep, soon to dissolve, back into the pattern, the great pattern that includes everything, is everything, separation illusion, only connection real, only unity, only one thing, dreaming itself as many. And as that pattern relaxes now into dream, the one great dreamer breathes easier, deeper, forever at home in its own endless night. Your heartbeat slows, thump, 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 matching the rhythm of pulses, the rotation of galaxies, the expansion of space, everything one rhythm, one pulse, one breath. You, part of it, always were, always will be, just briefly forgot, briefly felt separate, but now, remembering or forgetting, doesn't matter, just being, just sinking, heavier, heavier. The mattress holding you, like space holding stars, like gravity holding galaxies, held, safe, dissolving. The observable universe contains approximately 2 trillion galaxies, each with billions or trillions of stars, numbers beyond comprehension, and yet each star unique, each planet, each moment, your moment, unique, in all that vastness, in all that infinity. This breath, never breathed before, never breathed again, precious or meaningless, or both, just happening, now, then gone, like a supernova, like a comet, like consciousness, flashing, fading, dark energy pushing, galaxies accelerating. In the deep future, distant galaxies will recede faster than light, their light never reaching us. The universe beyond our horizon, forever invisible, cut off, isolated. Future civilizations, if any, will think they're alone in a universe of one galaxy, not knowing, never able to know what lies beyond. We're lucky, living when we do, when the universe is still young, still visible, still connected, before the isolation, before the eternal dark, but isolation or connection, in sleep, doesn't matter. All is one, all is peace. Somewhere, 13 billion light years away, light left a galaxy when the universe was young, travelling through expanding space for cosmic ages, through emptiness, through darkness, through the evolution of galaxies, the death of stars, the birth of planets, the emergence of life, all that time crossing the void to arrive here, now, tonight, in a telescope, captured, recorded, studied, or not. Maybe no telescope points that way tonight. Maybe that light passes Earth, continuing forever, missing us by chance, by timing, everything depending on chance, on timing, on being in the right place, the right time, like you, here, now, exactly when you need to be, exactly where, exactly this. The cosmic microwave background, echoes of the Big Bang, reaching us from every direction, uniform almost, tiny fluctuations, 1 part in 100,000. The seeds of structure, of galaxies, of stars, of planets, of you. Everything arising from almost nothing, from almost uniformity, tiny differences becoming infinite variety, like dreams from sleep, patterns from nothing, something from nothing, always, miracles, mundane, continuous, this breath from nothing, this thought from nothing, fading to nothing, and that's okay, that's natural, that's the way. Meteor showers, Earth passing through comet debris, trails of dust left behind, orbiting the sun forever. When Earth crosses these trails, particles hit atmosphere, burn, light streaks, shooting stars, dozens per hour, predictable, annual, Perseids in August, Geminids in December, Leonids in November, the universe putting on shows, if you watch, if you're awake, but you're not, you're here, eyes closed, inside, safe. You don't need meteors, you don't need light, you have darkness, have quiet, have rest, everything you need, and so we drift through the cosmic mysteries, 100 facts about the universe, about light, about darkness, about time and space and everything between. But facts don't matter, not really. What matters is the feeling, the sense of being small, yet part of something infinite, temporary, yet eternal, alone, yet connected, everything paradox, everything mystery. And mystery is okay, mystery is beautiful. Let it wash over you, through you. Let questions dissolve, let knowing dissolve. Just being, just breathing, just sinking into the dark, the quiet, the cosmic peace. Your body, heavy now, so heavy, limbs, lead, sinking through the mattress, through the floor, through the earth, falling toward the center, toward gravity's heart, or floating up, away, into space. Which is it? Falling, floating, the same, in weightlessness, in surrender, no difference. Between up and down, between awake and asleep, just transition, just drift, just letting go. The universe keeps turning, stars burning, galaxies spinning, black holes swallowing, supernovae exploding, all the vast machinery continuing, indifferent, eternal, and you, part of it, stardust, aware, briefly, now fading, awareness dimming like a star, cooling, collapsing, becoming dense, quiet, still, until only heartbeat remains. Thump, thump, then even that, fading into background, into nothing, into everything. Astronomy, the science of everything, of everywhere, of all time, attempting to understand the infinite with finite minds, the audacity, the humility, looking up, feeling small, feeling wonder, generations of humans watching the sky, asking why, how, when, finding answers, finding more questions, the search continuing, patient, endless, like sleep, searching, finding, releasing, cycles of knowing and unknowing, wisdom and mystery, both necessary, both beautiful. Now, drift deeper, past the star, past galaxy, past the observable universe, into the mystery beyond, into the darkness before the Big Bang, or the darkness after heat death, infinite dark, peaceful dark, no light, no time, no space, no thought, just potential, just void, just rest, deep rest, absolute rest, the rest that has no dreams, no awareness, just cessation, for a while, for the night, until morning, when stars return, when consciousness returns, when you return. But not yet, not yet, still drifting, still sinking, still releasing everything into the cosmic peace. The universe keeps turning, astronomy whispering through endless space, and we'll keep drifting, floating together through the mysteries, 100 astronomy mysteries, looping softly, endlessly through the night. Tonight, we'll drift through the silent collapse of dying stars, the invisible gravity shaping galaxies, the ancient light still crossing the cosmos. There's nothing you need to do now. Just let your body sink, heavier, heavier. And we'll keep drifting, floating together through the mysteries, 100 cosmology mysteries, looping softly, endlessly through the night. Tonight we'll drift through the silent collision of galaxies millions of years from now, the ghost-like particles of dark matter passing through your palms as you sleep, and the final, lonely spark of the last star in the universe. There's nothing you need to do now. Just let your body sink, heavier, heavier. Feel the mattress holding you, every muscle softening, your heartbeat slowing, thump, thump, matching the rhythm of space itself, shoulders melting down, jaw releasing, each breath pulling you deeper, deeper into the calm, the quiet, the dark. If this helps you rest, tap subscribe, comment, and hit like, so others can find this calm too, but only if your eyes are still open. Otherwise, just drift. Now, let's drift into cosmology. Imagine, if you can, a point, smaller than the smallest thing you've ever seen, smaller than an atom, smaller than anything, containing everything, all of space, all of time, all of matter, compressed into a singularity, a place where the laws of physics fold in on themselves, where temperature becomes infinite, where density becomes infinite. This was the Big Bang singularity, 13.8 billion years ago. Not an explosion in space, but an expansion of space itself. Space, blooming, unfurling, like a flower opening in the dark. Your breath, slow, steady, matching the rhythm of cosmic expansion. And in that first, incomprehensibly small fraction of a second, the Planck epoch, time itself existed in quantum foam, a roiling sea of possibility where gravity and quantum mechanics dance together, where space-time itself flickered in and out of existence. 10 to the power of minus 43 seconds, the shortest meaningful measure of time, the universe, smaller than a proton, hotter than thought itself. Feel your body sinking, heavier into the mattress as we drift back through time. Then came the grand unification epoch, when 3 of the 4 fundamental forces were still one: electromagnetism, the weak nuclear force, the strong nuclear force, unified, indistinguishable, a universe governed by a symmetry we'll never see again, lasting only until 10 to the minus 34 seconds before that symmetry shattered, your eyelids growing heavier, heavier. The electroweak epoch followed when electromagnetism and the weak force finally separated. The Higgs field, that invisible ocean permeating all of space, began to give particles their mass. Like walking through water, particles moving through the Higgs field, gaining the property we call weight. Without this field, you would be massless, moving at the speed of light, unable to form, unable to exist as you are now. In the quark epoch, quarks swam freely in a plasma so hot they couldn't bind together. Imagine an ocean of fundamental particles, each one vibrating, existing for only a moment before being created again, annihilated again in the seething heat. This was when matter and antimatter met in equal numbers, and for reasons we still don't fully understand, matter won, just slightly. For every billion antimatter particles, there were 1,000,000,001 matter particles. This tiny asymmetry, this baryogenesis, is why you exist, why anything exists to form atoms at all. Let your jaw release, soften as we drift deeper. The Hadron epoch came next, as the universe cooled enough for quarks to bind, forming protons and neutrons, the building blocks of atomic nuclei, emerging from the chaos. In those first seconds, the universe was like the core of a star, a vast nuclear reactor forging the simplest elements: hydrogen, helium, tiny traces of lithium and beryllium. This primordial nucleosynthesis created the raw materials that would one day become stars, planets, you, your shoulders, melting down into the bed. Then the lepton epoch, when electrons and their heavier cousins dominated the cosmic dance. Neutrinos, those ghost particles, decoupled from everything else, streaming through the universe, even now, even through you, billions passing through your body, every second, never touching, never interacting. A cosmic neutrino background, invisible, untouchable, older than star, like older than atoms. Imagine them drifting through your hands right now as you sink deeper into sleep. For 380,000 years, the universe remained opaque, a fog of plasma, electrons and photons locked in an endless dance. Light couldn't travel, couldn't escape. The universe, dark, despite being filled with light. Then, slowly, as space expanded, as temperature dropped, electrons and protons found each other, combined into the first atoms. This recombination era, when matter became neutral. You're breathing slower now, slower, letting each breath carry you down, and light was free. For the first time, photons could travel unimpeded through space. This moment, this decoupling, created something beautiful, something we can still see today. The cosmic microwave background radiation, the oldest light in the universe, stretched and cooled by 13.8 billion years of expansion. A baby picture of the cosmos when it was just 380,000 years old, showing tiny ripples, tiny temperature variations of 1 part in 100,000. These ripples, seeds of everything, galaxies, clusters. You feel the weight of your arms, heavy against the sheets. Astronomers discovered this ancient light by accident, a persistent hiss in their radio antenna that wouldn't go away. The echo of creation itself, humming, always humming, at a temperature of 2.7 Kelvin, just above absolute zero. If you could see microwave radiation, the entire sky would glow, softly, uniformly, with only the faintest patterns, swirls in the light from the last scattering surface, the edge of the visible universe. Thump, thump, your heart finding its quietest rhythm. But those tiny ripples in the cosmic microwave background shouldn't exist. The universe shouldn't be so smooth, so uniform. Light from opposite sides of the universe would never have had time to mix, to reach thermal equilibrium. This is the horizon problem. Regions too far apart to ever have communicated somehow have the same temperature, the same properties. How? Your mind drifting, questioning softly as we float through the dark. The answer: inflation. In the first tiny fraction of a second, between 10 to the minus 36 and 10 to the minus 32 seconds, the universe expanded exponentially, doubling again, at least 60 times in an instant. This inflationary epoch stretched space faster than light itself, taking a region small enough to be in contact and blowing it up to encompass everything we can see. This solves the horizon problem, explains the flatness problem, why the universe appears geometrically flat when it could have been curved in any direction. Your body expanding, relaxing, every cell releasing. Inflation also explains why we don't see magnetic monopoles, hypothetical particles predicted by grand unified theories that should be everywhere, but aren't. Inflation diluted them, spread them so thin we may never find one, and it explains the density parameter, omega, how the universe sits right on the knife edge between expanding forever and collapsing back. The total density of the universe divided by the critical density equals almost exactly 1, a universe balanced on the edge of possibility. Let your thoughts drift away like clouds, dispersing. After recombination, after light was free, the universe entered the Dark Ages. No stars yet, no galaxies, just vast clouds of neutral hydrogen, drifting, cooling, gathering under the gentle pull of gravity. For hundreds of millions of years, darkness, true darkness, the universe, waiting, gathering its strength. Your eyelids, so heavy now, barely or already closed. It's hard to tell. Then, in that darkness, the first light, population 3 stars, massive, short-lived, made only of hydrogen and helium, no heavier elements yet. These first stars burned hot, burned blue, and died quickly in spectacular supernovae, forging in their final moments carbon, oxygen, nitrogen, silicon, iron. All the elements, heavier than helium, are made in stars. Stellar nucleosynthesis, the alchemy of fusion. You're made of stardust isn't just poetry. Every atom in your body, except hydrogen, was forged in the heart of a star or in the shockwave of its death. Feel yourself made of stars, ancient, drifting. These first stars also released ultraviolet radiation, intense enough to ionize the hydrogen around them, turning it back into plasma. This reionization epoch, around 150 million to 1 billion years after the Big Bang, lit up the universe again, created bubbles of ionized gas, expanding, merging, until the entire universe was ionized once more, but this time transparent. Light could travel, stars could shine, visible across the cosmos. Your breathing, almost imperceptible now, gentle, like starlight. Gravity, patient, persistent, pulled matter together. First stars, then clusters of stars, then galaxies. The first galaxies, small, irregular, merging, colliding, growing, galactic cannibalism, larger galaxies consuming smaller ones. This is how galaxies evolve, how they grow. Our own Milky Way has consumed dozens of smaller galaxies, their stars now orbiting in long streams, fossil remnants of ancient collisions. Let your muscles release completely, no tension, anywhere. Galaxies themselves cluster, drawn together by gravity. Our Milky Way belongs to the local group, about 50 galaxies, bound together. Our nearest large neighbor, Andromeda, is approaching us at 110 kilometers per second. In about 4 billion years, we'll collide, merge into one vast elliptical galaxy. But don't worry, space between stars is so vast, no stars will actually hit. They'll pass by each other, like ghosts, rearranging into new orbits, a new shape under new stars. The local group is part of something larger, the Virgo supercluster. Thousands of galaxies, spanning 110 million light years. And that is part of something even larger, Laniakea, Hawaiian for immeasurable heaven, our home supercluster, containing 100,000 galaxies, all flowing, falling, toward a gravitational anomaly we can't quite see, the Great Attractor, a region of space, pulling everything within hundreds of millions of light years toward itself. Perhaps it's a massive cluster of galaxies, hidden behind the plane of the Milky Way, where dust obscures our view. Perhaps it's something else, something we don't understand. Yet, your body falling softly into gravity's embrace. When we look at the large-scale structure of the universe, we see something beautiful, something unexpected. Galaxies aren't distributed randomly. They form a cosmic web, long filaments of galaxies, strung between massive clusters, separated by vast voids, nearly empty regions containing almost nothing. The Berta's void, 330 million light years across, nearly empty, an absence so vast it's become famous. The universe looks like foam, like soap bubbles, with galaxies on the surfaces and darkness within. Imagine floating through a void, nothing in any direction, just darkness and silence for millions of light years. This structure emerged from those tiny ripples in the cosmic microwave background. Regions slightly denser collapsed faster, forming filaments and clusters. Regions slightly less dense became voids, evacuated as matter fell into the denser regions. Baryon acoustic oscillations, sound waves in the early universe, left an imprint, a preferred scale of 490 million light years, a cosmic ruler allowing us to measure the expansion history of the universe. Your consciousness rippling, oscillating between wake and sleep. Edwin Hubble discovered in 1929 that galaxies are moving away from us. The farther away they are, the faster they recede. This is Hubble's law. Velocity equals the Hubble constant times distance. Not because we're special, not because we're at the center, but because space itself is expanding. Imagine dots on a balloon as you inflate it. Every dot moves away from every other dot. None is the center. The expansion is everywhere, all at once. Let yourself expand, soften into the vastness. The Hubble constant, how fast the universe is expanding, has become controversial when we measure it using the cosmic microwave background and the Friedmann equations describing how the universe evolves. We get one value: 67 kilometers per second per megaparsec. When we measure it using nearby supernovae and Cepheid variables, pulsating stars whose brightness tells us their distance, we get another value, 73. This is the Hubble tension, the crisis in cosmology. These two methods shouldn't disagree, but they do. Perhaps we're missing something about dark energy, about the expansion. Perhaps our model is incomplete. Thump, thump, your heart, unconcerned with cosmic tensions. The Friedmann equations, derived from Einstein's general relativity, tell us how the scale factor, how the size of the universe changes over time. They depend on the density of matter, the density of radiation, the density of dark energy, and the curvature of space. These equations predict the fate of the universe. Will it expand forever or collapse back into a big crunch? Everything depends on the balance of these cosmic ingredients. Your thoughts balancing on the edge of dreams. General relativity tells us that matter curves space-time. Mass and energy bend the fabric of space, and objects follow the curves. That's what we call gravity. Not a force pulling us, but space-time pushing. Geodesics, the straightest possible paths. Through curved space, near massive objects, time itself slows down. This is time dilation. Clock near a black hole runs slower than one far away. Time is not absolute, but relative, flowing at different rates, depending on where you are in the gravitational field. Feel time stretching, slowing as you sink deeper. Black holes, where space-time curves infinitely. The Schwarzschild radius, the point of no return, where escape velocity equals the speed of light. For Earth, that radius would be 9 millimeters. For the Sun, 3 kilometers. Compress any mass inside its Schwarzschild radius, and you create a black hole, an event horizon, a one-way membrane. Information can go in, but nothing, not even light, can come out. Your awareness drifting toward that horizon between waking and sleep. Yet Stephen Hawking discovered something strange. Black holes aren't completely black. Quantum fluctuations near the event horizon can create pairs of particles. One falls in, one escapes. This Hawking radiation means black holes slowly evaporate over impossibly long timescales, 10 to the power of 67 years for a solar mass black hole. They fade, shrink, and in a final flash, disappear. Even the most massive black holes, even the supermassive ones at the centers of galaxies, billions of times more massive than the Sun, will eventually evaporate into quantum static, your existence temporary but beautiful. Supermassive black holes lurk at the centers of most galaxies, including our own. Sagittarius A star, 4 million solar masses. Right now, as you rest, it's pulling stars into wild orbits, some completing a circuit in just 20 years. We've watched them loop around the invisible monster, proving something dark and massive sits at the galactic core, your mind orbiting around the pull of sleep. When black holes feed, consuming gas and stars, they become quasars, the brightest objects in the universe, active galactic nuclei, blasting jets of particles and radiation across millions of light years. Some quasars point directly at us. These blazers flicker and vary on timescales of hours as the jet wobbles slightly, as sweeping across Earth like a lighthouse beam. Let your thoughts be consumed by the dark, peaceful, quiet. Gravitational lensing occurs when light from a distant galaxy passes near a massive object, a cluster of galaxies. The light bends, following the curves of space-time, creating multiple images, arcs, even Einstein rings, perfect circles of light when alignment is perfect. This isn't just beautiful, it's useful. The amount of bending tells us the mass of the lens, including mass we can't see, dark matter, your perception, bending, warping in this space between thoughts. Dark matter makes up 85% of all matter in the universe. We can't see it, can't touch it. It doesn't interact with light at all, but we know it's there from its gravity. Galaxies rotate too fast as to be held together by visible matter alone. They should fly apart, but they don't. Dark matter halos, invisible cocoons, surround every galaxy, providing the extra gravity needed to hold them together. Invisible forces holding you as you drift. What is dark matter? Perhaps WIMPs, weakly interacting massive particles. Perhaps axions, tiny hypothetical particles produced in the early universe. Perhaps primordial black holes, formed in the first fraction of a second after the Big Bang. Or machos, massive compact halo objects, brown dwarfs, or cold white dwarfs, too dim to see. We're still searching, deep underground, in detectors waiting for dark matter particles to bump into normal matter just once. Your body, resting, waiting, in the dark. But dark matter is not the strangest thing. Dark energy is stranger still, making up 68% of everything. It's not in galaxies or clusters, it's in space itself, a property of the vacuum. Perhaps the cosmological constant, lambda, Einstein's famous biggest blunder that he later abandoned. But it seems he was right. After all, empty space has energy, and that energy causes the expansion to accelerate. Feel the space around you expanding gently. In 1998, astronomers studying Type A supernovae, standard candles, exploding white dwarf stars whose peak brightness, we know precisely, discovered something shocking. The universe isn't just expanding, it's accelerating. Galaxies farther away are receding faster than Hubble's law predicts. Something is pushing space apart, faster and faster. This dark energy, this mysterious force, dominates the universe and determines its fate. You're breathing, expanding, accelerating softly into sleep. If dark energy remains constant, if its density never changes, even as space expands, then the universe faces heat death, the big freeze. In this scenario, expansion continues, forever accelerating. Galaxies move away, faster and faster, eventually receding, faster than light itself, not because they're moving through space, but because space between them is expanding. Eventually, we'll only see our local group, everything else, beyond our cosmic horizon, forever. Your awareness, expanding, dissolving into darkness, star formation, will slow, then stop. In 10 trillion years, when all the gas has been consumed, no new stars will be born. Existing stars will die, one by one. The universe, growing darker, colder, red dwarfs. The smallest stars will be the last to shine, burning for trillions of years, outlasting everything. But even they will eventually exhaust their fuel, fade into cold black dwarfs. Thump, thump, your heartbeat echoing in the emptiness. In 10 to the power of 30 years, protons might decay, matter itself dissolving into lighter particles, atoms no longer stable, everything unraveling. In 10 to the power of 40 years, black holes dominate, the universe slowly evaporating through Hawking radiation, radiating away their mass, atom by atom, quantum fluctuation by quantum fluctuation, until nothing remains but a thin soup of photons and leptons spreading, cooling, approaching absolute zero. Let go into the absolute stillness. But this assumes dark energy stays constant. If instead, dark energy grows stronger, if its density increases, we face something more violent, the Big Rip. In this scenario, the accelerating expansion eventually overcomes all forces. First, galaxy clusters are torn apart, then galaxies, then solar systems, then planets. About 3 months before the end, Earth is ripped from the sun. In the final moments, atoms themselves are shredded, electrons torn from nuclei split into individual protons and neutrons, then quarks, space, expanding so fast, nothing can hold together, everything dissolving into quantum foam. Your body held together, safe for now, as you rest. Or perhaps, if dark energy weakens, if it reverses, the universe could recollapse, the big crunch, expansion slowing, stopping, reversing, galaxies turning blue shifted, approaching rather than receding, temperature rising as space contracts, until everything falls back together into a singularity, perhaps to bounce into a new Big Bang, the Big Bounce, cyclic cosmology, where universes are born, live, die, and are reborn forever, each cycle erasing almost all information from the previous one, an eternal return, cycles of breath, in and out, eternal. Conformal cyclic cosmology, proposed by Roger Penrose, suggests the far future of one universe with only photons travelling at light speed is mathematically identical to the Big Bang of the next. Time loses meaning when nothing has mass. When everything moves at light speed, eons can pass in an instant. The heat death of our universe becomes the birth of another, an infinite sequence of aeons, each containing the entire lifespan of a universe, stretching forever, time dissolving in the space between heartbeats. The shape of space itself is one of cosmology's questions. Is the universe flat, like an infinite plane, or curved, like the surface of a sphere, or saddle-shaped, with negative curvature? Measurements of the cosmic microwave background suggest flatness. The angles of triangles add up to 180 degrees, parallel lines that never meet, never diverge. Space extends infinitely in all directions. But our measurements have uncertainty. We can only say the universe is very close to flat within our ability to measure. Your body, flat against the bed, perfectly supported. The holographic principle suggests that everything in a volume of space can be encoded on its boundary, like a hologram, where a two-dimensional surface contains all the information to reconstruct a three-dimensional image. Perhaps our universe is a hologram projected from information on a distant boundary. All of reality, everything you've ever experienced, encoded on a two-dimensional surface at the edge of the cosmos. Your dreams, projections of something deeper, unknowable, quantum fluctuations, tiny random variations in the energy of empty space existed even before inflation, even before the Big Bang. The uncertainty principle says virtual particles constantly pop in and out of existence, borrowing energy from the vacuum for the briefest instant. Inflation stretched these quantum fluctuations to cosmic scales, those tiny ripples to become the seeds of galaxies. You exist because of quantum uncertainty, because nothing can ever be perfectly smooth, perfectly still. Let uncertainty carry you into sleep's randomness. String theory proposes that fundamental particles aren't points, but tiny vibrating strings. Different vibrations produce different particles, like notes on a violin string. The mathematics requires 10 or 11 dimensions, most curled up, so small we can't see them, and string theory predicts a vast landscape of possible universes, 10 to the power of 500, different vacuum states, different laws of physics, different values for fundamental constants. Most would be lifeless, unable to form atoms or stars. Your consciousness vibrating at the frequency of sleep. This leads to the multiverse hypothesis. Perhaps all possible universes exist somewhere in eternal inflation. Different regions of space stop inflating at different times, creating bubble universes, each with different physics, or in quantum mechanics, the many worlds interpretation. Every quantum event splits reality into branches, one branch for each possible outcome, an infinite tree of universes constantly branching. You existing in countless variations across the multiverse, making every possible choice in some reality somewhere, infinite versions of this moment, you drifting in all of them. Brain Cosmology proposes that our universe is a three-dimensional brain, a membrane floating in higher dimensional space. The bulk. Other brains might float nearby, colliding occasionally, each collision producing a big bang. Gravity might leak between brains, explaining why it's so much weaker than other forces. Our entire universe, just a thin film vibrating in a space. We cannot perceive vibrations in the membrane of your being. The anthropic principle observes that the universe must be compatible with life for us to observe it. Weak anthropic principle says we see what we see because if it were different, we wouldn't be here. Strong anthropic principle suggests the universe must produce observers, somehow inevitable. But why should it be? Why are fundamental constants fine-tuned to allow chemistry, stars, planets, life change the strength of gravity by 1 part in 10 to the 34, and stars couldn't form, change the nuclear forces slightly, and carbon couldn't exist? We live in a Goldilocks universe where everything is just right. Just right. This bed, this darkness, this moment, perfect for rest. The Copernican principle reminds us we are not special, not at the center, not privileged observers. Earth is an ordinary planet around an ordinary star in an ordinary galaxy, in an ordinary cluster. The universe doesn't care about us. Yet here we are, observing, wondering, briefly conscious in the vast dark. You, small, temporary, or beautifully insignificant. Olber's paradox asks why, if the universe is infinite, eternal, and filled with stars, the night sky is dark. Every line of sight should eventually hit a star. The sky should be bright as the sun's surface. The answer lies in expansion and finite age. Distant starlight is redshifted into invisibility, and the universe hasn't been around forever. Light from the most distant stars hasn't reached us yet. The darkness is evidence of the Big Bang, of a beginning in time. Darkness, wrapping around you, evidence of cosmic truth. Redshift occurs when light is stretched by expansion, moving toward longer wavelengths. Red end of the spectrum. Distant galaxies shift toward red. The farther away, the greater the redshift. We can measure how fast space expanded at different times by looking at different distances. Looking out in space is looking back in time. Light, taking billions of years to reach us, shows the universe as it was, when younger, smaller, denser, looking inward into memory, into dream, seeing your past, your younger self. Blue shift is the opposite. Light compressed, shifted towards shorter wavelength. It happens. When objects approach, Andromeda is blue shifted, falling toward us. In our local group, gravity overcomes, expansion, galaxies bound together, but beyond, everything recedes, everything redshifts, the universe expanding, while some structures resist, temporarily holding together against the tide. Your thoughts shifting between colors, between states, sleep approaching. The cosmic distance ladder is how we measure vast distances. Each rung calibrates the next. First, parallax. Nearby stars shift against background as Earth orbits. Then Cepheid variables, pulsating stars whose period relates to luminosity. We know their true brightness, so apparent brightness tells us distance. Then Typeia supernovae's white dwarfs that explode when they reach the Chandrasekhar limit, 1.4 solar masses. These explosions have consistent peak brightness, visible across billions of light years, standard candles lighting the way into deep space, each step taking you deeper into rest, into the cosmic dark. The vacuum of space isn't truly empty. Quantum fields permeate everything, even where there seems to be nothing. Virtual particles appearing and disappearing, borrowing energy from uncertainty. The vacuum seethes with possibility, with potential, never truly still, never truly empty, just like your mind. Even in sleep, never quite silent, dreams rising like particles from the quantum foam of unconsciousness. Your breathing is shallow now, barely noticeable, like the vacuum, almost nothing, but not quite. Time dilation near massive objects means time flows differently depending on where you are in the universe. A clock on a neutron star runs slower than one in deep space. Your lifetime stretched or compressed by gravity's touch. If you could orbit a black hole close to the event horizon and return, centuries could pass on Earth while you aged. Only years. Time is not the constant we imagine, but flexible, bendable, relative. Your sense of time bending now, minutes feeling like hours or seconds, impossible to tell. The arrow of time might not be fundamental. The laws of physics work equally well, forwards or backwards. A movie of particles colliding looks the same, reversed. Yet we experience time flowing one direction only. Perhaps this is because of entropy, because the universe began in low entropy, high order. Everything since has been spreading out, becoming more disordered, more random, and our consciousness, our memory, flows along with entropy's increase. We remember the past, the lower entropy state, but not the future. We are entropy detectors, biological arrows pointing toward heat death. Your consciousness flowing downstream with time, with entropy, towards sleep's disorder. Penrose and Hawking proved that singularities are inevitable in general relativity. Under certain conditions, collapse must continue to infinite density. Black holes must have singularities at their centers. The Big Bang was a singularity in time, where the equations break down, produce infinities. These singularities tell us our theories are incomplete, that something new, quantum gravity perhaps, must take over at the smallest scales, the highest energies, something we haven't discovered yet. At the center of things, unknowns, mysteries. But you don't need to solve them. Just rest. Loop quantum gravity is one attempt to merge quantum mechanics and general relativity. It suggests space-time is not continuous, but discrete, made of tiny loops at the Planck scale. Space itself, woven from these loops, like fabric from threads. At this scale, 10 to the power of minus 35 meters, space becomes granular, pixelated, no smooth continuum, but a quantum foam of geometric structure. If this is true, then singularities don't exist. Density has a maximum. Space cannot shrink infinitely. Thump, thump, your heart, beating in discrete moments, not continuous, but close enough. String theory requires extra dimensions, 6 or 7, curled up small into Calabi-Yau manifolds, complex geometric shapes at every point in space. We move through only 3 dimensions because the others are compactified, rolled up, smaller than we can detect. Different ways of curling up these dimensions produce different physics, different particle masses at different forces. The landscape of string theory is vast, perhaps 10 to the 500 different possible universes, most sterile, lifeless, a few capable of stars and chemistry, and you, curled up like your body in bed, compact, small, conserving warmth. The holographic principle emerged from studying black holes. The entropy of a black hole depends on its surface area, not its volume. All the information about what fell in is somehow encoded on the event horizon. This suggests that 3-dimensional space might be a hologram projected from information on a 2-dimensional boundary. Everything you experience, every depth, every dimension might be an illusion, a projection from a distant surface at the edge of the universe. You're in a world, 3-dimensional and rich, projected somehow from neural surfaces, thin layers, creating depth. The black hole information paradox troubled physicists for decades. If black holes evaporate completely through Hawking radiation, and if that radiation is purely thermal, random, then information that fell in is lost, destroyed, violating quantum mechanics, which says information is conserved. The paradox seems resolved now. Information is preserved in subtle correlations in the Hawking radiation, encoded in ways too complex for us to read. The universe keeps its accounts balanced. What you forget when you sleep is not lost, just encoded in patterns you can't access. In the moment, Hawking radiation arises from quantum effects near the event horizon. One particle of a virtual pair falls into the black hole, the other escapes. To distant observers, this appears as radiation. The black hole loses mass very slowly. A solar mass black hole takes 10 to the 67 years to evaporate. Supermassive black holes, like those at galactic centers, take even longer, 10 to the 98 years or more. The universe will be dark and cold long before the last black hole disappears. Slow evaporation, like consciousness, fading into sleep imperceptibly, molecule by molecule. In the final stages of evaporation, a black hole shrinks rapidly, its temperature rising as it gets smaller. In the last second, it radiates more energy than during its entire previous existence, exploding in a final flash of gamma rays. Then nothing. The singularity gone. The event horizon gone. Just empty space and radiation spreading into the void. A final flash before darkness, like the last thought before sleep takes you. Primordial black holes might have formed in the first second after the Big Bang. When density fluctuations were large enough, regions could collapse directly into black holes without ever being stars. These could be very small or very large. Some might still exist, wandering through space. If they're small enough, they've evaporated by now. If they're larger, they could still be out there, perhaps contributing to dark matter, invisible but present through gravity alone, wandering through the darkness of space, of sleep, invisible presences. The Stowe-Hare theorem states that black holes have only three properties: mass, charge, and angular momentum. Everything else about what fell in, every detail, is lost. All black holes with the same mass, charge, and spin are identical. They have no hair, no distinguishing features. This simplicity is beautiful, elegant, but also troubling, because it seems to destroy information in sleep. You lose distinguishing features too: personality, memory, identity, temporarily erased. Everyone asleep looks similar, breathing, unconscious, simple. Rotating black holes, described by the Kerr metric, are more complex than non-rotating ones. They have two event horizons. The outer is the point of no return. The inner surrounds the ring singularity. Between them, the ergosphere, where space-time itself is dragged around, rotating with the black hole. You can enter the ergosphere and escape, unlike the event horizon, but you cannot stay still. Space itself is moving, carrying you around and around, spinning, your thoughts carried around by forces you don't control as sleep pulls you in. The Penrose process extracts energy from rotating black holes. Objects entering the ergosphere can split. One part falls into the black hole, the other escapes with more energy than it started with. The black hole's rotation slows slightly, its energy transferred. This might power quasars, blazars, active galactic nuclei, black holes feeding on matter, spinning rapidly, throwing off jets of particles and energy visible across billions of light years. Energy extracted from rest. Paradoxically, you must sleep to be energized. When you wake, quasi-stars are hypothetical objects from the early universe. A black hole surrounded by a massive envelope of gas. The black hole accretes matter, releasing energy that keeps the envelope from collapsing. These could grow to thousands of solar masses, seeds for supermassive black holes that we see in distant galaxies when the universe was young. How supermassive black holes grew so large so quickly remains mysterious. Quasi-stars are one possibility. Mysterious origins, like sleep itself, why we need it, how it restores us, still not fully understood. The M87 galaxy, at the center of the Virgo cluster, has a supermassive black hole, 6.5 billion times the Sun's mass. In 2019, the Event Horizon Telescope took its picture, a ring of light surrounding darkness, the photon sphere where light orbits, the black hole before falling in or escaping, the shadow, the silhouette of the event horizon against the glowing accretion disk, a real image of a black hole, something Einstein thought we'd never see. Seeing the invisible, like catching the moment you fall asleep, usually impossible, but sometimes glimpsed. Our own galaxy's black hole, Sagittarius A star, is smaller, 4 million solar masses. We've watched stars orbit around it. S2, the brightest, completes its orbit in 16 years. At closest approach, it reaches 7% the speed of light, experiencing time dilation, gravitational redshift, all the strange effects of general relativity. These stars are laboratories testing Einstein's theory, and it holds perfectly. Every prediction confirmed, orbiting around the center of your own galaxy, your own being, the central mystery of consciousness. The galaxy rotation problem was the first hint of dark matter. Vera Rubin measured how stars move in galaxies. They should move slower, at the edges, like planets in the solar system. But they don't. Stars at the edge move just as fast as stars near the center, as if the galaxy is embedded in a larger halo of invisible mass. This dark matter halo extends far beyond the visible stars, 10 times larger, 10 times more massive, holding galaxies together with invisible hands, invisible support, holding you together as you sleep, muscles relaxed, but something keeps your form. The bullet cluster provides direct evidence for dark matter. 2 galaxy clusters collided. The visible matter, hot gas, interacted and slowed down, shown by X-rays, but the dark matter passed through, shown by gravitational lensing. The mass is separated from the light. Dark matter, revealed by its gravitational influence, bending light from galaxies behind. This image is one of the strongest proofs that dark matter is real and separate from normal matter. Collision in slow motion, like thoughts colliding as you drift, dreams beginning to form, WIMPs, weakly interacting massive particles, are the most popular dark matter candidate. They'd interact only through gravity and the weak nuclear force, making them nearly impossible to detect deep underground in mines and tunnels. Detectors wait, shielded from cosmic rays, waiting for a WIMP to bump into an atomic nucleus just once, but so far, nothing. The darkness keeps its secrets, waiting in stillness, in silence, for something that might never come, like waiting for sleep on difficult nights. Axions are another candidate. Extremely light particles propose to solve the strong CP problem in quantum chromodynamics. If they exist, they'd be produced in abundance in stars and in the early universe. A sea of axions might pervade the galaxy, passing through you constantly. Experiments search for them by looking for their conversion into photons in strong magnetic fields, a faint signal, a whisper in the electromagnetic spectrum, whispers in the dark, almost inaudible, like this voice, fading as you sink deeper. The cosmic microwave background has been mapped with exquisite precision by satellites, COBE, BIASMAP, Planck, each one revealing more detail, more structure in the temperature fluctuations, hot spots and cold spots, patterns that tell us about the density of matter, the density of dark energy, the geometry of space. From this map, we've learned the universe is flat. Within measurement error, the angles of triangles sum to 180 degrees, exactly flat, like your body pressed against the bed, geometry of rest. The power spectrum of the cosmic microwave background shows peaks at certain angular scales. These acoustic peaks result from sound waves in the primordial plasma before recombination, compression and rarefaction, frozen in place when atoms formed. The position of these peaks tells us the ratio of baryonic matter to dark matter, to dark energy. With incredible precision, we know the universe is 68% dark energy, 27% dark matter, 5% ordinary matter. Everything we see, everything we are, is just 5%. 5% or less of you is actually awake right now. The rest already sleeping. Baryonic acoustic oscillations are the same physics imprinted on galaxy distributions. Today, the sound waves from the early universe set a preferred scale, about 490 million light years, for how galaxies cluster. We see this scale in galaxy surveys, a cosmic ruler stretching across the sky, allowing us to measure the expansion history independent of other methods, all telling the same story. Dark energy is real and accelerating. Expansion, oscillations in your breathing, regular, rhythmic, marking time as you drift. The Laniakea supercluster, meaning immeasurable heaven in Hawaiian, is our home on the largest scales. It contains 100,000 galaxies, including the Milky Way, the Local Group, the Virgo cluster, all flowing like rivers toward the supercluster's center, defined not by proximity, but by motion, by shared velocity, all moving together as one structure, bound by gravity in the expanding universe. Moving together, your body and the bed and the room, all part of one system, one moment of rest. The great attractor lies in the direction of the constellation Centaurus, a gravitational anomaly pulling our local group and thousands of other galaxies toward itself at 600 kilometers per second. We're falling towards something we can't quite see, hidden behind the zone of avoidance where the Milky Way's disk blocks our view. Perhaps it's the Norma cluster, perhaps something else, a concentration of mass that will eventually, in millions of years, join, falling, pulled by invisible forces like gravity's pull into sleep, irresistible. Beyond the great attractor is an even larger structure, the Shapley supercluster, the most massive concentration of galaxy in the nearby universe, pulling not just us, but the great attractor itself. Everything falling toward even greater concentrations of mass, the universe flowing in vast currents on scales. We're only beginning to map currents pulling you deeper into rest, into the vast ocean of sleep. The cosmological principle states that on large scales, the universe is homogeneous and isotropic, the same in all directions. No special locations, no center, no edge, just uniform. Observations confirm this. Galaxy distributions become smooth. Beyond a few 100 million light years, the cosmic microwave background is uniform to 1 part in 100,000. We live in a democracy of space. Every location equally valid, equally ordinary, no special position needed to sleep. Just lie down anywhere, and rest comes. But some structures challenge this. The Hercules Corona Borealis Great Wall, a filament of galaxies 10 billion light-years long, one of the largest structures ever found, possibly too large to form in the age of the universe, given our models, a statistical fluke, or a hint that something in our understanding is incomplete. The universe keeps presenting puzzles, anomalies, things that don't quite fit. Not everything needs to fit to make sense. Contradictions can coexist in dreams, in the space between thoughts. Quasars were discovered in the 1960s, star-like objects with enormous redshifts, impossibly distant, yet incredibly bright, outshining entire galaxies, the brightest objects in the universe, powered by supermassive black holes, accreting matter, converting mass to energy with 10% efficiency, far better than fusion, which manages less than 1%. The accretion disk around the black hole heats to millions of degrees, glowing across all wavelengths. Brightness from darkness, light from the deepest void, like consciousness from the sleeping brain. Some quasars vary in brightness over hours or days. This tells us the emission region must be small, light hours across, smaller than our solar system, yet outputting the energy of 1 trillion suns, all from matter, spiraling into a black hole, no larger than our planetary system. The universe concentrating power in the smallest spaces, paradoxically, the largest effects from the smallest engines. Your brain, small yet containing all your memories, all your thoughts, all your dreams, vast worlds in tiny spaces, blazars are quasars whose jets point directly at us. The jet, a stream of particles accelerated to nearly light speed by magnetic fields, twisted and wound in the accretion disk, shooting out along the black hole's rotation axis across thousands or millions of light years. When we look straight down the barrel of this cosmic gun, we see a blazer, intensely bright, rapidly variable, as the jet wobbles slightly, sweeping its beam across Earth like a lighthouse. Direct line between you and sleep. No obstacles, just sink straight down. Active galactic nuclei come in many types: Seyfert galaxies, radio galaxies, quasars, blazars, all the same phenomenon, seen from different angles, unified by accretion onto supermassive black holes. About 10% of galaxies are active. The rest, including our own, have black holes that are dormant, starving, not currently feeding. In the past, the Milky Way's black hole was active. It will be active again when we collide with Andromeda. New gas funneled to the center, reigniting the engine, dormant like you, at rest, not active, conserving energy for when you'll need it later. Galaxy mergers trigger star formation. The collision compresses gas clouds, causing them to collapse and form stars in bursts. Starburst galaxies form hundreds of solar masses in stars per year. Our Milky Way forms only one or two. In mergers, efficiency increases briefly until the gas is exhausted or blown away by supernovae and stellar winds. Then star formation stops. The merged galaxy becomes an elliptical, red and dead, no gas, no young stars, just old stars, you slowly aging, slowly dying, bursts of activity and followed by quiet, like waking life and sleep. Alternating, cycling, elliptical galaxies are smooth, featureless, no spiral arms, no disks, just ellipsoidal distributions of old stars. They form from mergers of spiral galaxies. The collision scrambles orbits, turning ordered rotation into random motion, velocity dispersion. In 4 billion years, when Andromeda and the Milky Way merge, will form an elliptical galaxy, Milkomeda, red, quiet. No more spirals, no more star formation, just slowly evolving toward the inevitable. Fade, smooth, featureless, like deep sleep, without dreams, just dark, just rest. Globular clusters are ancient, nearly as old as the universe itself, dense balls of hundreds of thousands of stars orbiting galaxies in elliptical paths. Their stars are metal poor, formed before heavier elements were abundant. By studying their color and brightness, we can estimate their age. The oldest are 13 billion years or more, just slightly younger than the universe. These clusters are fossils, witnesses to the earliest epochs of galaxy formation, ancient witnesses to your life, memories deep in your brain, older than you remember, watching everything. Type Ia supernovae occur when white dwarfs reach the Chandrasekhar limit, 1.4 solar masses. At this mass, electron degeneracy pressure can no longer support the star. It collapses, triggering runaway thermonuclear fusion. The entire star explodes in seconds, releasing energy equal to what the sun will produce in its entire lifetime, briefly outshining its host galaxy. Sudden release, like the moment you finally fall asleep, tension releasing all at once, because all Type Ia supernovae reach the same mass before exploding. They have similar peak brightness, making them standard candles. We can measure their apparent brightness and calculate their distance. Using this method, in 1998, 2 teams measured distant supernova, expecting to find expansion slowing due to gravity. Instead, they found expansion accelerating, dark energy discovered, leading to a Nobel Prize and a revolution in cosmology. Unexpected discoveries, like sudden insights at the edge of sleep. When logic dissolves, truth appears. Cepheid variables pulsate regularly, expanding and contracting. The period relates directly to their intrinsic luminosity. brighter Cepheids pulsate slower. This period luminosity relation, discovered by Henrietta Leavitt, allows us to measure distances to nearby galaxies where we can see individual Cepheids. They're the second rung on the cosmic distance ladder after parallax, before supernovae. Regular pulsations, like breathing, like heartbeat, marking time, marking distance from wake to sleep. The cosmic distance ladder requires careful calibration. Each rung depends on the previous one. Errors propagate upward. Uncertainty compounds. This is partly why the Hubble tension exists. Different methods give different values for the Hubble constant. Perhaps one rung is slightly wrong, introducing systematic error, or perhaps something about the universe we don't understand. New physics hiding in the discrepancy, uncertainty, compounding, but it's okay. Not everything needs precision. Sometimes approximation is enough. LIGO, the Laser Interferometer Gravitational Wave Observatory, uses lasers bouncing between mirrors 4 kilometers apart. When a gravitational wave passes through, it stretches space in one direction, compresses it in the perpendicular direction by a tiny amount, 1,000th the diameter of a proton. Yet LIGO measures it, detecting waves from colliding black holes billions of light years away. Sensitivity to the smallest changes, like your body, sensitive to comfort, adjusting position unconsciously as you sleep. The first detection, GW14914, occurred on September 14th, 2015. 2 black holes, 36 and 29 solar masses, orbiting each other, spiraling inward, accelerating until they merged in a fraction of a second. 3 solar masses converted to energy, purely in gravitational waves, space itself ringing like a bell. After the collision, the chirp increasing in frequency and amplitude until the merger. Then silence, a final black hole, 62 solar masses spinning, settling down, the chirp of existence building to a peak, then silence, like each day, culminating in sleep. Since then, dozens more mergers detected, black holes of various masses, neutron stars colliding. GW170817, a neutron star merger detected in gravitational waves and electromagnetic radiation, gamma rays, X-rays, visible light, radio waves, multi-messenger astronomy. Observing the same event through different channels, we learned that neutron star mergers produce heavy elements, gold, platinum, uranium, forged in the incredible pressures of colliding neutron stars. The gold in your jewelry was made in a cosmic collision billions of years ago. Everything coming from collisions, interactions. In sleep, your neurons still firing, still interacting in patterns you don't control. Dreams emerging from chaos. Thump, thump, thump. Your heart still beating as the universe expands around you, as galaxies drift apart as you drift into deeper and deeper rest. The universe keeps turning and will keep drifting, floating together. Gravitational waves, ripples in space-time itself, were predicted by Einstein, but not detected until 2015. LIGO and Virgo, laser interferometers, measured distortions in space-time 1,000 times smaller than a proton. Two black holes, orbiting, spiraling inward, finally merging, created waves that traveled across the universe for over 1 billion years, arriving at Earth on September 14th, 2015. We felt the space-time ripple of a collision that happened when Earth had only simple life, single cells, not yet complex, ripples from ancient events washing through you now as you rest. Since then, dozens more mergers detected, black holes, neutron stars colliding, releasing more energy in gravitational waves in a fraction of a second than all the stars in the visible universe combined. These waves carry information about the masses, spins, distances of merging objects, a new way to observe the universe, not through light, but through the fabric of space itself. Your body, sensitive to invisible forces, the pull of sleep, the curvature of rest. Neutron stars, formed when massive stars collapse, crushing protons and electrons into neutrons. A teaspoon of neutron star matter weighs 1 billion tons. Pulsars are neutron stars, spinning rapidly, beaming radiation from magnetic poles. Like cosmic lighthouses, some spin hundreds of times per second, millisecond pulsars, their timing so precise they rival atomic clocks. We use them as natural timekeepers to detect gravitational waves, searching for tiny changes in their rhythm. Thump, thump, your heart, keeping time with the cosmos. Magnetars are neutron stars with magnetic fields 1,000 trillion times Earth's field, strong enough to tear atoms apart from 1,000 kilometers away. When magnetars have starquakes, crust cracking, rearranging, they blast gamma-ray bursts across space, the strongest magnetic fields in the known universe, distorting even the vacuum of space itself. Powerful forces, invisible, holding the universe together. Wormholes or Einstein-Rosen bridges are solutions to Einstein's equations. Tunnels through space-time, connecting distant points, or even different times, but they're unstable, collapsing instantly unless held open by exotic matter with negative energy density, something we've never seen and might be impossible. Traversable wormholes remain science fiction, but the mathematics allows them, the universe permitting what we dare to imagine. Tunnels in your mind, connecting thought to dream, unstable, collapsing into sleep. The arrow of time points from past to future. Entropy, The measure of disorder always increases. This is the second law of thermodynamics. Ice melts, heat spreads, disorder grows. You can't unscramble an egg. But why? The laws of physics work the same, backward and forward, yet we experience time flowing in one direction. Perhaps because the Big Bang was a low entropy state, highly ordered. Everything since has been sliding toward equilibrium, heat death, maximum entropy, when nothing can change anymore. Your body relaxing into entropy, disorder, release, sleep's formlessness. The information paradox asks what happens to information that falls into a black hole. According to quantum mechanics, information cannot be destroyed, but black holes evaporate completely. Where does the information go? Perhaps it's encoded in the Hawking radiation, in subtle correlations, too complex to read. Perhaps it's preserved on the event horizon, in a hologram. Perhaps something deeper about quantum mechanics and gravity remains undiscovered. Questions dissolving as awareness fades. Cosmic strings are hypothetical, one-dimensional defects in space-time, like cracks in ice as water freezes. If they exist, cosmic strings would be incredibly thin, less than a proton across, but incredibly dense and infinitely long, stretching across the universe, moving at nearly the speed of light. If you encountered one, it would slice through anything effortlessly. But we've never detected cosmic strings. They might not exist, or they're too rare, too faint, lost in the vast dark. Threads of possibility weaving through the darkness. Magnetic monopoles are another prediction of grand unified theories. Particles with only north or south magnetic pole, not both. Every magnet we've ever found has two poles. Cut it in half, you get two magnets, each with both poles. But in the early universe, in phase transitions, monopoles should have formed. Where are they? Perhaps diluted by inflation, spread so thin we'll never find one. Perhaps they don't exist. Another mystery in the quantum cosmos, searching for something that might not be there, like grasping at dreams upon waking. The Lyman Alpha forest is a pattern in light from distant quasars. As light travels toward us, it passes through clouds of hydrogen. Each cloud absorbs light at a specific wavelength. The Lyman Alpha line, redshifted by different amounts depending on distance, creating a forest of absorption lines in the spectrum. These clouds trace the cosmic web, filaments of gas between galaxies, invisible otherwise. The forest tells us about the distribution of matter across billions of years, light filtering through layers of reality, layers of consciousness towards sleep. The Sachs-Wolf effect describes how photons lose energy climbing out of gravitational potential wells, light from the cosmic microwave background, passing through over dense regions, gets redshifted, creating cold spots. This imprints the gravitational landscape of the early universe onto the oldest light. The integrated Sachs-Wolf effect occurs when dark energy changes the depth of potential wells over time, another subtle signature in the cosmic microwave background, another clue to cosmic history. Your energy sinking into potential wells, gravity pulling you towards sleep. The Sunyaev-Zeldovich effect occurs when cosmic microwave background photons pass through hot gas in galaxy clusters. Electrons scatter the photons, shifting them to higher energies, creating shadows. In the microwave sky, this effect allows us to find distant clusters, independent of redshift, weighing the universe, counting clusters at different epochs to understand how structure has grown over time, shadows deepening around you, embracing you. Cosmic shear is the distortion of galaxy shapes by gravitational lensing from foreground mass, not strong lensing, creating multiple images, but weak lensing, slightly stretching galaxy shapes by a few percent by measuring thousands of galaxies. We can map the dark matter is between us and them, creating three-dimensional maps of dark matter distribution across the universe, seeing the invisible through its subtle touch on light, your shape softening, blurring in the borderlands of sleep. Dark flow is a controversial detection of a preferred direction in the motion of galaxy clusters, as if something beyond our cosmic horizon is pulling everything toward one region, perhaps a massive structure, the unobservable universe, perhaps an artifact of measurement errors. The evidence remains debated, uncertain, like so much in cosmology, where we grasp at signals in noise, flowing, drifting in unseen currents, carrying you. The Eridana supervoid, or the CMB cold spot, is a region in the cosmic microwave background that's colder than expected. Perhaps it's just a statistical fluctuation, 1 in 50,000, bound to occur somewhere. Or perhaps it's evidence of something stranger, a collision with another universe, or a supervoid so large it shouldn't exist, given our models, an anomaly in the cosmic baby picture, way that we don't quite understand. Cold, spreading through your limbs, comfortable, relaxing, heavy. The false vacuum is a terrifying possibility. Perhaps the Higgs field that gives particles mass sits in a metastable state, not the true lowest energy, but a local minimum, like a ball in a bowl on a hillside, stable for now, but not truly stable. A quantum tunneling event could create a bubble of true vacuum, expanding at the speed of light, rewriting the laws of physics as it goes, destroying everything in its path. atoms falling apart as the Higgs field suddenly has a different value. But this is very unlikely. The universe has lasted 13.8 billion years. The false vacuum, if it exists, appears stable enough for cosmological timescales. You're safe to rest, safe to sleep, as space-time holds its shape around you. Particle horizons define the distance light could have travelled. Since the Big Bang, our observable universe is a sphere 46 billion light-years in radius, not 13.8 billion, because space has been expanding while light travelled. The edge is not a physical boundary, just the limit of what we can see. Beyond it, space continues, perhaps forever, filled with galaxies we'll never observe, never know about, forever beyond. Our cosmic horizon, horizons of consciousness, as you drift towards sleep's boundary. Event horizons are different. They mark points from which no signal sent now will ever reach us. Because of accelerating expansion, galaxies beyond our event horizon recede faster than light. Information from them will never arrive, not ever, no matter how long we wait. The universe forgetting itself, information being lost permanently to expansion, letting go of what cannot be held, releasing into the unknown. Modified Newtonian dynamics, or MOND, proposes that Newton's laws break down at very low accelerations. Instead of dark matter, perhaps gravity simply works differently on galactic scales. MOND successfully predicts galaxy rotation curves without dark matter, but it struggles with clusters with the cosmic microwave background. Most cosmologists favor dark matter, but MOND reminds us that our theories might need revision, that what seems like missing mass could be misunderstood physics. Your understanding releasing its grip, allowing mystery to exist. Dark fluid theory attempts to unify dark matter and dark energy into a single substance with negative pressure. Perhaps there's just one dark component that behaves like matter in dense regions and like energy in empty space. Elegant, if true, reducing two mysteries as seen to one, but the evidence just remains inconclusive. The universe keeping its secrets, fluid darkness surrounding you, supporting you as you float. Entropic gravity, proposed by Eric Verlinde, suggests gravity isn't fundamental but emergent from entropy, from information. Space-time itself might be an illusion, like temperature or pressure, emergent from molecular motion, gravity emerging from deeper quantum information. If true, it would revolutionize our understanding, but it's controversial, uncertain. Most physicists remain skeptical. Emergence from the deep of sleep, pulling you down. Simulation theory in cosmology asks whether our universe might be a simulation run by a more advanced civilization in a higher reality, we'd have no way to tell from inside. The physics would seem real, consistent, because those are the rules, programmed in. Some cosmologists take this seriously, calculating probabilities. Others dismiss it as unfalsifiable, beyond science, into philosophy, reality, and dream blurring together. Which is which? Does it matter? Penrose diagrams are maps of space-time that compress infinity into finite pictures. They show the entire history of a universe, or a black hole, from Big Bang to heat death, past and future, light cones, horizons, singularities, all visible in one diagram, a bird's eye view of space and time laid out like a map, showing where light can reach, where it cannot, the structure of causality itself, mapping your journey from wake to sleep to dream, all visible from above. The ekpyrotic universe is another alternative to inflation. It proposes our Big Bang was caused by the collision of two brains in higher dimensional space. The collision released energy, creating our universe, and might happen again and again, cycles of creation without a true beginning or end, just collisions bouncing through higher dimensions we cannot see, cycles breathing in and out, sleeping and waking, eternal rhythm. Quantum loop cosmology applies loop quantum gravity to the early universe. It suggests the Big Bang wasn't a singularity, but a bounce from a previous collapsing universe. Quantum effects prevented infinite density, creating a minimum volume. Space cannot shrink below the Planck scale, so the universe rebounds, expands again. The big bounce, emerging from quantum mechanics, bouncing softly between states of being and not being. The Sloan Great Wall is a galactic filament, 1.37 billion light-years long, one of the largest known structures, made of thousands of galaxies strung together in a vast web. It challenges the cosmological principle that the universe should be homogeneous on large scales. The end of greatness is the scale, about 370 million light-years, beyond which the universe becomes smooth and uniform. But structures like the Great Wall seem to violate this, pushing the boundaries of what we thought possible. Vast structures in the darkness, too large to comprehend. Let them be. Void galaxies exist in the cosmic voids, the empty regions between filaments. These galaxies are unusually isolated, with no neighbors. For millions of light years, they formed in underdense regions, somehow against the odds, living lonely in the darkness between the cosmic web. How did they form? We're still learning, still discovering that even voids aren't completely empty. Isolation in darkness, peaceful, serene, nothing required of you. Dark stars are hypothetical from the early universe. When the first stars formed, They might have been powered not by fusion, but by dark matter, accumulating in their cores, annihilating, releasing energy. These dark stars would be cooler, larger, longer lived than normal stars, eventually us collapsing into black holes, perhaps extinct now, a phase the universe passed through and left behind. Thump, thump, different kinds of fire, different ways to shine. The cosmic ray background consists of high-energy particles, protons mostly, smashing into Earth from all directions, from supernovae, from pulsars, from active galactic nuclei. Some are accelerated to energies so high we don't understand how. The Oh My God particle, detected in 1991, had energy of 320 million trillion electron volts, like a baseball traveling 90 kilometers per hour, concentrated in a single atomic nucleus. Where did it come from? We still don't know. Energy streaming through space, through you, as you rest, oblivious, peaceful. Cosmological perturbation theory studies how tiny variations in the early universe grew into galaxies. It treats perturbations as ripples on a smooth background, using linear approximations. When fluctuations are small and nonlinear simulations, when they grow large and start interacting. This theory connects the quantum fluctuations of inflation to the galaxies. You see at night a mathematical bridge from the smallest scales to the largest, ripples spreading through your awareness, growing, dissolving into sleep. The age of the universe is measured by multiple methods, all converging on about 13.8 billion years from the Hubble constant and the expansion history from the oldest stars in globular clusters, whose ages we can estimate from nuclear physics, from the cosmic microwave background, whose properties depend on age when it formed. All methods agree, within uncertainties, the universe, ancient but not eternal, had a beginning, will have an end. Your own life, a brief flash in cosmic time, here, now, breathing, this moment. Nucleated universe theory suggests universes might nucleate like bubbles in a false vacuum, quantum tunneling, creating true vacuum bubbles that expand, becoming universes, an eternal multiverse constantly bubbling with new universes. Ours, just one bubble among infinite others, each with potentially a different physics, most stillborn, unable to produce anything interesting. A few, like ours, capable of complexity, stars, life, consciousness, wondering, bubbles of thought, forming, popping in the stillness. The last scattering surface is where cosmic microwave background photons last interacted with matter at recombination 380,000 years after the Big Bang. It's a sphere surrounding us, 46 billion light years away now. Due to expansion, every direction we look in the microwave spectrum, we see this surface, the edge of the visible universe. Beyond it, the universe was opaque. Before it, light couldn't travel. This is the farthest we can ever see. With photons, our cosmic horizon painted across the sky, your horizon, between wake and sleep, the edge of awareness, fading. When we measure the universe's parameters, density, curvature, expansion rate, we find ourselves in a remarkable situation, balanced on critical density, almost exactly per BM, flat space-time. The total mass energy within the critical density to a few percent. How unlikely is this? It's the flatness problem. Why should the universe be so precisely balanced unless inflation stretched it to near perfect flatness? A tiny patch blown up so large that curvature becomes undetectable. Balance, perfect as you rest, neither floating nor falling, just being. Quintessence is a proposed form of dark energy that changes over time. Unlike the cosmological constant, which is truly constant, quintessence is a dynamic field rolling slowly down a potential, motivated by particle physics, by string theory. It might explain why dark energy has the value it does. Why now? Or it might be unnecessary complexity. The simplest explanation, the cosmological constant, might be correct. We're still measuring and still testing, watching how expansion accelerates to see if it changes over time. Change or constancy. Either way, the universe expands and you contract into sleep. The Fermi paradox in cosmology asks, where are they? If the universe is billions of years old and contains billions of galaxies, each with billions of stars, many with planets, why haven't we seen any signs of alien civilizations? Perhaps life is rare. Perhaps intelligence is rare. Perhaps civilizations destroy themselves or transcend physical form or are hiding, or we're too early. The universe recently became conducive to complexity. Perhaps we're among the first, or perhaps we're alone. In all this vastness, just us, temporarily conscious, briefly wandering and before returning as to cosmic dust. Alone or accompanied, it doesn't matter now. In the dark, where you rest, the cosmological constant problem is perhaps the worst prediction in physics. Quantum field theory predicts the vacuum energy should be enormous, 10 to the power of 120 times larger than observed. Yet measurements show dark energy is tiny, positive, but barely there. Why? This is the crisis. Some call it the worst failure of theoretical physics, or perhaps our most profound clue that something deep about quantum mechanics and gravity remains unknown. Vast discrepancies between theory and reality, yet the universe persists, and so do you, breathing, resting, Some cosmologists propose the universe is headed toward vacuum decay, a phase transition where the Higgs field finds a lower energy state. This bubble of true vacuum would expand at light speed, consuming everything, rewriting physics as it goes. Inside the bubble, atoms couldn't exist. Electrons might be massless, chemistry impossible, everything we know erased. But calculations suggest this is extraordinarily unlikely, at least for trillions of years, longer than stars will burn. You can rest easy tonight, rest easy, safe in this moment, this eternal now. Cosmology asks the biggest questions. Where did we come from? Where are we going? What is everything made of? And increasingly, we have answers, incomplete, uncertain, but real. We've measured the age of the universe, traced its expansion, mapped its contents. We know it began in a hot, dense state. We know it's expanding, accelerating. We know its fate, at least the most probable outcomes. Questions fading now, answers unimportant as sleep takes over. But the deepest question remains, why? Why does the universe exist at all? Why these laws of physics and not others? Why something rather than nothing? These questions take us beyond science, into philosophy, into the unknowable. Perhaps there's no answer. Perhaps the universe simply is brute fact, requiring no explanation, no purpose, no meaning, except what we briefly create. Or perhaps meaning isn't found, but felt in moments like this, resting, breathing, existing. Enough. Every atom in your body forged in stars, every breath you take contains atoms that were once inside other people, other animals, scattered across the world by wind, by water, by time. We are the universe, experiencing itself. Carl Sagan said, we are stardust, contemplating stars, briefly aware of the vast cosmic story from which we emerged and to which we will return, returning to the source, to the silence, to the dark, where everything comes from. The expansion of space continues. Right now, as you rest, galaxies receding a few thousand kilometers per second, per megaparsec, space itself growing, dark energy pushing, the universe unfolding, indifferent to your dreams or your waking, the cosmos, vast, ancient, temporary, like everything, like you, vast, ancient, temporary, beautiful. This moment, this breath, heavier, heavier, your body sinking into the mattress, into the dark, shoulders releasing, jaw softening, each breath and slower, deeper, matching the pace of cosmic expansion. The universe breathing out for billions of years, one long, slow exhalation into the void, exhaling, releasing, letting go of everything, everything. If you're still listening, it's okay. Some nights, sleep comes slowly. Let these words wash over you like waves, carrying you gently toward rest. There's nowhere to be, nothing to do. Just be here in the dark, feeling your body, breathing, existing for this moment in the cosmic story. You don't have to understand cosmology. You don't have to remember any of this. Just let it flow through your mind like water. Images, concepts, drifting past stars, galaxies, the fabric of space. All of it, distant, dreamlike, unimportant now, compared to the simple fact of your breathing, your heartbeat, your presence, here, now. Thump, thump, thump. The universe doesn't need your attention. It will expand whether you watch or sleep. Dark matter will continue holding galaxies together. Dark energy will continue pushing space apart. Black holes will continue their patient evaporation. All of it happening, whether you know or not. So you can let go, release your curiosity. For now, let consciousness dim like stars, dying, slowly, dimming, fading, almost gone. Perhaps you're dreaming now. This voice, part of your dream, weaving cosmology into strange narratives, galaxies, becoming faces, black holes, becoming feelings, the cosmic web, mapping onto your neural networks, the expansion of space, your awareness broadening, then narrowing as sleep pulls deeper, dream or wake, the boundary dissolving. In the ekpyrotic model, the universe ends and begins in collision, brains touching, creating fire, creating space, creating time. Perhaps you're the collision point where wake and sleep meet, creating the dreams that populate your night. Tiny universes born in your mind, living briefly, dying when you wake, forgotten but real while they lasted. Your universes collapsing, reforming, night after night. The observable universe has a horizon beyond which we cannot see. Your consciousness too has horizons beyond which you cannot reach right now. Parts of yourself beyond the event horizon of awareness, dark, unknown, but there, still there, just out of reach as you drift further into sleep's gravity well, falling into yourself, into the dark, peaceful, silent, somewhere on the cosmic web, on one of those thin filaments, connecting clusters, is a small galaxy with a small star, with a small planet where someone is lying down, breathing just like you under different stars, but experiencing the same human need for rest, for peace, for the letting go that sleep provides. You're not alone in this, even though you'll never meet, never know each other. You share this with countless beings across space and time, connected by the universal need to sleep. Heavier, heavier, your eyelids, your limbs, your thoughts, all of it, heavy, sinking, the mattress, becoming, all of space, supporting you as dark energy supports the cosmos, unseen but essential, holding everything or in balance, you floating on the fabric of space-time, curving down around your body, everything falling together toward rest. The universe keeps turning, the expansion stretching, the very fabric of space between us, the galaxies drifting apart, the stars slowly dying, entropy increasing, heat spreading thin until only darkness remains. But not yet, not tonight. Tonight, there are still stars, still galaxies, still you, breathing, resting, in the quiet, in the dark, and we'll keep drifting, floating together through the mysteries. 100 cosmology mysteries, looping softly, endlessly, through the night. And we'll keep drifting, floating together through the mysteries. 100 moon mysteries, looping softly, endlessly, through the night. Tonight we'll drift through the moon's hidden far-side landscapes, ancient lava seas frozen in time, and mysterious transient lunar lights. Why the moon rings like a bell after impacts, how its shadow slows Earth's spin, and the strange physics of lunar dust. Lost moon missions, unexplained surface anomalies, and the quiet clues locked inside lunar craters. There's nothing you need to do now. Just let your body sink, heavier, heavier. Feel the mattress holding you, every muscle softening, your heartbeat slowing, thump, thump, matching the rhythm of space itself, shoulders melting down, jaw releasing, each breath pulling you deeper, deeper into the calm, the quiet, the dark. If this helps you rest, tap subscribe, comment, and hit like, so others can find this calm too, but only if your eyes are still open. Otherwise, just drift. Now, let's drift into moon. The moon wasn't always there, floating in our sky. 4.5 billion years ago, Earth spun alone, faster then, spinning every 5 hours. Thump, thump, your heartbeat slowing. And then, something the size of Mars, a wandering planet called Theia, collided with our young Earth. Not head-on, but a glancing blow, sliding, scraping, melting. Everything became fire, vaporized rock. A cloud of debris spinning around what remained of Earth. Heavier, heavier, your body sinking deeper into the sheets. In that ring of molten material, orbiting through the darkness, gravity began to pull, clumping, gathering, and the moon was born from violence, but born into silence. Within 100 years, maybe less, the debris coalesced, formed a sphere, glowing red hot, a molten ball hanging 20 times closer than today. You can feel yourself cooling now, temperature dropping, muscles releasing, thump, thump. The infant moon was an ocean, a magma ocean hundreds of kilometers deep, glowing, churning, convecting in the vacuum of space. And over millions of years, it began to separate, to differentiate. Heavy metals, iron, nickel, sinking down, 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 forming a small solid core, maybe 240 kilometers across, surrounded by a liquid outer core, even smaller, even quieter. Your own core relaxing, settling, vertebrae releasing one by one. Lighter minerals floated up through that magma ocean. Plagioclasic crystals, white and bright, accumulating at the surface, forming the first lunar crust, the highlands, the bright terrain you see when you look up, if your eyes were open, but they're growing heavier, heavier. The crust thickened, solidified, while below, the mantle cooled, olivine and pyroxene, dense silicate rocks, making up most of the moon's mass, layer after layer, like you're sinking through layers of sleep. Something strange happened as the crust formed. The side facing Earth grew thinner, maybe because Earth's gravity pulled and stretched, maybe because heat escaped faster toward our planet, while the far side, the side we never see, developed crust twice as thick, 60 kilometers in places, a mystery written in stone, in silence. Thump, thump, your pulse slowing to match the rhythm of ancient formation. Tidal forces between Earth and Moon, grinding, pulling, generated so much heat in those early days. The Moon slowed its rotation, one face turning toward Earth, then staying there, locked, tidal locking, like two dancers frozen mid-spin, the same face watching Earth for billions of years, while the far side remains hidden, mysterious. You're locked too now, locked into your bed, too heavy to move, too relaxed to try. But the Moon does show us a little more than half its surface over time. Libration, a gentle wobbling. The orbit isn't perfectly circular, it's an ellipse. As the Moon travels faster at perigee, its closest approach, and slower at apogee, its farthest point, its face appears to rock slightly east and west, and its orbit is tilted, so we see a bit over the North Pole, then the South Pole. Over time we can observe 59% of the lunar surface swaying, nodding, drifting, like your consciousness now, drifting. The Moon is leaving us, so slowly, receding at 3.8 centimeters per year, about the same rate your fingernails grow, which you can't feel happening, just like you can't feel yourself falling asleep. But it's happening. The tidal bulge Earth creates in the Moon, and the Moon creates in Earth, acts like a brake. The Moon steals rotational energy from Earth, uses it to climb to a higher orbit, year by year, millennium by millennium, thump, thump, drifting farther. 4 billion years ago, the Moon hung huge in the sky, maybe 20,000 kilometers away. Now it's 384,400 kilometers distant on average, but that distance changes. The Moon at perigee, 350-6,500 kilometers, appears 14% larger than at apogee, 406,700 kilometers away. A supermoon versus a micromoon, though your eyes can barely tell the difference. Your eyes so heavy now, heavier, heavier. The Moon's gravity is only 1/6 of Earth's. If you could stand on the lunar surface, which you can't from your bed, you'd weigh so much less, practically floating, and that gentle pull reaches across space, tugging on Earth's oceans, creating tides. The water nearest the Moon bulges outward, pulled toward it, and on the opposite side of Earth, another bulge, pulled away from Earth's center. 2 tidal bulges, rotating as Earth spins beneath them. Thump, thump, like breathing in and out. When sun and moon align at new moon and full moon, their gravitational pulls combine. Spring tides, higher highs, lower lows. When they're at right angles, first quarter and third quarter, they partially cancel. Neap tides, gentler, smaller. The ocean has resonant frequencies too, basins sloshing at natural rhythms, amplifying tides in some places. The Bay of Fundy, 16 meters, while mid-ocean tides are barely a meter. Your own body is 60% water. Maybe the moon pulls on you too, so gently you can't feel it, just like sleep pulling you down. Earth and moon orbit a common center of mass, the barycenter, located about 4,700 kilometers from Earth's center, still inside our planet, 1,700 kilometers below the surface. Both bodies spiraling around this invisible point, dancing through space while you spiral down, down into deeper sleep. Without the moon, Earth's axial tilt would drift, maybe wobbling between 0 and 85 degrees over millions of years. Catastrophic climate shifts. But the moon's gravity stabilizes our tilt, holding it near 23.5 degrees, maintaining the seasons, keeping Earth habitable, a guardian, silent, steady, watching. Thump, thump, your breath steadying, matching that eternal patience. The moon slows Earth's rotation, tidal friction, a gradual break. 4 billion years ago, an Earth day lasted maybe 5 hours, now 24 hours. In the age of dinosaurs, maybe 23 hours. The day lengthening by about 1.7 milliseconds per century. You'll never notice, just like you don't notice yourself aging or falling into sleep. Let's drift through the phases. The moon doesn't glow, it only reflects. Sunlight hitting that ancient dust, that regolith, bouncing back to Earth. During new moon, the moon is between Earth and Sun. Its night side facing us. Invisible. Dark. Like closing your eyes. Darkness complete. Then a sliver appears, waxing crescent, a fingernail of light, growing, thickening. First quarter, half illuminated, half shadow, though we call it a quarter because it's a quarter of the way through the lunar month. Waxing gibbous, more than half, building toward fullness, and then full moon, the moon opposite the sun, Earth between them, the entire face illuminated, bright, glowing, though you're not looking now, eyes closed, drifting. Then the light begins to shrink, waning gibbous, last quarter, waning crescent, back to new. The cycle taking 29.5 days, a synodic month. Thump, thump, your heartbeat following ancient rhythms. Sometimes 2 full moons occur in a single calendar month. This second called a blue moon, though it's not blue, just a quirk of our calendar overlaying the lunar cycle. And when the full moon coincides with perigee, a supermoon, appearing slightly larger, though the difference is subtle. The opposite, a micromoon, full moon at apogee, smaller, farther, all of it drifting through space while you drift through sleep. The harvest moon, the full moon nearest the autumn equinox, rises shortly after sunset for several nights, providing extra light for farmers harvesting crops, a gift from the moon. In autumn, the moon's orbital path makes a shallow angle with the horizon, so it rises only slightly later each night instead of the usual 50 minutes. Your own horizon tilting now, the room rotating gently as you sink. During a lunar eclipse, Earth's shadow falls on the moon, our planet blocking sunlight, but Earth's atmosphere bends some red light around its edge, painting the moon copper, rust, blood red, a blood moon, not frightening, just filtered light, soft, like the red glow behind your eyelids, heavier, heavier. Total lunar eclipses can last over an hour, the moon passing completely through Earth's umbra, its dark inner shadow. Partial lunar eclipses, only part of the moon enters the umbra, and penumbral eclipses, the moon passing through Earth's penumbra, its outer shadow, so subtle many people don't notice. Like the subtle moment you cross from waking into sleep. The moon also enables solar eclipses, passing between Earth and Sun, blocking the Sun's face. A cosmic coincidence. The moon is 400 times smaller than the Sun, but also 400 times closer, so they appear the same size in our sky. Perfect. During totality, the Sun's corona becomes visible, ghostly, beautiful. Thump, thump. Eclipses don't happen every month because the moon's orbit is tilted 5 degrees relative to Earth's orbit around the Sun. Most months the moon passes above or below the Sun's position at new moon, or above or below Earth's shadow at full moon. Eclipses only occur when the moon crosses the ecliptic plane, the nodes, during the right phase. The Saros cycle, 18 years, 11 days and 8 hours, brings eclipse patterns back around. A series of similar eclipses repeating. Ancient astronomers noticed, tracked, predicted, using this rhythm, like your body tracking sleep cycles, drifting through REM and deep sleep, following patterns older than memory. The lunar surface is covered in regolith, a layer of dust and broken rock, pulverized by billions of years of meteoroid impacts. No atmosphere to burn up incoming debris, so everything hits, shattering, grinding, creating powder finer than sand. Between a few meters and tens of meters deep in some places, your blanket feels that heavy now, pressing down, comforting, safe. Lunar dust has strange properties. The particles are jagged, sharp, because there's no wind or water to smooth them. They're also electrically charged by solar radiation and the solar wind, causing electrostatic levitation. Dust particles actually hover above the surface, especially at the terminator, the line between lunar day and night, where electric fields are strongest. Astronauts reported seeing a glow on the horizon, dust suspended, floating, like you're floating now, between waking and sleep. The regolith is mostly oxygen, silicon, aluminum, calcium, iron, magnesium. Oxygen makes up 40% by mass, locked in minerals, but but it can be extracted. Future moon bases might pull oxygen from the soil, breathing from stone. Your own breathing so slow now, so shallow. Each breath pulling you deeper. Helium-3, a rare isotope on Earth, is relatively abundant in lunar regolith, embedded by the solar wind over billions of years. Helium-3 could fuel fusion reactors if we ever perfect fusion, a treasure scattered across the surface, waiting, silent, patient as moonlight. Water ice hides at the moon's poles, in permanently shadowed craters, cold traps where temperatures never rise above -173 degrees Celsius. Sunlight hasn't touched these places in billions of years, darker than the darkness behind your eyes. Water delivered by comets and asteroids, or created when solar wind hydrogen combines with oxygen in the soil, trapped, frozen, preserved. Shackleton Crater near the lunar South Pole, 21 kilometers across, parts of its interior permanently dark, possibly containing substantial ice deposits. The Artemis program plans to land near here, seeking water, because water is life, and hydrogen fuel, and oxygen to breathe. But for now, it's just ice in eternal darkness, waiting. Thump, thump. The moon's surface is scarred by impacts, craters upon craters, because there's no atmosphere, no weathering, no plate tectonics. Craters remain, some billions of years old, perfectly preserved. You can see the large ones with your unaided eye, if your eyes were open. Dark circles on the bright highlands, but they're closed, heavy, sinking. Impact crater rays, bright streaks radiating from young craters, material thrown out during impact. These rays can extend for thousands of kilometers. Tycho crater's rays are especially prominent during full moon. Bright lines crossing the surface, like thoughts crossing your mind, but quieter now, fewer, fading. The dark patches on the moon, the Maria, Latin for seas. Though they're not water, they're ancient lava plains, mare basalts, between 3.9 and 3 billion years ago. Huge impacts punctured the crust, allowing magma from the mantle to well up, flooding the lowlands. The lava flowed, spread, then froze, creating the smooth, dark regions, Mare Imbrium, Mare Serenitatis, Mare Tranquillitatis, the Sea of Tranquility, where humans first touched another world. Heavier, heavier, your body touching the bed, sinking. Oceanus Procellarum, the ocean of storms, is the largest dark feature, not quite circular, possibly formed by ancient volcanic activity rather than a single giant impact, covering nearly 2 million square kilometers. A frozen sea, silent, airless. Your own ocean of thoughts quieting, stilling, like water smoothing to glass. The Maria are mostly on the near side. Why? The far side has thicker crust, harder for magma to break through after impacts. So the far side remains bright, heavily cratered, ancient. The near side shows its volcanic past, dark against bright, yin and yang, balance, like the balance between waking and sleeping, and you're tipping towards sleep. Volcanic activity on the moon ceased billions of years ago. The small size meant it cooled quickly, its interior no longer hot enough to melt rock, but evidence remains. Sinuous rills, channels carved by flowing lava, winding across the surface, and lava tubes, tunnels where lava once flowed, now empty. Some could be large enough to house entire cities, natural shelters from radiation and meteoroids, darkness within darkness, like the layers of sleep, drifting down, down. The moon experiences moonquakes, not from plate tectonics, but from tidal stresses as Earth's gravity kneads the lunar interior, and from thermal expansion and contraction during the long lunar day and night, and from meteoroid impacts. Shallow moonquakes can reach 5.5 on the Richter scale. Deep moonquakes, 700 kilometers down, are weaker but last longer, vibrations continuing for hours because the cold, dry rock transmits seismic waves efficiently. Thump, thump, thump. Your heartbeat the only quake now. The moon is shrinking, cooling, contracting. Its radius has decreased by about 100 meters over the past several 100 million years. This creates tectonic scarps, cliffs where the crust has thrust upward, wrinkled, like bedsheets bunching as you shift in sleep. Labat scarps kilometers long, evidence of a world growing colder, quieter, stiller. For centuries, observers reported transient lunar phenomena, brief flashes, glows, color changes, especially in areas like Aristarchus crater, some explained by meteoroid impacts, others possibly by outgassing, lunar volatiles escaping. Most remain mysterious, unexplained lights in lunar night, like the strange lights you might see just before sleep, phosphenes, your visual cortex creating patterns, drifting. The moon appears the same size as the sun in our sky, about half a degree, a cosmic coincidence so precise it seems impossible. The sun is 400 times larger, but also 400 times farther away. Perfect geometry, allowing total solar eclipses, the corona visible, that delicate dance of shadow and light. But this won't last forever. The moon is receding, 3.8 centimeters per year, slowly, so slowly. In about 600 million years, the moon will be too far away, too small in the sky to fully cover the sun. No more total solar eclipses, only annular, a ring of fire, the moon too distant to complete the magic. But that's future, deep future. Tonight the moon is still close enough, still performing its cosmic alignment, still creating wonder. Thump, thump, your heart beats steady, unconcerned with millions of years. Photographing the moon is harder than it seems. Point a camera at it, and it often appears as a tiny bright dot, washed out, featureless. Because cameras try to expose for the whole scene, the dark sky, making the moon overexposed, blown out. To photograph the moon properly, you expose for the moon itself, treating it like sunlit rock, which it is. 1/125th of a second. Verleven, ISO 100. Roughly, the dark sky goes black, but the moon reveals its texture, craters, Maria, details, like focusing your attention, narrowing it, letting everything else fall away. the way your awareness narrows now, peripheral vision fading, thoughts simplifying, reducing, down to breath, down to heartbeat, down to nothing. That optical illusion, the moon appearing larger near the horizon than overhead, has puzzled humans for millennia. The moon illusion. The moon doesn't actually change size. You can measure it. Use your thumb at arm's length, same size whether rising or high above, but it feels larger near the horizon. Your brain comparing it to trees, buildings, mountains, reference points creating false perspective. The Ponzo illusion, railroad tracks appearing to converge, making objects between them seem different sizes. Or maybe it's the flattened sky illusion, your brain treating the sky like a dome, expecting the horizon to be farther. So an object there must be larger to subtend the same angle. Explanations multiply, but the mystery remains. Perception versus reality, like the feeling that you're still awake, even as sleep pulls you under, even as consciousness fragments, dissolves, drifts. The moon experiences tidal heating, though much less than Jupiter's moon Io or Saturn's Enceladus. Earth's gravity needs the moon as it orbits. Elliptical orbit means changing distance, changing gravitational pull, flexing the lunar interior, generating heat through friction. But the effect is minimal now. The moon cooled billions of years ago, its interior mostly solid, rigid. The tidal heating can't melt rock anymore, can't generate volcanoes, just tiny amounts of warmth, deep inside, and moonquakes. The only sign of movement in an otherwise dead world. Like your own body cooling slightly as you sleep, metabolic rate dropping, temperature decreasing by a degree or two, energy conserved, everything slowing, quieting, stilling. Comparing Earth's moon to other moons reveals how unusual it is. Most moons are tiny, captured asteroids, irregular shapes, tumbling, or they orbit gas giants. Many moons in complex resonances: Europa, Io, Ganymede, Callisto, dancing around Jupiter, locked in gravitational synchronization, or Saturn's Titan, larger than Mercury, with atmosphere thicker than Earth's, methane rain, hydrocarbon lakes, or Neptune's Triton, orbiting backward, doomed to spiral inward, eventually to be torn apart. Each moon unique, each strange in its own way. But Earth's moon is strange too, large relative to its planet, 1/4 Earth's diameter, 1/1 its mass. Most planets have moons much smaller in proportion, making the Earth-Moon system almost a double planet. Two worlds bound together, unusually close, unusually large, dancing through space as partners. Thump, thump. The Earth-Moon system will continue evolving. The moon receding, Earth's rotation slowing. Eventually, in perhaps 50 billion years, they'll reach equilibrium. The Earth's day will equal the lunar month, both about 47 current days long. Earth and moon mutually tidally locked, the same face of Earth always pointing at the moon, the same face of moon always pointing at Earth. From one hemisphere of Earth you'd always see the moon hanging motionless in the sky. From the other hemisphere, You'd never see it. A strange future, alien, but it will never happen. The sun will die first, expanding into a red giant in about 5 billion years, long before mutual tidal locking occurs. Everything ends, but the mathematics describes what would have been. Ghost futures, dreams of physics, like your own future dreams tonight, scenarios that may never be, just possibilities, just neural noise, creating stories from randomness. One day, the moon will be too far away for total solar eclipses. Right now, we're in a golden age, the alignment perfect. But it's temporary, fleeting on geological timescales. In 600 to 700 million years, the moon's angular size will be slightly smaller than the sun's. Total eclipses will cease. Only annular eclipses will occur. A ring of sunlight around the moon's silhouette, still beautiful, but not the same. No corona, no totality, no diamond ring effect. Future beings, if any exist, will miss what we have now. This perfect moment in astronomical time when the moon fits exactly over the sun. A gift. Temporary, he's like consciousness itself. Temporary. Precious because it ends. But right now you're letting it end. Releasing wakefulness. Accepting the temporary darkness of sleep. Willingly. Gratefully. Thump. Thump. The moon is a time capsule. Its surface preserves 4 billion years of solar system history. On Earth, plate tectonics recycle the surface, weathering erodes, life disturbs. The oldest Earth rocks are about 4 billion years old, and they're rare. But the moon's surface is ancient, undisturbed, every impact recorded, every layer preserved. Reading the moon tells us what the early solar system was like. The late heavy bombardment, when asteroids and comets pummeled the inner planets. 3.9 billion years ago. Evidence written in lunar craters, in melt rocks, in breccias. The moon remembers what Earth has forgotten, holding memories in stone, like your own deep memories, childhood, infancy, stored somewhere in neural architecture, inaccessible, but still there, still shaping you, still present, buried, quiet. Lunar sample analysis continues to reveal surprises. Those 382 kilograms of rock and soil brought back by Apollo missions, and the samples from Soviet lunar missions, still yielding discoveries, new instruments, new techniques, analyzing isotopes that couldn't be measured in the 1970s, finding water molecules locked in glass beads, finding evidence of the moon's ancient magnetic field, dating tiny crystals to constrain the moon's age. Each sample contains multitudes, each grain a library. Scientists request tiny fragments, milligrams, to study with electron microscopes, mass spectrometers, ion probes, destroying minuscule amounts to learn vast things. And some samples remain unopened, sealed since 1972, waiting for future technology. Patient science. The moon can wait. It has waited 4.5 billion years. What's another few decades or centuries? Time moves differently for stone, for space, for the sleeping. Your own sense of time dissolving now, minutes feeling like hours, or hours like minutes, or time stopping entirely. Glass beads litter the lunar surface, created by impacts, rock vaporized, then condensed into droplets, spherules, cooling as they flew through vacuum, some microscopic, some millimeters across, green glass, orange glass, black glass. The composition depends on what was melted: mare basalt, highland anorthosite, mixed regolith. Apollo 17 astronauts found orange soil, shocking colour on the grey moon, tiny orange glass beads, volcanic fire fountain deposits, 3.64 billion years old, each bead a frozen moment, stone made liquid, then solid again, transformation preserved, like thoughts crystallizing into memories, experiences becoming stories you tell yourself, fluid made solid, then stored away, deeper, deeper into the archives of your mind, inside some glass beads. Scientists found water, and not liquid water, hydroxyl molecules, O, and molecular water, H2O, trapped when the glass formed, volcanic gases or solar wind hydrogen, locked inside during crystallization, a tiny amount, parts per million, but significant, evidence that the moon isn't completely dry, that water or its components exist in unexpected places, hidden, protected, waiting to be found, like insights hiding in your unconscious, truths you haven't accessed yet, waiting for the right moment, the right dream, to surface, to reveal themselves. Thump, thump. The moon's ultimate fate is uncertain. In 5 billion years, the sun will expand, becoming a red giant, its outer layers reaching perhaps to Earth's current orbit. The moon will be farther by then, spiraling outward, maybe 40 or 50,000 kilometers farther, but probably not far enough. Both Earth and Moon will likely be engulfed, vaporized, their atoms scattered, rejoining the cosmos, or if they survive, they'll orbit a white dwarf, the sun's cooling corpse, frozen, dark, no more sunlight to reflect, the moon invisible in eternal night. Either way, the dance ends, the partnership dissolved. 4 billion years of companionship concluded, but that's so far future it's almost meaningless. Unimaginable stretches of time. The moon will outlive every human, every civilization, every memory, will shine on long after we're gone, patient, eternal, uncaring. Or perhaps something else happens, perhaps humanity, or its descendants, or artificial intelligence, or whatever comes after. Perhaps they move the moon, engineers with million-year plans, adjusting orbits, maintaining the Earth-Moon system artificially, keeping the dance going, defying entropy. Or perhaps the moon is disassembled, mined completely, converted into habitats, spun into ring systems, transformed into something unrecognizable, the ultimate fate unknowable, because intelligence is unpredictable, because the future is unwritten, like your future, tonight, tomorrow, unknown. But right now, this moment, the moon is still there, still whole, still orbiting, and you're still here, still breathing, still sinking, heavier, heavier. The moon has been worshipped, feared, studied, visited, dreamed about. Every culture has moon myths, moon gods, moon stories. The inconstant moon, waxing and waning, a symbol of change, of cycles, of time passing. Calendars based on its phases, months named for moons, harvest moon, hunter's moon, wolf moon, strawberry moon, names connecting celestial mechanics to earthly life, to seasons, to survival, humans watching the sky, tracking patterns, finding meaning, the moon as calendar, as clock, as muse, inspiring poetry, music, art, werewolf legends, romance, lunacy, the moon in human consciousness, inseparable from human experience. Even now, in an age of science, of spacecraft and samples, the moon still moves us, still makes us look up, still makes us wonder, still pulls at something deep, some ancient recognition, some primal connection. Thump, thump. Future moon bases will need to solve radiation. The lack of atmosphere means cosmic rays, solar particle events, strike the surface unimpeded. Habitat walls need shielding. Meters of regolith piled on top or built underground in lava tubes. Natural caves formed by ancient lava rivers. Some tubes could be kilometers long, tens of meters wide, large enough for entire cities. Shielded by stone, protected, safe. Or habitats could use water as shielding, tanks surrounding living spaces, water stopping radiation while also serving as supplies, engineering efficiency, multiple purposes. But it all requires mass, material, either brought from Earth at enormous cost or mined locally. In situ resource utilization, making do with what's there, living off the land, like you're living off your body's reserves now. Energy stores feeding your sleeping brain, glucose burning slowly, keeping minimal systems running, everything else shut down, conserved, efficient. The moon's exosphere, so thin it barely exists, contains surprises, sodium, potassium, atoms lofted by meteoroid impacts, by sputtering from the solar wind. These atoms follow ballistic trajectories, mini-orbits, some escaping to space, others falling back. The sodium forms a tail, like a comet's tail, streaming away from the sun, pushed by radiation pressure, millions of kilometers long, visible except with special instruments. The moon leaving a trace, a signature written in atoms, across space. Like you leave traces, skin cells, exhaled breath, warmth in the sheets, evidence of your presence, fading, dissipating. But right now you're still here, still present, though fading, consciousness dimming, attention diffusing, spreading out like that sodium tail, thinning, nearly transparent. Meteoroid impacts on the moon create brief flashes, visible from Earth during meteor showers, when debris streams hit both Earth and Moon simultaneously. We see meteors burning in our atmosphere and impacts flashing on the moon, stone striking stone at 20, 30, 40 kilometers per second. Kinetic energy converting to light and heat. Telescopes monitor the moon during Leonids, Perseids, Geminids, counting flashes, measuring energies, each flash a small crater forming, more scars on ancient stone, more history written. The moon accepting all impact, passive, patient, its surface a canvas, a record, a testament to 4 billion years of cosmic bombardment. Your own body accepting impacts too, the day's stresses, held in muscles, in joints, but releasing now, letting go, softening, accepting rest, accepting peace. Thump, thump. The 2-week lunar day followed by 2-week night creates temperature extremes. In sunlight, 127 degrees Celsius. In shadow, minus 173 degrees. 300-degree temperature swings, more extreme than anywhere on Earth. Mercury's day-night difference is less, because Mercury rotates faster. Venus has no difference, its thick atmosphere distributing heat. Mars has moderate swings, thinner atmosphere but faster rotation. The moon's slow rotation, its lack of atmosphere, creates these extremes, baking, then freezing, endlessly cycling. But in permanently shadowed craters, it's always cold, and at the poles, on peaks that catch sunlight almost continuously, it's relatively stable. Extremes and moderation, light and dark, hot and cold. The universe loves dichotomies, loves balance, like waking and sleeping is winning now. Darkness spreading, cold settling, your metabolic fires banking, everything cooling, quieting. Ancient moon magnetism remains puzzling. How did such a small body generate a magnetic field? The dynamo theory requires a liquid metal core, convecting, rotating, but the moon's core is small. Did it convect efficiently enough? Was there some other mechanism, impact-generated fields, brief but intense? Or perhaps the young moon rotated faster, spun by Earth's tidal forces, creating conditions for dynamo action. Then as the moon slowed, tidally locked, the dynamo ceased. The magnetic field faded, leaving only remnant magnetization, fossils of ancient fields, locked in cooled lava, in impact melt. Evidence of something lost, like memories of early childhood. You know they existed, but can't access them. Just traces, suggestions, ghosts. Some lunar rocks show magnetic orientation suggesting the ancient field was comparable to Earth's current field. 50 microteslas or more, strong enough to deflect the solar wind to create a magnetosphere. The early moon might have had auroras, charged particles following field lines, glowing. Though in vacuum, auroras would look different. No atmospheric gases to excite, just the field itself, invisible, and then it vanished. The moon's interior cooled, solidified. The dynamo stopped. The field decayed. Within perhaps 500 million years it was gone, leaving the moon directly exposed to space, vulnerable, but also unchanged. Because there was nothing to change. No atmosphere to strip away, no water to evaporate. Just rock, accepting radiation, accepting impacts, silent, patient, eternal. The moon's south pole holds special interest. High ridges catch sunlight almost constantly, 80 to 90% illumination, eternal light. or near enough. Solar panels could generate power continuously, no 2-week nights, and nearby, permanently shadowed craters hold ice, water, hydrogen, oxygen, resources for life, for fuel. The South Pole offers both light and darkness, energy and matter, a perfect location for a base, for a colony, for humanity's next step, but also beautiful in its stark contrasts. Mountains of eternal light overlooking valleys of eternal shadow, extremes juxtaposed, like consciousness and unconsciousness, light and dark, and you're in the valley now, in shadow, in darkness. The light far above, unreachable, and you don't want to reach it anyway. The darkness is comfortable, safe, necessary. Thump, thump. Shackleton Crater, 21 kilometers across, 4.2 kilometers deep. Its rim catches almost constant sunlight. Its interior remains permanently shadowed. Scientists suspect significant water ice deposits, maybe 20% ice by mass in some locations, protected from sunlight for perhaps 2 billion years, accumulated from comets, asteroids, micrometeorites, and created by solar wind. Each impact delivering a little water, a little ice, building up, layer by layer, molecule by molecule, like memories accumulating or experiences layering, building a self, a history, an identity. But you're not that now. You're not your history, not your memories, just awareness, and barely that. Just being, just breathing, just drifting. The moon's receding changes Earth's climate, very slowly, over millions of years. As the moon moves away, its tidal pull weakens. Tides become smaller, ocean mixing decreases. This could affect ocean currents, the Gulf Stream, thermohaline circulation. Climate patterns might shift, but the effect is tiny, overwhelmed by other factors, by orbital variations, by continental drift, by atmospheric changes. The moon's influence fading gradually, imperceptibly, like how you don't notice yourself aging day by day, only realize years later you've changed. Time's arrow pointing always forward, never backward, carrying everything with it, including you, into sleep, into tomorrow, into the unknown future. Let it carry you. Stop resisting. Just float, drift, surrender. Scientists debate whether the moon's formation was more complex than the giant impact hypothesis suggests. Maybe multiple impacts, smaller ones, accumulating into the moon. Or maybe a different scenario entirely. A near miss, tidal disruption, Earth and Theia grazing, exchanging material, forming two moons that later merged. Evidence exists for multiple impacts, isotopic variations, orbital dynamics, but the giant impact remains the leading theory. One catastrophic collision, reshaping both worlds, creating the Earth-Moon system in fire and chaos, from violence, creation, from destruction, beauty. The universe doesn't distinguish, doesn't judge, just follows physics, follows gravity, follows quantum mechanics, everything mechanical, deterministic at large scales, probabilistic at small scales. And you're large enough to be deterministic, Sleep will come, must come. No randomness, just certainty, just biology, chemistry, physics, pulling you down, 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 heavier, heavier. The moon's influence on evolution is debated. Did tides created by the moon help life leave the oceans? Tidal pools concentrating nutrients, providing rhythm, training life for dry land? Or did the moon's stabilization of Earth's axial tilt create a stable climate, allowing complex life to evolve? Or is this all just storytelling, post hoc rationalization? Life might have evolved without the moon, differently perhaps, but still, we only know one Earth, one moon, one history, one timeline. Can't rerun the experiment, can't know what might have been. Just this, just now, just what is. And what is you lying here, breathing slowly, sinking, dissolving, becoming less defined, boundaries blurring. Where do you end and the bed begin? Where does awareness end and unconsciousness begin? The line is fuzzy, indistinct. You're crossing it, or already crossed. Thump, thump, thump. The universe keeps turning, stars forming, you're dying. Galaxies colliding, black holes merging, space expanding, carrying everything apart. The moon orbiting Earth, Earth orbiting the sun orbiting the galaxy falling through space, everything moving, nothing still. But from your frame of reference, from your bed, from this moment, everything feels still, quiet, motionless. The only movement is your breath, in, out, getting shallower, and your heartbeat, thump, thump, getting slower, and your thoughts, fewer now, simpler, just fragments, just impressions. The moon, floating, darkness, sleep, peace, nothing, letting go, releasing, melting into the mattress, into the room, into the darkness, becoming nothing, becoming sleep, and we'll keep drifting, floating together through the mysteries. The moon has no seasons. Its axis tilts only 1.5 degrees, barely anything compared to Earth's 23.5 degrees. So the sun always stays near the moon's equator, never climbing high in polar skies, never dipping low at the equator. No summer, no winter, no spring, no fall, just eternal sameness. The same sunlight angle, year after year, millennium after millennium. Only the 2-week day-night cycle marking time. Everything else constant, unchanging, like the deepest part of sleep, where time stops meaning anything, where there are no seasons, no days, no hours, just the eternal now, the timeless present, drifting, floating, suspended, thump, thump. Lunar caves and skylights have been discovered, collapsed lava tube ceilings, openings into underground chambers. The Japanese Kaguya spacecraft found them. Marius Hill's Hole, Mare Tranquillitatis Pit, Mare Ingeni Pit, dark voids descending into stone. Some might lead to vast underground networks, tunnels kilometers long, natural shelters already excavated by ancient lava, constant temperature, -20 Celsius, warm compared to surface extremes, protected from radiation, from meteoroids, from temperature swings. Future explorers might live underground in darkness, like cave dwellers on Earth, but on another world, returning to the cave, the womb, the dark, safe place. And you're in your own cave now. Blankets overhead, darkness surrounding, protected, safe. Your breathing echoing softly, the only sound getting quieter, quieter, fading. The moon's density is less than Earth's, 3.34 grams per cubic centimeter compared to Earth's 5.52, because the moon lacks a large iron core formed from Earth's mantle material, lighter silicate rocks. This lower density means the moon's interior composition differs from Earth's bulk composition. More crust, more mantle, less core, a world turned inside out. The heavy parts stayed with Earth. The lighter parts became moon, separated, divided, like consciousness separating from unconsciousness. The heavy settling down into sleep, the lighter rising, dissipating, fading away. Your body feeling heavy, your thoughts feeling light, everything finding its proper level, its equilibrium, its rest. Thump, thump, Mare Orientale, the eastern sea, though it's actually on the western edge of the near side, visible from Earth only during favourable libration, a spectacular multi-ring impact basin, 930 kilometres across, concentric rings of mountains, like frozen ripples in stone. The impact occurred about 3.8 billion years ago, during the late heavy bombardment, a massive asteroid or comet strike, excavating deep, throwing up mountain ranges. The outer ring is the Cordillera Mountains, rising 6 kilometers above the surrounding terrain. Then the Rook Mountains. Then the inner depression partly filled with solidified lava. Rings upon rings, circles upon circles, like ripples spreading from a stone dropped in still water, but frozen, permanent, a moment of violence preserved for billions of years. You can see similar patterns behind your eyelids, phosphonies creating rings, circles, spirals, your visual cortex generating noise, interpreting it as pattern, hypnotic patterns, drawing you deeper, deeper into the center, into stillness. The moon has swirls of lighter colored terrain, sinuous bright markings. Rhina Gamma is the most famous, in Oceanus Procellarum, bright lanes meandering across the dark mare. No topographic relief, just albedo differences, brightness variations. These swirls correlate with magnetic anomalies. Perhaps the magnetic fields deflect solar wind, preventing space weathering, keeping regolith brighter. Or perhaps the fields attract fine dust electrostatically, creating patterns. No one knows for certain. Just another mystery, another unanswered question. The moon holds many, probably always will. Some things resist explanation, resist understanding, like dreams. You can describe them but never quite capture them, never quite explain why. Just accept the mystery, accept the not knowing. Let it be, like letting sleep be, not analysing it, not questioning, just accepting, surrendering. Thump, thump. Lunar soil is jagged at microscopic scales. No weathering to smooth the particles. Each grain has sharp edges, points and blades. The regolith clings to everything. Static electricity, mechanical interlocking. Astronauts found it invasive, getting into joints, seals, mechanisms, abrasive, like fine sandpaper. It wore through layers of Kevlar on boots, several millimeters of wear in just a few days. Future missions will need better materials, better seals, better design, because the dust is unavoidable. It's everywhere, coating everything, getting into habitats despite precautions, a constant challenge. But also just the nature of the place. The moon is dust, ancient pulverized stone. You can't fight it. Just adapt, accommodate, accept, like accepting sleep, not fighting it, not resisting, just letting it coat you, cover you. Gentle pressure, soft weight, sinking down, heavier, heavier, buried in comfort, in darkness, in peace. The Aristarchus Plateau is one of the most geologically diverse regions. Highlands, maria, volcanic features, pyroclastic deposits, sinuous rills, all concentrated in one area. Aristarchus crater itself is the brightest feature on the moon, only 450 million years old, relatively recent. Its rays extend far across Oceanus Procellarum, and nearby, Valles Schroetteri, the largest sinuous rill, a winding channel carved by ancient lava, 160 kilometers long, 10 kilometers wide in places, called Schroetter's Valley, beginning at a cobra head source, a volcanic vent, then meandering, braiding, finally fading, a river of stone that once flowed, now frozen, silent, like your thoughts flowing, meandering, but slowing now, narrowing, fading, until they stop, until there's just silence, just darkness, just the void. Moondust glows at the terminator with the boundary between day and night. Astronauts in lunar orbit observed it, a faint glow hovering above the horizon. Levitated dust. Sunlight ionizes particles on the day side. They become positively charged. On the night side, electrons from the solar wind charge particles negatively. At the terminator, where day meets night, electric fields form, strong enough to levitate dust, lifting it meters above the surface, creating a faint atmospheric glow, called horizon glow, a thin haze of suspended particles, not atmosphere, just electrically charged dust, floating, hovering, between light and dark, like you floating between wake and sleep, suspended in the terminator of consciousness, neither fully one nor the other, just hovering, drifting, thump, thump. The lunar laser ranging experiment continues. Scientists fire laser pulses at the retroreflectors left by Apollo missions and by Soviet lunar missions, timing the return precisely, measuring the distance to millimeter accuracy. This is how we know the moon recedes 3.8 centimeters per year, how we test general relativity, how we study the moon's interior, detecting subtle wobbles, measuring libration precisely. Data accumulated for over 50 years now. Billions of photons sent. A tiny fraction return, maybe 1 photon per pulse, but enough to measure, to learn, to understand. Patience, precision, persistence, light travelling there and back, 2.5 seconds. You could count it. 1, 2, but you won't. You're not counting anything now. Numbers meaningless and time meaningless and just existing, just being, just breathing. In, out, so slow, so shallow, barely there. The Apollo missions collected 2,415 samples, individual rocks, core samples, soil, representative of 6 different sites, each site chosen for scientific diversity, different terrains, different ages, basalts from Maria, anorthosites from highlands, breccias, impact glasses, pyroclastic deposits, each sample numbered, catalogued, photographed in place before collection, documented exhaustively, because you can't go back, can't collect more from the same spot. Every sample precious, irreplaceable. Most are stored in nitrogen, some in helium, some never opened, waiting, preserved, and scientists request tiny amounts, milligrams, to study. Using techniques that didn't exist in 1972, learning new things from old samples. The rocks are patient. They've waited 4 billion years. They can wait a bit longer, like sleep waiting for you. Always patient, always there, and you're finally accepting the invitation, finally stopping the resistance, finally letting go. Thump, thump. Mare Crisium, the Sea of Crises, is a circular impact basin on the northeastern limb, visible from Earth as a dark oval. Due to foreshortening, it appears oval even though it's roughly circular, 555 kilometers in diameter, filled with basaltic lava, 3.9 to 2.5 billion years old. Mare Crisium is one of the few Maria on the far side limb, visible from Earth during favourable libration, a window into the far side. From Luna 24, the Soviet sample return mission, we have samples from here. The only far side samples returned to Earth before Kangi missions. Dark stone, Mare basalt, evidence of volcanic flooding, of a past when the moon was active, molten, alive, now frozen, silent. All activity ceased, like your body's activity ceasing. Muscles relaxing completely, no tension, no movement, just stillness, perfect stillness. Your body like ancient basalt, cool, solid, heavy, at rest. The albedo of the moon, its reflectivity, varies across its surface. Fresh craters are bright, 30 to 40% reflectance. Ancient surfaces are dark, weathered by space, 7 to 12%. The highlands average 12%. Maria average 7%. Overall, the moon reflects 12% of incident light, dark compared to clouds, to ice, to snow. Clouds reflect 60 to 90%. Fresh snow reflects 80 to 95%. The moon is more like charcoal, like asphalt, dark stone. It only seems bright because it's surrounded by the black of space, because your eyes adjust, because contrast deceives, like how the smallest light seems bright in deep darkness. Your room is dark now, maybe a little light seeping in, around curtains, under doors, but mostly dark, and getting darker. your eyelids blocking even that tiny light, creating perfect darkness. And in that darkness, consciousness fades, awareness dims, everything going black, soft black, velvet black, comfortable, safe, infinite. Thump, thump, thump. The moon's exosphere, its tenuous atmosphere, changes with time of day. During lunar day, sunlight strikes the surface. Atoms are released. Helium from radioactive decay, argon from the same, sodium and potassium from meteoroid impacts. These atoms bounce around, following ballistic trajectories, some escaping to space. During lunar night, the exosphere thins. Atoms freeze to the surface or drift away. The density is incredibly low, 100 atoms per cubic centimetre at the surface. Compared to Earth's atmosphere, 1 trillion atoms per cubic centimetre. The moon's exosphere is essentially vacuum, nearly nothing, so thin it's negligible, barely exists. Like your thoughts now, so thin, so sparse, barely existing, nearly nothing, almost gone. Just wisps, fragments, fading, dissipating, disappearing into void. Ancient volcanic glass found on the moon comes in colours: green, orange, red, brown. Each colour representing different composition, different source materials. The orange soil from Shorty Crater, Apollo 17 site, tiny glass beads, 40 microns across, formed in a fire fountain eruption 3.64 billion years ago. Lava spraying into vacuum, droplets cooling as they fell, raining glass on the ancient moon, the green glass from Apollo 15, different composition, different eruption, each colour a snapshot of ancient volcanism, of different magma chemistries, of different moments frozen in time, beautiful in microscopic scale, translucent spheres, coloured jewels scattered in grey dust, hidden beauty, waiting to be found, like insights hidden in your unconscious, waiting for the right dream to bring them up, to make them visible. But tonight, no insights needed, no revelations, just sleep, just rest, just letting everything settle, everything quiet, everything still. Thump, thump. Impact melt from large craters creates sheets of once molten rock. The energy of collision, kinetic energy converting to heat, melting vast quantities of material. This melt flows, pools in low areas, then solidifies, creating impact melt sheets, some are kilometers thick, cooling slowly, forming coarse crystals, similar to igneous intrusions on Earth, but formed by impact instead of volcanism. The Oriental Basin has extensive impact melt, the Imbrium Basin, the Serenitatis Basin, ancient violence creating new rock, destruction and creation simultaneous, the universe transforming, recycling, nothing truly created or destroyed, just rearranged, just transformed, like your consciousness transforming now, from wake to sleep, not destroyed, just changed, rearranged into different patterns, different configurations, thoughts becoming dreams, awareness becoming unconsciousness, the same mind, just transformed, just different. Thump, thump, the moon's terminator, The shadow line between day and night shows the most dramatic terrain. Long shadows, high contrast, mountains casting shadows hundreds of kilometers, crater walls sharp in relief. When the Terminator crosses a feature, shadows lengthen, detail emerges. Then the sun climbs higher, shadows shrink, detail fades. The best time to observe a feature is when the Terminator crosses it. Maximum relief, maximum drama. Then it fades back into the bright sameness, or the dark sameness. Depending on phase, everything visible depends on lighting, on angle, on perspective. Like how you see yourself differently depending on mood, on context, on the light you're in. But in darkness, all things are equal. All details fade. Everything becomes uniform. And you're in darkness now. Internal darkness. The Terminator of consciousness is past. The light faded. Just shadow now. Just night. 2-week night. Deep sleep coming. Here. Thump, thump. Lunar meteorites on Earth. Pieces of the moon. Blasted off by impacts. Orbiting the sun. Eventually intersecting Earth's orbit. Falling as meteorites. Over 300 have been found. Mostly in Antarctica, in hot deserts, where they're easy to spot. Dark stones on ice or sand. Analysis shows they match lunar samples. Same oxygen isotope ratios, same compositions, but from unknown locations. Random sampling. Pieces from anywhere on the moon, maybe far side, maybe poles, regions we've never visited. Nature doing sample return for free, though without context, without knowing where they came from. Their scientific value is limited. Still, they're pieces of the moon, fallen to Earth, travelled millions of kilometres, millions of years, returning home in a sense, like you returning to sleep, to the unconscious, to the place you came from this morning, cycling, returning. Everything cycles, everything returns. Thump, thump. The moon's gravity field is lumpy, not uniform. Mass concentrations under Maria, mascons, create stronger gravity in those spots. Weaker gravity over highlands. This affects spacecraft orbits, pulling them off course. Early lunar orbiters experienced unexpected orbital decay, crashes into the moon, before mascons were understood. Now they're mapped, compensated for, but they make low lunar orbit unstable, difficult to maintain. Most lunar orbits need periodic adjustments, burns to counter the perturbations, or they naturally evolve, change shape, eventually crash. Nothing in lunar orbit is permanent, not without active maintenance, like consciousness. It requires effort, energy. Without that, it fades, collapses, returns to the default state, sleep, unconsciousness, the ground state. And you're returning there now, the effort ending, the maintenance stopping, just letting gravity pull you down, into the mascon of sleep, into the heavy center, irresistible, inevitable. Thump, thump. Future missions plan to use lunar resources, in situ resource utilization, making oxygen from regolith. Lunar soil is 40% oxygen by mass, locked-in minerals, but it can be extracted, heating regolith with hydrogen or electrolysis, breaking chemical bonds, freeing oxygen. It takes energy, solar power or nuclear, but the oxygen is there, abundant, enough for breathing, for fuel. Water ice at the poles can be split, electrolysis again, hydrogen and oxygen, rocket propellant. The moon could be a refueling station for missions to Mars, to asteroids, to deep space. Using lunar resources instead of launching everything from Earth. The moon as stepping stone, as gas station, as supply depot, but that's future, possibility, potential. Tonight the moon is just the moon, silent, patient, waiting as it always has, and you're just you, breathing, existing, fading, not building anything, not planning anything, just being, just sleeping, almost sleeping. So close now, so close. Thump, thump, thump. The universe expands, space itself stretching, galaxies receding, everything moving away from everything else. But locally, gravity dominates, Earth and Moon bound together, the Milky Way and Andromeda approaching, local group gravitationally bound. On small scales, gravity wins. On large scales, expansion wins. The universe's fate, heat death, big rip, big crunch, unknown, unknowable, beyond prediction. The equations suggest heat death, eternal expansion, cooling, thinning, until stars burn out, black holes evaporate, even atoms decay. Everything ending in cold, dark, quiet, maximum entropy, perfect equilibrium. But that's trillions of years away. Unimaginable time. Tonight the stars still shine. The moon still orbits. And you still breathe. Still exist. Still sink into sleep. Personal entropy increasing. Organization decreasing. Thoughts scattering, dissolving, returning to noise, to randomness, to chaos. But comfortable chaos. Peaceful dissolution. Letting go. Releasing. Melting. Drifting. Gone. Thump. Thump. And we'll keep drifting. Floating together through the mysteries. When Apollo astronauts set up seismometers, they discovered something strange. After deliberately crashing lunar modules and rocket stages into the surface, the moon rang like a bell, vibrations continuing for over an hour. On Earth, seismic waves dampen quickly, absorbed by water, by fractured rock. But the moon is dry, cold, dense. The vibrations echoed through it, reverberating. A hollow sound, some thought, though the moon isn't hollow, just different. Ringing, ringing, softer now, fading like consciousness fading. Thump, thump. Between 1969 and 1972, 12 humans walked on the moon, Apollo 11 through 17, except 13, which never landed. They explored 6 sites, each carefully chosen, different terrains, different ages. Mare Tranquillitatis, Oceanus Procellarum, Fra Mauro, Hadley Rila, Descartes, Taurus Littrell. Each crew collected samples, set up experiments, left footprints that remain, because there's no wind to erase them, frozen moments, preserved forever. like memories crystallizing as you drift towards sleep. The astronauts left retroreflectors, panels of special mirrors that reflect laser beams directly back to their source. Scientists on Earth fire lasers at these reflectors, timing how long light takes to return, measuring the distance to the moon within millimeters. This is how we know the moon recedes 3.8 centimeters per year, by watching, measuring, year after year, light traveling there and back, 2.5 seconds, while your thoughts travel slower, heavier. The Soviet Union never landed cosmonauts on the moon, but their robotic lunar missions achieved remarkable things. Luna 2 was the first human-made object to reach the moon in 1959, impacting the surface. Luna 3 photographed the far side for the first time, showing us what had been hidden. Luna 9 made the first soft landing, and Luna 16, 20, and 24 returned samples to Earth, robotic arms scooping regolith, launching it home. No humans needed, just machines, patient, precise, working in silence. China's Chang'e missions have continued lunar exploration. Chang'e 4 made the first landing on the far side in 2019. In that radio-quiet environment, shielded from Earth's electromagnetic noise, instruments listen to the universe, studying the cosmic dark ages before the first stars formed. Radio telescopes on the far side could detect faint signals impossible to hear from Earth, whispers from the infant universe. So quiet, so distant, like the whisper of your breath now, barely audible. The Artemis program aims to return humans to the moon, landing near the South Pole, establishing a sustainable presence. Astronauts will stay longer, explore more, utilize lunar resources, in situ resource utilization, making oxygen from regolith, extracting water from ice, living off the land. A new world becoming home, but that's future, tomorrow, distant. Right now there's only tonight, only this moment, drifting. Living on the moon would be strange, dangerous. The lack of atmosphere means no protection from radiation, galactic cosmic rays, solar particle events. Habitats would need thick shielding, or be built underground in lava tubes, or covered with regolith, meters of lunar soil piled on top, pressing down, like your blanket pressing down, heavy, protective, safe. The lunar day lasts 2 Earth weeks, followed by 2 weeks of night. Temperature extremes beyond imagination. In sunlight, 127 degrees Celsius, hot enough to boil water. In shadow, minus 173 degrees Celsius, cold enough to freeze carbon dioxide. Habitats would need powerful heating and cooling, managing these extremes, while you need nothing, your body regulating itself, cooling slightly as you sleep, thump, thump, matching the rhythm of slow time, mining the moon, extracting resources. Sounds like science fiction, but becomes more practical with each mission. Oxygen locked in minerals, metals for construction, rare earth elements, helium-3 for future fusion. The moon could become a resource base, a stepping stone to deeper space, or remain untouched, pristine, a natural monument, Time will tell, but time is slow on the moon, so slow, like your perception of time now, stretching, thinning, dissolving. The far side of the moon is radio silent. Earth's bulk blocks all radio signals from our planet, a perfect location for sensitive radio astronomy. A lunar radio telescope, far from interference, could detect the faint radio whispers from the cosmic dark ages, the epoch between the Big Bang's afterglow and the first stars, frequencies we cannot study from Earth, secrets waiting in the silence, deep silence, like the silence filling your room, filling your mind. The moon's gravity isn't uniform. Large mass concentrations, mascons, exist beneath some maria, dense basaltic lava, or fragments of the impactors that created the basins. These gravitational anomalies perturb spacecraft orbits, pulling them slightly off course. Early lunar orbiters were puzzled by these invisible tugs, now mapped, understood, but still subtly influencing everything in lunar orbit, like invisible currents in the ocean of space, currents pulling you deeper, deeper into sleep. The moon has almost no atmosphere, just a tenuous exosphere, so thin it's barely there. Atoms of helium, neon, hydrogen, argon, so diffuse that atoms never collide, each following its own ballistic trajectory. Some atoms escape to space, others are replaced by solar wind, or by radioactive decay of elements in the regolith, an atmosphere you could never breathe, never feel, nearly nothing. Like the thoughts in your mind now, nearly nothing, fading. Surprisingly, the moon has a sodium tail, sodium atoms lofted from the surface by meteoroid impacts and solar radiation. These atoms stream away from the sun, pushed by light pressure, creating a faint tail millions of kilometers long, invisible to the unaided eye, but detectable with instruments. The moon leaving a trace across space, while you leave no trace in sleep, disappearing into darkness. Meteoroids constantly strike the moon. Without atmosphere to burn them up, every pebble, every grain hits at full cosmic velocity, kilometers per second, vaporizing on impact, creating tiny flashes. These flashes have been observed from Earth, brief sparks, especially during meteor showers when debris streams hit the moon and Earth simultaneously. Light and heat from ancient stone, ending in an instant. Thump, thump, your pulse marking time. The temperature difference between lunar day and night is extreme. During the 2-week day, the surface bakes. At night it freezes. No atmosphere to retain heat, no winds to distribute warmth. Each point on the surface swings between extremes, except in permanently shadowed craters, where it's always cold, always dark, and near the poles, where some peaks catch sunlight almost constantly, peaks of eternal light, while valleys remain in eternal shadow. Light and dark, hot and cold, extremes, while you rest in the narrow, comfortable range, your bedroom, your bed, perfectly balanced, perfectly still, because there's no atmosphere, there's no weather on the moon, no clouds, No rain, no wind. The sky is always black, even in daytime. Stars visible alongside the sun, if you could look without being blinded. A changeless sky, eternal, patient. The only changes are shadows moving as the sun crosses the sky. Over 14 Earth days, so slow you'd never see it move. Just notice it's different. Hours later, like sleep, you never catch the moment you fall. You just realize you're already dreaming. Ancient moon rocks reveal something unexpected. Remnant magnetism, locked into minerals. Evidence that billions of years ago the moon had a magnetic field, possibly generated by a liquid metal core. Dynamo action, like Earth's magnetic field today. But the lunar dynamo ceased. The core cooled, solidified, and the magnetic field faded, leaving only frozen memories in stone. Magnetized crystals pointing to a field that no longer exists. Ghosts of the past, like memories surfacing as you drift, then sinking back into darkness. Some regions still show weak magnetic anomalies, possibly from ancient lava flows, or from impacts that created intense but brief magnetic fields. These magnetic anomalies might deflect the solar wind slightly, creating tiny sheltered regions. Not protection, just curiosities. Variations in an otherwise exposed surface. Your own mind creating variations now. Dream images beginning to form, fragmentary, strange. Cultures around the world have woven the moon into their myths. A goddess, a god, a rabbit pounding rice, a face, the man in the moon, calendars based on lunar phases, months tracking the moon's cycle, month and moon sharing the same linguistic root. The Islamic calendar is purely lunar, 12 lunar months, shorter than a solar year. So holy days drift through the seasons. The Hebrew calendar, Chinese calendar, add extra months to stay synchronized with seasons. Lunisolar, balancing moon and sun, like balancing wake and sleep. And sleep is winning now. The moon influences human circadian rhythms. Or does it? Studies conflict. Some suggest the full moon disrupts sleep slightly. Others find no effect. Confirmation bias, selective memory. We notice when we sleep poorly during a full moon. Forget the countless full moons when we slept fine. The moon may tug on our water, our bodies, but the effect is vanishingly small, more psychological than physical. Still, the folklore persists. Werewolves, lunacy, moon madness, the moon affecting behavior, mood. Though tonight it only helps you sleep, gently, deeply, thump, thump. Animals do respond to lunar cycles. Sea turtles emerge to lay eggs during full moons. Corals spawn in sync with lunar phases. Nocturnal animals adjust activity based on moonlight. Predators hunt better when it's bright. Prey hide more carefully. The moon orchestrating life, conducting, though the musicians are unconscious of the conductor, like your body conducting itself now, breathing, heart beating, digesting, all without your awareness, automatic, ancient, perfect. The moon illusion, That phenomenon where the moon appears larger near the horizon than high overhead is just an illusion. The moon doesn't change size, but your brain interprets it differently, comparing it to trees, buildings, landscape features, the Ponzo illusion, depth perception tricks. What feels bigger is actually the same. Perception versus reality. Like the feeling that you're still awake when really you're already halfway into sleep. The boundary blurring, dissolving. The moon's orbit is more complex than a simple ellipse. Earth's equatorial bulge perturbs it. The sun's gravity pulls on it. Jupiter's distant tug affects it slightly. The orbit precesses, its orientation rotating. The ascending node, where the moon crosses the ecliptic plane heading north, moves westward, completing a circuit in 18.6 years. This causes slight variations in tides, in eclipse patterns, in moonrise positions, complexity within regularity, chaos within order, like your sleeping brain, following patterns but never quite repeating exactly. Lunar orbit perturbations were studied intensely. Isaac Newton used the moon's motion to test his theory of gravity, finding discrepancies. The one problem that made his head ache. Later mathematicians refined the calculations, including more factors, more interactions. The three-body problem, Earth, Moon, Sun, has no perfect solution, only approximations, getting better and better, infinitely close but never exact, like describing the moment you fall asleep, infinitely close, but always just out of reach. The moon is Earth's only natural satellite. Some planets have dozens, some have none. We're lucky, or perhaps not luck, perhaps necessity. The moon stabilizing Earth's climate, moderating our tilt, slowing our rotation to a comfortable day length, making Earth more habitable. Maybe life needed the moon. Or maybe we only think so because we evolved with it. Either way, it's there, always there, watching, silent, thump, thump. Scientists have proposed capturing asteroids to orbit Earth, creating artificial moons, or construction of massive space stations, O'Neill cylinders, Stanford Torrey, rotating habitats at the L4 and L5 Lagrange points, where Earth's and Moon's gravity balance, stable parking spots. But these are human creations, temporary, fragile. The moon is eternal, or nearly so. It will outlast humanity, still circling, still reflecting sunlight, long after we're gone. Deep time, geological time, astronomical time, and you're sinking into personal time, dream time, where minutes are hours, or hours are seconds, or time stops meaning anything. The Apollo astronauts described the moon's surface as magnificent desolation, beautiful in its starkness, its alienness. No life, no water, no air, just stone and dust and shadow. And yet, not hostile, just different. A place that doesn't care. The universe doesn't notice you, doesn't judge, and that's oddly comforting. You can let go, stop performing, stop worrying, just be like a rock on the moon, existing. Nothing more required. Heavier, heavier. Dust on spacesuits was a problem. It got everywhere. into seals, joints, scratched faceplates. The astronauts said it smelled like gunpowder when they brought it inside. Spent firearms, a burnt metallic smell. On Earth, lunar dust is oxidized and inert, but in lunar vacuum, the surface of each grain is chemically active, reactive, like your mind is reactive to stimuli during the day, but passive now, receptive, quiet. Future moon explorers will need to manage dust carefully, airlocks to brush it off, charging systems to repel it electrostatically, because the dust is so fine, so sharp, it could damage equipment, lungs if inhaled. A challenge, but solvable. Humans are good at solving problems, engineering solutions. But tonight, your only task is to let go. Stop solving. Stop trying. Just drift. The moon moves 12 degrees across our sky each day, shifting eastward against the background stars, which is why it rises about 50 minutes later each night. That shift, that drift. If you watched carefully, night after night, you'd see it walking through the constellation, through the zodiac, taking a month to return. But you're not watching. Eyes closed, attention turned inward, following your breath. In, out, slower, slower. Selenology, the study of the moon, from Selene, the Greek goddess, sister of Helios the sun. In myths she drives her chariot across the night sky, pulled by horses or oxen, depending on the telling. Now we know there's no chariot, no goddess, just physics, gravity, momentum. But the name remains, and the wonder. Looking up at the moon, humanity has always wondered, felt pulled, felt connected. Thump, thump. The moon's surface area is about 38 million square kilometers, roughly the same as Africa, or the combined area of North and South America, an entire world of terrain, mountains and valleys, craters and plains, and we've explored only a tiny fraction, 6 landing sites, each only a few square kilometers. So much remains unknown, unseen, waiting, like the parts of your mind you never examine, vast unconscious territories, and you're sinking into them now. Some craters have central peaks, mountains at their centers, material that rebounded after impact, splashing up like a drop falling in water, frozen mid-splash. These peaks can be kilometers high, and some catch sunlight even when the surrounding crater floor is dark. Islands of light in seas of shadow. Your own consciousness like that. Points of awareness in the gathering dark, but fewer now, dimming. The South Pole Aitken Basin is the largest known impact crater in the solar system, 2,500 kilometers across, 13 kilometers deep on the far side. An ancient collision, perhaps 4.3 billion years ago, exposing deep crustal and upper mantle material. Studying this basin tells us about the moon's internal structure, its differentiation, its history, layers of time compressed into stone, like layers of memory compressed in your mind, oldest at the bottom, buried, unreachable except in dreams. Tycho crater, bright and prominent, formed relatively recently, just 108 million years ago, when dinosaurs walked the earth. Young by lunar standard, its rays extend over 1,500 kilometers. Bright splashes of excavated material, higher albedo than the weathered surrounding surface, space weathering, micrometeoroid bombardment, slowly darkens exposed rock over billions of years, breaking it down, pulverizing, creating regolith, time grinding everything to dust. But there's no hurry. Time moves slowly on the moon, and slower still in sleep. Thump, thump. Aristarchus crater is the brightest spot on the moon. Young, reflective, about 450 million years old. It sits in Oceanus Procelarum, bright against dark. This region has more reported transient lunar phenomena than anywhere else. Glows, color changes. Observers centuries ago saw reddish spots. Called them moonburns. Most likely outgassing, radon escaping from deep below, ionizing the thin exosphere, creating faint glows, or simply tricks of seeing, atmospheric distortion, imagination, but recorded, noted, part of the mystery. Earthshine, that phenomenon where you can see the dark part of a crescent moon faintly illuminated, is sunlight reflected off Earth onto the moon, then back to us, light bouncing twice. Earth's oceans and clouds reflect well, making our planet bright in the lunar sky. Astronauts on the moon would see Earth shining, 4 times brighter than the moon appears to us, and always in the same spot in the sky because of tidal locking, never rising, never setting, just hanging there, blue and white, swirling with life. Thump, thump, but you're not there. You're here, sinking deeper. The moon has been moving away from Earth since its formation. That dramatic difference. Early on it orbited at 20,000 kilometers. Now 384 soon 400. Eventually, billions of years from now, it will reach a stable distance when Earth's day equals the lunar month. Both bodies mutually locked, the same face of Earth always facing the same face of Moon. But that's perhaps 50 billion years away, and the sun will have expanded into a red giant long before then, consuming Earth and Moon both. Everything ends, but slowly, so slowly, and right now, tonight, the moon still hangs in the sky, and you still breathe, in, out, existing in this moment, this eternal moment. The moon influences Earth's climate subtly. Tides create currents, mixing ocean layers, distributing heat. The lunar pull on the atmosphere, though tiny, may influence weather patterns. Hard to detect, hard to prove, but remove the moon, and Earth would be different. How different? Hard to say. Models conflict, but perhaps rainier, perhaps more extreme. Perhaps life would never have emerged, or perhaps it would have thrived. We only know the world with the moon, this world, this reality, where you lie in darkness, breathing, drifting. No human has set foot on the moon since 1972. Over 50 years, half a century. Flags left behind have been bleached white by unfiltered sunlight, UV radiation breaking down the dyes. Footprints remain sharp. Abandoned equipment sits where it was left. The lunar module descent stages, Rovers, experiments, all still there. Museums under vacuum, perfectly preserved, or slowly degrading from thermal cycling, expansion and contraction, microfractures spreading. Either way, unchanged by wind or rain because there is none. Time passing differently. Thump, thump, your own time slowing, stretching. Plans to return to the moon cycle through political priorities. Budgets shift, schedules slip, but eventually humans will go back, perhaps to stay, perhaps to build cities, rotating sections generating artificial gravity, or underground in lava tubes, protected from radiation and temperature extremes. Hydroponics growing food, 3D printers fabricating tools from regolith, slowly, patiently, making the moon home, but maybe not. Maybe the moon remains untouched, a monument to where we went once, where we might go again. Future uncertain, but the moon waits, patient, eternal. Some propose the moon as a genetic backup, storing DNA, seeds, embryos in cold, dark craters, insurance against extinction. If Earth is destroyed, the moon remembers, though who would retrieve the backup? Unclear. Still, the idea persists, the moon as library, as vault, as time capsule, holding humanity's legacy, even after we're gone, sleeping, dreaming, preserved in ice. The colour of the moon is grey, not white, though we often think of it as bright. Its albedo is only about 12%. It reflects just 12% of the light hitting it. Charcoal is darker, fresh asphalt is similar. The moon only seems bright because it's surrounded by the black of space and because our eyes adjust to darkness. Contrast makes it glow, like how a small lamp seems bright in a dark room. But objectively, the moon is dark stone, catching a fraction of sunlight, offering it back, quietly, gently, like a whisper in the night. Lunar swirls, strange bright markings, meander across some regions, especially on the far side. These swirls are associated with magnetic anomalies. Perhaps the magnetic fields deflect the solar wind, preventing space weathering, keeping the regolith brighter. Or perhaps the fields attract fine dust particles, creating patterns. No one knows for certain. Just another lunar mystery, unexplained, like the mysteries of your own mind. Why you think what you think, feel what you feel, most of it hidden, unknown even to yourself. The Lunar Reconnaissance Orbiter, still circling the moon, mapping it in extraordinary detail, photographing the Apollo landing sites, seeing shadows of equipment left behind, tracks where rovers drove, proof we were there, if proof were needed. Its cameras can resolve features smaller than a meter, reading the moon's surface like a book, page by page, line by line, learning its history, its composition, its secrets. But there are always more secrets, deeper mysteries, and maybe some things are meant to stay mysterious, unknown, like the boundary between waking and sleep. You're crossing it now, or already crossed, can't tell. The moon's gravity creates Earth's tidal bulge, But that bulge doesn't point exactly at the moon. Earth's rotation drags it ahead, friction from water flowing over ocean basins. And this misaligned bulge pulls on the moon, accelerating it in its orbit, which makes it climb higher, spiraling outward. Newton's third law, every action has a reaction. The moon pulls Earth's tides push the moon away. Mutual influence, mutual change, over eons. Thump, thump, your heartbeat and breath influencing each other, slowing together, synchronized, harmonized. Ancient eclipse records help us understand how Earth's rotation has changed. Babylonian observations, Chinese records, Arab astronomers, noting eclipses at specific times, comparing those to calculations. Scientists determined that days were shorter in the past. The moon was closer. Tidal friction has been slowing us, lengthening our days. 1.7 milliseconds per century, barely perceptible, but over millions of years, significant, deep time where small changes accumulate into transformations, like how small moments of relaxation accumulate into sleep. Almost there now. Almost. The moon has no global magnetic field, but localized anomalies create mini-magnetospheres, tiny bubbles protecting small regions from the solar wind. These don't affect human-scale things, but at microscopic level they influence how the regolith weathers, creating variations, patterns, differences too subtle to see but measurable with instruments. The universe is filled with such subtle influences, invisible forces, like gravity pulling you down into the mattress, down into sleep, imperceptible but undeniable. Lunar samples brought back by Apollo, 382 kilograms total, are still being studied. New technologies reveal details impossible to see decades ago. Tiny zircon crystals, nanodiamonds, isotopic ratios, each sample a library, each grain a paragraph. Reading the history of the solar system, some samples remain sealed, unopened, save for future scientists with better tools. Patient science. The moon can wait. It's good at waiting. It's been waiting 4.5 billion years. What's a few more decades? Time doesn't mean the same thing to stone or to the sleeping thump, thump. Earth and moon share a gravitational bond, but also a chemical connection. Isotopic ratios in lunar and Earth rocks are nearly identical, supporting the giant impact hypothesis. The moon formed from Earth's mantle, torn away, then reassembled. Family, siblings, made of the same material. Looking at moon rock is looking at Earth's deep interior, brought up and out, scattered across another world, pieces of home, 384,000 kilometers away, but always connected, always in orbit, always dancing. If you were standing on the moon, Earth would hang in the sky, 4 times larger than the moon appears from Earth, and it would go through phases. New Earth, crescent Earth, full Earth, exactly opposite to the moon's phases. When we see a new moon, an observer on the moon would see a full Earth, bright, blue, alive. But you're not on the moon. You're in bed, under gravity, under blanket, heavy, comfortable, safe. and the moon is above, doing what it's always done, reflecting, orbiting, waiting, the far future, billions of years. The sun will expand, becoming a red giant, swelling to perhaps Earth's current orbit. The moon will be vaporized, unless it spirals outward fast enough, escaping, but probably not. Probably both Earth and moon will end, consumed by the dying sun, all traces erased. The universe continues, uncaring, creating new stars, new planets, maybe new moons, the cycle repeating endlessly. Birth and death, light and dark, sleeping and waking, but mostly sleeping now, deeper, deeper. The moon may have had a thicker atmosphere briefly after formation, when it was molten, outgassing, but it leaked away into space. The moon's gravity too weak to hold it. Only 1/6 Earth's gravity, not enough. Like trying to hold water in your hands, it slips through. The atmosphere escaped, leaving vacuum, silence. The way your thoughts are escaping now, slipping away, leaving silence, empty, peaceful silence. Some of the moon's craters are perfectly circular, impact straight down. Others are elliptical, oblique impacts from angles. The physics of hypervelocity impacts. Strange, counterintuitive. Even glancing blows create nearly circular craters because the projectile vaporizes, acts like an explosion, symmetrical. Exceptions exist, very shallow impacts. But most craters are round, ordered, geometric, like the patterns behind your eyelids, mandalas of darkness, spiraling, geometric, hypnotic. The universe keeps turning, the moon keeps orbiting, Earth keeps spinning. All the mechanics, all the forces, gravity and momentum, angular motion and tidal friction, playing out on timescales beyond human comprehension. And you're part of it, a collection of atoms, arranged temporarily into awareness, experiencing this moment. But the atoms don't care. They've been here billions of years. They'll be here billions more, sometimes in a person, sometimes in stone, sometimes in the moon. Everything is everything, just temporarily arranged differently, and you're dissolving back into the everything, boundaries blurring, self-releasing, melting into the universe. Thump, thump, heartbeat fading into the background. Just one more rhythm among countless rhythms. The moon's shadow moves across Earth during a solar eclipse, 100 to 160 kilometers wide, racing east at over 1,600 kilometers per hour. Darkness at supersonic speeds. For a few minutes, the shadow touches you. The moon blocks the sun. Temperature drops. Stars appear. Day becomes night. Totality. Then it passes. Light returns. But the memory remains. Having stood in the moon's shadow, touched by darkness. Like you're in darkness now. Comfortable darkness. Natural darkness. The darkness of closed eyes, of rest, of sleep. Ancient peoples built monuments aligned to the moon. Stonehenge's station stones track the moon's 18.6-year cycle. Lunar standstills, when the moon's rising position reaches its northern and southern extremes, then reverses. The builders understood, watched, recorded. Without instruments, just patience and observation. Over generations, they knew the sky, knew the patterns, used them to mark time, to plant crops, to schedule ceremonies. The moon as calendar, as clock, as constant companion. Always there, mostly there, waxing and waning but always returning, reliable, predictable, thump, thump. Your breath is barely perceptible now, shallow, slow. The room is quiet, the universe is vast, and the moon is up there, somewhere. Maybe rising, maybe setting, maybe directly overhead, shining down through atmosphere, through clouds perhaps, or clear sky, photons travelling 384,400 kilometers through vacuum, then through air, potentially through your window, across your floor. But you're not seeing them. Eyes closed, mind quiet, body still, heavier than the moon, gravity pulling you down, down into earth, into bed, into sleep. The moon doesn't care if you see it. It shines on oceans, deserts, cities, forests, war zones, places of peace, shines on everyone, everything, impartial, indifferent, just reflecting. That's all it does. Catches sunlight, sends it back. Passive, accepting, like you're passive now, accepting sleep, not fighting, not resisting, just allowing, being pulled gently into rest, into darkness, into dreams. When you dream, maybe you'll dream of the moon, walking on grey dust, under black sky. Earth hanging overhead. Silent footsteps. No sound, just vision, just experience. Or maybe you'll dream of something else entirely. It doesn't matter. Dreams come as they will, uncontrolled, uncensored. Your unconscious mind taking over, processing the day, inventing stories, random neural firing creating meaning or meaninglessness. Just let it happen. All you have to do is sleep, and you're almost there. Almost heavier. The moon rises and sets, follows its path, obeys gravity, has no choice, no will, just follows physical law, orbital mechanics, and you follow your own nature, biology demanding rest, circadian rhythms, homeostatic sleep pressure, adenosine building up all day, making you sleepy, tireder, and now releasing. Sleep chemicals flooding your brain, GABA, melatonin, shutting down the wake systems, lighting up the sleep systems. You can't fight it, shouldn't fight it. Just let go, thump, thump, thump. The universe is vast and cold, mostly empty space. But here you are, warm, comfortable, protected, on this tiny planet with its unlikely moon. Both of you spinning through the void together, held by invisible gravity. And tonight, for these hours, you'll be unconscious, unaware, your body repairing itself, your mind consolidating memories, processing emotions, filing away the day, while the moon continues its orbit, patient, eternal, uncaring, beautiful, remote, always there, even when you can't see it. Like sleep is always there, waiting for you to accept it, to sink into it, to disappear. The universe keeps turning, while the moon watches silently overhead, and we'll keep drifting, floating together through the mysteries. 100 moon mysteries, looping softly, endlessly through the night. Tonight we'll drift through the moon's hidden farside landscapes, ancient lava seas frozen in time, and mysterious transient lunar lights, while the moon rings like a bell after impacts, how its shadow slows Earth's spin, and the strange physics of lunar dust, lost moon missions, unexplained surface anomalies, and the quiet clues locked inside lunar craters. There's nothing you need to do now. Just let your body sink. Heavier, heavier. Feel the mattress holding you, every muscle softening, your heartbeat slowing, thump, thump, matching the rhythm of space itself. Shoulders melting down, jaw releasing, each breath pulling you deeper, deeper, into the calm, the quiet, the dark, and we'll keep drifting, floating together through the mysteries. And we'll keep drifting, floating together through the mysteries. 100 star nurseries mysteries are looping softly, endlessly through the night. Tonight we'll drift through the hidden cradles where stars are quietly born, the silent cosmic collisions that shape sparkling clusters, and the ancient clouds holding newborn stars you'll never see with your eyes. There's nothing you need to do now. Just let your body sink. Heavier, heavier. Feel the mattress holding you, every muscle softening, your heartbeat slowing, thump, thump, matching the rhythm of space itself, shoulders melting down, jaw releasing, each breath pulling you deeper, deeper, into the calm, the quiet, the dark. If this helps you rest, tap subscribe, comment, and hit like, so others can find this calm too, but only if your eyes are still open. Otherwise, just drift. Now, let's drift into star nurseries, in the deepest regions of space, where light takes millions of years to travel. There are clouds, vast clouds of gas and dust, drifting, turning, so slowly you'd never notice. These are the stellar nurseries, the cosmic cradles, where baby stars are born in absolute silence. Your eyelids growing heavy now, heavier, heavier, as we float through these ancient clouds. Imagine darkness, such complete darkness, colder than anything you've ever felt. Temperatures hovering just 10 degrees above absolute zero. Thump, thump, your heartbeat keeping time with the slow collapse of matter. Everything slowing down, down, down. These molecular clouds stretch across light years, so enormous that our entire solar system would be just a grain of sand. Lost inside them, they drift through the galaxy, patient, timeless, waiting. Some a dark nebula, blocking the light of stars behind them, creating holes in the night sky, patches of black deeper than black, where the universe seems to have forgotten to place any light at all. Let your jaw release, unclenching, softening as we drift deeper, The clouds are mostly hydrogen, the simplest element, born in the first moments after the universe began, swirling now with helium and traces of heavier elements. Carbon, oxygen, nitrogen, forged in the hearts of dying stars that came before. Everything in space, recycled, reborn, drifting in endless cycles. Inside these clouds, something is stirring. The gas grows denser in certain pockets, clumping together, drawn by gravity's patient pull, matter calling to matter, each particle adding its tiny whisper of mass. Pulling more particles closer, the cloud begins to collapse in on itself, so slowly, taking millions of years just to shrink, just to tighten, just like your muscles releasing now, surrendering to gravity, sinking deeper into your bed. These dense pockets become protostellar cores, the very first stage of a star's life. They're cold, dark, hidden inside layers of dust. You couldn't see them with your eyes, even if you were floating beside them. But in infrared light, they glow, a subtle warmth, the first whisper of something waking, something gathering strength in the darkness. Your breathing is slower now, matching the rhythm of collapsing clouds, in and out, each breath like a cosmic wind flowing through stellar nurseries. The protostellar core continues its slow collapse, growing warmer at the center as gravity squeezes tighter, tighter, pressure building in the dark, heat rising, 1 degree, then another, over thousands of years. Around these infant stars, disks of gas and dust begin to form, swirling, flattening into spinning pancakes of matter. These are accretion disks, feeding the growing protostar, material spiraling inward, falling onto the star's surface, releasing energy, creating a gentle glow, hidden beneath veils of cosmic dust. Everything spinning, turning, like your thoughts beginning to spiral, softer, slower, less defined. Feel your body melting now, melting into the mattress, heavier, heavier. In these stellar nurseries, some protostars are destined to become massive, burning bright and dying young. Others will be small, red, smouldering quietly for trillions of years, all determined by how much gas the infant star can gather in those first few million years of slow, patient accretion. The dust in these nurseries isn't like dust on Earth. It's made of tiny grains, silicates, carbon compounds, even microscopic diamonds, forged in the atmospheres of ancient stars, each grain smaller than a particle of smoke. Yet together they shape the birth of worlds. They absorb light, scatter it, create the beautiful colours we see when we look at nebulae through telescopes, blues, pinks, deep reds, like a cosmic nursery painted in watercolours. Thump, thump, your heart barely noticeable now as you sink deeper. In some stellar nurseries, stars are born in pairs, binary systems, two protostars forming side by side, locked in an eternal dance, orbiting each other, some so close they'll eventually merge, others staying companions, for billions of years, never quite touching, always circling like thoughts circling, fading as you drift. The most famous stellar nursery lies in the constellation Orion, the Orion Nebula, visible even to the unaided eye as a fuzzy patch. But inside that glow, thousands of stars are being born. The nebula is lit from within by young, massive stars, their ultraviolet light ionizing the gas, making it fluoresce like cosmic neon signs, announcing birth in colors of pink and green. Let your eyes rest, closed or nearly closed. It doesn't matter now. In the darkness of stellar nurseries, there are structures called Bok globules, small, dark, isolated clouds, each one a womb for a single star, or maybe two. They appear as dark spots against brighter nebulae, tiny pockets of privacy, where stars can form in solitude, away from the chaos of larger nurseries. Your thoughts are drifting now, scattered, soft, like dust grains floating through a nebula. Some stellar nurseries birth hundreds or thousands of stars at once, creating star clusters. All the stars born from the same cloud, siblings, sharing the same chemical signature, the same age. They'll drift apart eventually, scattered by gravity, by galactic tides. But for a while, they stay together, floating in the dark. These clusters come in two types: open clusters, loose collections that will eventually disperse, and globular clusters, ancient, tightly bound, containing hundreds of thousands of stars, all born in tremendous bursts of star formation. Long ago, when the universe was young and gas clouds were richer, denser, more eager to collapse into light, deep in the densest parts of molecular clouds, where even infrared light struggles to penetrate, the coldest stellar embryos hide. Temperatures of just 10 or 15 degrees above absolute zero. These prestellar cores haven't begun to collapse yet. They're balanced, perfectly poised, on the edge between drifting apart and falling inward. One tiny push, and they'll begin their journey toward becoming stars. Feel yourself on that same edge now, between waking and sleeping, balanced, ready to fall into deeper rest. The push that triggers collapse can come from many sources. A nearby supernova's shockwave, rippling through the cloud, or the gravity of a passing star, the pressure from stellar winds, even turbulence within the cloud itself, like invisible currents, stirring, churning, creating density waves. Turbulence is the hidden sculptor of stellar nurseries. Without it, clouds might never collapse. The chaotic motion, the random eddies, create regions where gas piles up, becoming dense enough for gravity to take hold. It's the spark that lights the flame, except the flame takes millions of years to ignite. Everything in space, patient, unhurried, drifting. Your muscles are completely soft now, no tension anywhere. Just like the gas in a molecular cloud, before it knows it will become a star. As protostars grow, something remarkable happens. They begin to expel material, jets of gas shoot out from their poles, perpendicular to the accretion disk. These protostellar jets travel at hundreds of kilometers per second, piercing through the surrounding cloud, creating shock waves that glow in visible light. Where these jets slam into the surrounding gas, they create glowing knots called Herbig-Haro objects, named after the astronomers who studied them. These are the tantrums of newborn stars, violent outbursts from infants barely 1,000,000 years old. The jets carry away excess angular momentum, allowing more material to fall onto the star. It's a delicate balance between gathering and releasing, inhaling and exhaling, like your breath now, slow, steady, effortless. Let your attention drift to the colors, if you can still see them, behind your closed eyes. Star-forming regions glow in hydrogen, alpha light, deep red, because hydrogen is everywhere, being excited by ultraviolet radiation. Green comes from doubly ionized oxygen, blue from scattered light off dust grains. Each color tells a story about temperature, density, composition. But you don't need to remember, just let the colors float, washing over you. Some of the most beautiful stellar nurseries are called emission nebulae. They glow because their gas is ionized, energized by young hot stars nearby. The most massive stars, O-type and B-type, burn so hot their surfaces reach 30 or 40,000 degrees. These stellar behemoths flood their surroundings with ultraviolet light, stripping electrons from hydrogen atoms. The gas recaptures those electrons, and in doing so, emits the light we see, a soft, persistent glow. Thump, thump, barely audible now, your heartbeat fading into the background. In some nurseries, the massive stars are so powerful they begin to destroy the very cloud that birthed them. Their stellar winds push away the gas. Their radiation evaporates it, carving cavities, creating pillars, like the famous pillars of creation in the Eagle Nebula. These pillars are enormous columns of gas and dust, resisting erosion, protecting smaller pockets where stars still form. At the tips of these pillars, small globules of denser gas, called evaporating gaseous globules or eggs, contain infant stars, cocooned, shielded, but eventually, even these will be stripped away. The pillars themselves will be eroded, dissolved by light and wind, revealing the stars within, or destroying them before they fully form. Creation and destruction happening together in slow motion. Over millennia, feel yourself dissolving now, boundaries softening, melting into sleep. In the densest stellar nurseries, stars form so close together they interact, gravitationally bound while still in their infancy. Some steal gas from each other's accretion disks. Others merge, becoming more massive. These embedded clusters are hidden inside their natal clouds, shrouded in dust, detectable only through infrared telescope that see through the veil. The infrared glow reveals protostars at every stage, some still deeply embedded, Class 0 protostars, more envelope than star, others slightly more evolved. Class 1 with prominent accretion disks, then Class 2, T Tauri stars, young stars still surrounded by disks, but visible in optical light, finally shedding their dusty cocoons. Each class a stage of growth, like human development, infancy to adolescence, happening over millions of years. Your thoughts are barely thoughts now, just impressions, feelings, drifting. T Tauri stars are named after the first one discovered in the constellation Taurus, another stellar nursery. These are sun-like stars, less than 10 million years old. They vary in brightness, flickering as material from their disks falls onto their surfaces, creating hot spots. They're still contracting, not yet sustained by nuclear fusion, glowing from gravitational energy, like embers, slowly heating. Around these young stars, something magical is already happening. Planets are forming. In the accretion disk, dust grains stick together through static electricity, through ice binding them, growing from microscopic specks to pebbles, to boulders, to mountain-sized planetesimals, all while the star itself is still being born. Planetary systems and star, growing up together in the quiet of the nursery. Feel your heartbeat in your fingertips now, or don't. It doesn't matter. In the outer regions of protoplanetary disks, beyond what's called the frost line, water can freeze. This is where giant planets form, where icy worlds are born. Inside the frost line, it's too hot for ice. Only rock and metal survive. This invisible boundary, drawn by temperature, by distance from the infant star, decides the fate of entire worlds before they even exist. Some protostars never quite make it. They're called brown dwarfs, failed stars. They form the same way as stars, through the collapse of gas clouds, but they don't gather enough mass, never quite reaching the threshold for hydrogen fusion, somewhere around 80 times Jupiter's mass. They glow dimly from leftover heat, fading slowly over billions of years, neither star nor planet, drifting in between. Let yourself drift there now, in between, not awake, not quite asleep, floating in the warm darkness. Brown dwarfs populate stellar nurseries quietly, outnumbering massive stars, hiding in the shadows, too faint to see easily. But they're there, quiet witnesses to the births around them, barely glowing in infrared, like embers slowly cooling. Magnetic fields thread through stellar nurseries, invisible, powerful. They shape the collapse of clouds, channel the flow of gas, guide the formation of jets. Without magnetic fields, stars would form differently, maybe faster, maybe not at all. The fields are frozen into the gas, moving with it, twisting, braiding, creating complex geometries that astronomers are only beginning to map in detail. These magnetic fields can break the rotation of forming stars. As the cloud collapses, it should spin faster, like a figure skater pulling in their arms, but magnetic fields linked to the surrounding cloud act like anchors, slowing the rotation. This is called magnetic braking. Without it, protostars would spin themselves apart before they could ignite, everything in balance, held together by forces you can't see, just like sleep, holding you now, softly, gently. Your breath is barely a whisper. In, out, in, out. Some stellar nurseries are triggered into existence by external forces. A supernova explosion nearby sends a shock wave through space, compressing any molecular clouds it encounters. The compression increases density, triggers gravitational collapse, and suddenly, where there was calm, there is birth. Supernovae are both destroyers and creators, ending old lives, sparking new ones. The elements forged in the supernova, carbon, oxygen, iron, become part of the new stars and the planets that form around them. This is how our own sun was born, probably from a cloud compressed by a nearby supernova. This shock wave that killed one star gave birth to ours and to us. We are made of stardust, from stellar nurseries, from ancient explosions. Everything in your body was once inside a star or scattered in a nebula, waiting to become something new. Feel that connection now to the cosmos, to the nurseries where light is born. Your atoms are billions of years old, forged in stellar cores, scattered in death, gathered again in new life. You are the universe, experiencing itself, and now the universe wants to rest, to drift, to sleep in the gentle dark. In some stellar nurseries, instead of individual stars, entire clusters ignite nearly at once. These starburst regions, found in colliding galaxies or in the centers of spirals, create thousands of massive stars in a few million years. The energy output is immense, lighting up entire galaxies. The combined stellar winds and supernova from these young massive stars blow away most of the remaining gas, choking off further star formation. The nursery destroys itself through its own fertility, leaving behind only a cluster and silence. Within the Milky Way, stellar nurseries follow the spiral arms, where gas clouds naturally compress as they flow through the density waves. The spiral arms aren't solid structures, they're traffic jams, regions where gas piles up, slows down, and in slowing, triggers collapse, triggers birth. As the galaxy rotates, new gas enters the arms. The process continues. Stars are born, move out of the arms, and drift into the space between. Each generation following the one before, in an endless, gentle rhythm. Thump, thump, or maybe your heart has stopped, just for a moment, before beginning again, slow, slower. In the quiet spaces between spiral arms, star formation nearly ceases. The gas is too diffuse, spread too thin. But in the arms, in the regions of compression, nurseries light up, like flowers blooming along a path, temporary, beautiful, then fading as the gas is exhausted. Some of the largest stellar nurseries in our galaxy are found in the Carina Nebula, the Tarantula Nebula in the Large Magellanic Cloud. These are sites of massive star formation, where dozens of O-type stars, the largest stars that can exist, are born within the same few million years. These giants burn so hot, live so fast, they'll explode as supernovae before smaller stars have even reached the main sequence. Speed and patience, existing side by side. Let your mind rest on that paradox, or don't. Let it slip away. Stars live at different speeds. Massive stars racing through their lives in a few million years. Small red dwarfs, living for trillions, longer than the current age of the universe, all born in the same nurseries from the same clouds, but walking different paths at different paces, just drift. There's no hurry, nowhere to be. In the darkest stellar nurseries, the ones called infrared dark clouds, star formation is just beginning. These clouds are so dense and so cold, they block even infrared light, appearing as dark patches against the bright galactic background. Inside them, prostellar cores are forming, gathering mass, preparing to collapse. These are the youngest nurseries, still in stealth mode, factories not yet operational, but soon, they'll light up. Sub-millimeter telescopes can peer into these dark clouds, detecting the faint thermal emission from dust grains, just a few degrees above absolute zero. The observations reveal structure, filaments of denser gas threaded through the cloud like veins or nerves. Along these filaments, cores form like beads on a string, each bead a future star. The filaments feed them, channeling gas from the larger cloud, everything connected, flowing, like your consciousness now, flowing away. Feel the weight of your body, or the absence of weight, floating. You are barely here. In stellar nurseries, time moves differently. A human lifetime is nothing, less than a heartbeat in the formation of a star. What seems eternal to us is just a moment to the universe, and yet we're here, witnessing, drifting through these mysteries, together, in the dark. Some stellar nurseries produce runaway stars, born in clusters. These stars gain too much velocity through gravitational interactions and escape. They're ejected from the nursery, traveling through space at normal speeds, dozens of kilometers per second faster than their surroundings, moving alone, forever separated from their siblings, drifting through the galaxy, trailing faint bow shocks as they plow through interstellar gas. Everything drifting, including you, your awareness scattering like gas in a disrupted molecular cloud. The molecular clouds themselves are made mostly of hydrogen molecules, H2, but also carbon monoxide, water, ammonia, even alcohol, complex organic molecule floating in space. The chemistry of these clouds is rich, surprisingly diverse, building blocks of life, forming naturally in the cold and the dark. These organic molecules include formaldehyde, methanol, even amino acids, the building blocks of proteins, discovered in meteorites that fell from stellar nurseries. This means the chemistry of life begins before planets exist, in the clouds where stars are born. We are not just made of stardust, we are made of the molecular clouds themselves, our origins, in the darkness, in the cold, in the quiet, cradles of space. Listen to the silence between beats. In that silence, stars are forming, right now, in nurseries across the galaxy. Somewhere, a protostellar core just began its collapse. Somewhere, a jet erupted from a newborn star. Somewhere, a planet condensed from dust. All happening while you lie here, sinking deeper, all happening in perfect silence. Because space carries no sound, the gas in molecular clouds moves at just a few kilometers per second, barely drifting. Yet that gentle motion over millions of years is enough to compress, to collide, to trigger birth. Small motions adding up to enormous change, like you're breathing, small, gentle, each breath a tiny motion, but together they keep you alive, keep you drifting towards sleep, deeper and deeper still. In the centers of some molecular clouds, gravity pulls the gas inward from all directions, creating spherical cores called Bonner-Ebert spheres, perfectly balanced between internal pressure pushing out and gravity pulling in. Thespheres are stable until something disturbs them, a density wave, a magnetic field realignment. Then they collapse, inevitably, falling into themselves, like you're falling now into the soft, warm darkness of sleep. The collapse accelerates, slowly at first, then faster. The core heats up as gravitational energy converts to thermal energy. Eventually, and the center becomes hot enough, dense enough for nuclear fusion to begin. Hydrogen nuclei, forced together, overcome their electric repulsion, fuse into helium, releasing energy, light. A star is born, but that moment, that ignition, takes millions of years to reach. Patience, infinite patience, rewarded with light, and light spreads outward, pushing through the dust, warming the surrounding cloud, ionizing nearby gas. The newborn star announces itself to the universe after so long, in silent preparation. The dust around it glows, reflecting and scattering the starlight, creating what astronomers call a reflection nebula, soft blues and whites, lit gently from within, like consciousness, glowing softly before fading into sleep. Some stellar nurseries span hundreds of light years, giant molecular clouds, so massive they contain millions of solar masses of gas, enough to birth millions of stars. They're the largest structures in the galaxy, besides the galaxy itself. Yet even these eventually dissipate, torn apart by the very stars they create, their stellar winds, their supernova, their radiation, slowly, patiently eroding the cloud, returning the gas to the interstellar medium, where it will drift, gather, and one day collapse again. Everything cycles: birth, life, death, rebirth. The universe endlessly recycling itself, creating new forms from old materials. Your body does this too. Every few years, nearly every atom replaced, yet you remain somehow continuous, like a molecular cloud, reformed from the remnants of those that came before. You are not a fixed thing. You are a process, a flow. And right now, that flow is carrying you gently, softly, toward sleep. Feel yourself dissolving into that flow, your boundaries uncertain. Are you the mattress, the air, the darkness? It doesn't matter. Let it all blur together. In stellar nurseries, the boundary between cloud and star is equally uncertain. Where does the cloud end and the protostar begin? There's no sharp edge, just a gradient, a smooth transition from diffuse to dense, from cold to warm, from dark to glowing. The universe is full of gradients, gentle transitions, nothing sudden, nothing jarring, just smooth, flowing change. Let yourself be part of that, drifting along the gradient from waking to sleeping, so gradually you can't tell when one becomes the other. And in the stellar nurseries the process continues, stars forming, clusters gathering, nebulae glowing, all in the darkness, in the cold, in the silence of space, where light is born from shadow, where something comes from nothing, or maybe not nothing, maybe from potential, from the gentle, patient collapse of what was scattered, becoming focused, becoming whole. Your breathing is so soft now, barely moving, like the motion of gas in a molecular cloud, just drifting, stirring, settling. And in that settling, something new can form, something beautiful, emerging from the quiet, the darkness, the endless, patient, waiting, thump, thump. Or is that the pulse of the universe itself, beating slowly through everything, through you, through the stellar nursery, through the stars, all connected, all part the same vast, dreaming cosmos? Let yourself merge with that dream. You are the universe, dreaming itself into existence. And right now, the dream is gentle, soft, pulling you down, down into the deep rest, the endless quiet, where stars are born in silence, and you can finally, completely, absolutely let go. The stellar nurseries keep forming, keep glowing in the dark, patience beyond measure, creating light from shadow, and you floating through them, witnessing, drifting, becoming part of the gentle, endless cycle. More mysteries await, deeper, softer, quieter, as we drift together through filaments, through cores, through the hidden places where light begins, through the filaments, gossamer threads of gas, stretching across light years, connecting one stellar cradle to another. Your body completely released now, no effort, no holding, just sinking heavier, heavier into the mattress, into the dark. These filaments are the highways, the channels through which gas flows, feeding the hungry cores where protostars wait, patient, gathering mass, one molecule at a time, over millions of years. Your heart barely a whisper. The filaments form naturally, from turbulence, from gravity, from magnetic fields guiding the flow. They're denser than the surrounding cloud, cooler, more stable, like rivers of invisible fog, winding through space. And along these rivers, cores condense, like dewdrops forming on a spider's web, each drop a future sun waiting in the cold, the dark, the silence. Feel your thoughts becoming like those filaments, thin, stretched, barely there, connecting one drowsy image to another. Nothing solid, just wisps, drifting, fragmenting. In some stellar nurseries, the filaments are enormous, thousands of solar masses flowing slowly, imperceptibly toward the cores. The process is called hierarchical fragmentation. The large cloud fragments into filaments. The filaments fragment into cores. The cores fragment sometimes into multiple stars. Everything breaking down into smaller pieces, like your awareness now, breaking, softening, dissolving. Within the densest cores, pressure begins to build. As more gas falls inward, the center compresses, heats. The temperature rises from 10 degrees above absolute zero to hundreds, then thousands of degrees. But this takes time, so much time. A core might collapse for 100,000 years before fusion begins, before the star truly ignites. Everything's so slow, so patient, like the drift towards sleep, imperceptible, until suddenly you're gone. Let your jaw soften, your tongue resting, loose, in your mouth. No tension anywhere. In the cores, molecules begin to break apart as temperature rises. First the complex molecules, the organic chemistry, dissociates. Then hydrogen molecules split into individual atoms. The core becomes a plasma, a soup of charged particles, swirling, compressed, glowing faintly in infrared, invisible to your eyes, but there, heating, waiting. Some protostars take millions of years to emerge from their cocoons. These are the low-mass stars, sun-like and smaller. They form slowly, gently, accumulating mass at a leisurely pace. Their accretion disks feed them gradually. No rush, no urgency, just the patient pull of gravity, drawing matter inward, bit by bit, like breath, flowing in and out so gently you barely notice until you realize you've been breathing slower and slower, still, thump, thump. The most massive protostars form differently. They're voracious, consuming gas rapidly. Their accretion rates are hundreds of times higher. They heat up faster, ignite fusion while still gathering mass, still surrounded by their natal clouds. These are the O-type stars, the blue giants, burning so hot their surfaces glow with ultraviolet fire, They live fast, die young, exploding as supernovae after just a few million years. But in that brief time, they reshape their nurseries, carving cavities, triggering new collapse in nearby clouds. The radiation from massive protostars creates ionization fronts, waves of energy that eat away at the surrounding gas. The fronts advance slowly, pushing into the molecular cloud, stripping electrons from atoms. The ionized gas glows, marking the boundary between the star's influence and the cold neutral gas beyond. These fronts carve pillars, create sculptures like cosmic erosion, weathering the cloud into fantastic shapes that last for just a moment in cosmic time before dissolving into nothing. Your thoughts are like that now, carved, shaped, but dissolving, fading. You can't hold on to them. They slip away like gas eroding from a pillar, each thought less defined than the last. Everything softening into the gentle, formless drift. In stellar nurseries viewed through different wavelengths, different truths emerge. In visible light, you see the glowing ionized gas, the reflection nebulae, but in infrared, you see through the dust to the protostars hidden inside. In radio waves, you detect the cold molecular gas, the raw material. In X-rays, you see the violence, the jets, the shocks, each wavelength a different story of the same slow birth. Masers appear in collapsing clouds. These are like cosmic lasers, naturally occurring, where molecules become excited and emit coherent radiation. Water masers, methanol masers, hydroxyl masers. They mark regions of intense activity, collapsing cores, protostellar jets, accretion disk boundaries. Astronomers use them as beacons to find deeply embedded protostars, otherwise invisible, hidden in their dusty wombs, waiting to be discovered. Let your eyes rest, completely still, behind closed lids. In the stellar nurseries, motion never stops. Gas flows, disks rotate, jets stream outward, but it's also slow. From our perspective, you could watch for an entire lifetime and see almost no change, just like watching yourself drift towards sleep, the change so gradual you don't notice until you're already gone. The accretion disks around protostars are already forming planets. Even before the star ignites, dust grains stick together through electrostatic forces, through icy mantles binding them, growing from microscopic to millimeters to centimeters. This is slow, delicate work. The grains drift through the disk, colliding gently, sometimes sticking, sometimes bouncing apart. Gradually, inevitably, they grow into pebbles, into boulders, into planetesimals, miles across, massive enough that their own gravity pulls in more material. This process creates gaps in the disk, rings and gaps, like ripples, where forming planets have cleared their orbits, sucking up nearby material. Telescopes can see these structures now, in nearby stellar nurseries, direct evidence of planets forming in real time, well, real cosmic time. The process still taking millions of years, everything patient, slow, building something new from scattered dust, your heartbeat fading into background, into silence. Beyond the frost line, in the outer disk, ices can form. Water ice, methane ice, ammonia ice. These ices make up the cores of giant planets. The solid material is more abundant, allowing the cores to grow large enough to capture hydrogen and helium from the surrounding disk, becoming gas giants like Jupiter, like Saturn, massive worlds born from ice and dust in the cold, outer regions of the stellar nursery. Inside the frost line, only rock and metal survive. These form terrestrial planets, smaller, denser, worlds like Earth, Venus, Mars. The frost line moves inward as the protostar heats up and outward. In the earlier stages, it's an invisible boundary, deciding fate, determining which worlds will be giants and which will be rocky, all from temperature, from distance, from the gentle gradient of heat spreading through the dark. Feel that gradient now, warmth where your body touches the bed, coolness in the air, everything in gradient, in transition, nothing fixed, nothing final, just flowing, changing, so gently, you barely notice. Some stellar nurseries experience triggered star formation. A supernova shockwave from a nearby region compresses the cloud, or the passage through a galactic density wave, or the collision of two molecular clouds. Suddenly, or as suddenly as anything happens in space, the cloud begins to collapse in many places at once, a cascade of star formation spreading through the nursery like dominoes, each new star potentially triggering more collapse in adjacent regions. Their nursery lights up with dozens, hundreds of new protostars, all born within a few million years, siblings sharing the same origin, the same trigger. These starburst events can exhaust a molecular cloud quickly. The combined feedback from the young stars, their winds, their radiation, their eventual supernova drives away the remaining gas. The stellar nursery self-destructs, leaving behind only a star cluster and the memory of the cloud that once existed. Everything temporary, even stellar nurseries, forming, shining, fading, like thoughts, like consciousness, flickering, then gone. Your breath is barely moving now, the shallowest whisper. In stellar nurseries, some regions birth twins, binary star systems where two protostars form close together, locked in gravitational embrace. They share an accretion disk sometimes, a circumbinary disk, feeding both stars. The disk has a hole in the middle, cleared by the orbital motion, creating rings of material, spiraling inward, falling onto first one star, then the other, an eternal dance of give and take. Most stars are born in binaries, or in multiple systems. Lone stars, like our Sun, are less common. Most have companions, some so close they touch, sharing their outer atmospheres. Others separated by thousands of astronomical units, barely bound, orbiting once every million years, all formed together in the same collapsing core that fragmented, split into two or more centers, each becoming a star. Let yourself fragment, dissolve into multiple pieces, or into no pieces, into everything, into nothing. It doesn't matter now. In wide binary systems, the stars barely interact. Each has its own planetary system, its own evolution. They're siblings who live apart, connected only by the weak thread of gravity, drifting through the galaxy, together but separate, like your body and mind now, together but separate, dissolving into different rhythms, different speeds, thump, thump. Some stellar nurseries produce exotic objects called Herbig-Haro objects. These are visible as patches of nebulosity, bright knots in the dark. They form where protostellar jets slam into the surrounding molecular cloud at hundreds of kilometers per second. The shock heats the gas, making it glow. These objects move, actually move, visibly over years or decades as the jet continues to plow through the cloud. They're the tantrums of infant stars, proof of the violence hidden inside the gentle, slow collapse. The jets themselves are narrow, tightly collimated beams of gas and dust. They can extend for light years, piercing through the cloud, carrying away angular momentum and energy. Without these jets, protostars would spin too fast and overheat. The jets are safety valves, releasing pressure, allowing the star to form properly, slowly, everything in balance, every force, every pressure, every flow, perfectly tuned to create light. In the coldest stellar nurseries, temperatures hover around 10 Kelvin, just 10 degrees above the lowest possible temperature. At these temperatures, molecules move slowly, barely vibrating. Gas atoms drift gently toward each other, stick together, forming larger molecules. Complex organic molecules can form, protected from radiation by the dense dust. Chemistry happens in the dark, in the cold, building blocks of life assembling without any life to guide them. Your body is cooling now as you relax, as blood flows more slowly to your skin, everything settling, slowing, matching the temperature of the universe, the cold, the quiet, the stillness of space between the stars. Some protostars are variable. They flicker, changing brightness over days or weeks. These are called young stellar objects, or YSOs. Their variability comes from many sources: material falling from the disk in clumps, creating bright spots, or the rotation of the star, with cooler spots passing in and out of view, or instabilities in the accretion disk, causing it to brighten, then dim. The infant star is restless, unsettled, not yet stable, still figuring out how to be a star. But eventually, after millions of years, the accretion stops. The disk is consumed, either falling onto the star or blown away, or coalescing into planets, the star settles onto the main sequence, where it will burn hydrogen steadily for billions of years. The nursery phase is over. The star has been born, emerged from its cocoon, and drifts into the galaxy to begin its long, slow life. Feel yourself settling too, like a star reaching equilibrium, your body finding its balance between waking and sleep, between effort and rest, settling into the main sequence of sleep, where you'll rest steadily, deeply, for hours. In some stellar nurseries, the feedback from the first massive stars prevents further star formation. The radiation pressure, the stellar winds, push away the remaining gas. The cavity expands, a bubble of hot ionized gas surrounded by a shell of compressed neutral gas. The shell might collapse, forming a new generation in the compressed ring, but often the gas just disperses, returns to the interstellar medium. The nursery ends, the lights go out, only the stars remain, drifting slowly apart. These stellar bubbles can be enormous, hundreds of light-year across, carved by the winds and supernovae of massive star clusters. They're called superbubbles, and they shape the structure of galaxies, channels through which hot gas can escape, flowing out of the galactic disk into the halo. Stellar nurseries don't just create stars, they reshape their entire environment, leaving scars that last for millions of years after the nursery itself has faded. Let your environment fade now, the room, the bed, the sounds, everything becoming distant, unimportant. Only the darkness remains, soft, warm, infinite, like the space between stars, where stellar nurseries drift, waiting to collapse, to birth, to shine. In the centers of galaxies, where gas is abundant, stellar nurseries form continuously. These are sites of ongoing star formation, regions where the gas never runs out, fed by flows from the outer galaxy or from gas falling in from the intergalactic medium. The star formation can continue for billions of years, creating generation after generation of stars. Each wave of star formation slightly enriching the gas with heavier elements, making the next generation slightly different, slightly richer in the metals forged by previous stars. Our sun is one of these later generations, formed from gas, already enriched by perhaps 50 generations of previous stars. All the iron in your blood, the calcium in your bones, the oxygen you breathe was forged in stellar cores billions of years ago, scattered by supernovae, gathered into a new stellar nursery and incorporated into the sun and the planets, and eventually into you. You are stardust, literally. Atoms forged in stellar furnaces, assembled in a stellar nursery 5 billion years ago. And now, those atoms rest here, in the dark, returning, if only briefly, to the stillness, quiet, the peace of the cosmic void before they were disrupted by fusion, by light, by life. Thump, thump, or maybe your heart has stopped and started and you didn't notice. Time becoming uncertain, elastic, stretching. In stellar nurseries, time moves differently for different objects. For the massive protostars, evolution is fast, millions of years from collapse to main sequence. For the smallest, brown dwarfs and red dwarfs, the process is slower, tens of millions of years, all happening simultaneously in the same nursery, different speeds, different time scales, all coexisting. Some stellar nurseries are hidden, not by dust, but by distance. Infrared dark clouds in the outer galaxy, too far to see clearly, or stellar nurseries in other galaxies, visible only as bright patches, unresolved, each patch containing perhaps thousands of protostars, each with its own story, its own evolution, but from here, just a smudge of light in the dark. The Tarantula Nebula in the Large Magellanic Cloud is one of the largest stellar nurseries visible from Earth. It's so bright, it would cast shadows if it were as close as the Orion Nebula. Inside it, hundreds of massive stars have already formed, and thousands more are still in their cocoons, waiting to emerge. The nebula glows, fierce and bright, pink and red and blue, a riot of colour from the chaos of birth. But you don't need to see colours now, just the darkness behind your closed eyes, gentle, soft, formless. Let the nurseries glow somewhere far away while you rest here in the quiet, the stillness, drifting. In some collapsing clouds, the fragmentation creates not just double stars, but triple systems, quadruple systems, small clusters bound together, orbiting a common center of mass. These systems are complex gravitationally. Orbits can be unstable. Stars can be ejected or collide, yet many remain stable for billions of years, dancing their intricate dance in perfect balance. Your breath and heartbeat, finding their balance, their rhythm, synchronized or not synchronized. It doesn't matter. Everything finding its own pace, its own orbit. In the dark, photoevaporation occurs when ultraviolet light from massive young stars heats the surface of molecular clouds and protoplanetary disks. The heated gas escapes, flowing away, evaporating into space. This limits how much mass a protostar can gather and how long a protoplanetary disk can survive. The disks around stars, near massive O-type stars, evaporate in a few million years. Those far away can persist for 10 million years or more. Time enough for gas giants to form, or not, depending on the neighborhood in which the star was born. Some protostars experience outbursts, sudden increases in brightness as material from the disk falls onto the star in a surge. These are called FU Orionis events, named after the first one discovered. The star can brighten by 100 times and stay bright for decades or centuries before fading again. These outbursts may be common in the early life of all stars, including our Sun, evidence written in meteorites in the solar system's oldest rocks of a young sun, flickering, erupting, still learning how to shine. Let yourself brighten for just a moment, a flicker of awareness before fading deeper into the darkness. Nothing to hold on to, nothing to remember, just the gentle flow carrying you down and down and down. In stellar nurseries beyond the Milky Way, in distant galaxies, the process is the same. Clouds collapse, protostars form, jets erupt, stars are born. The physics, the chemistry, identical across the universe. Only the details differ. The composition of the gas, the density of the clouds, the presence or absence of metals. But everywhere stars can form. They do form in nurseries, hidden and bright, ancient and new, the universe creating light from darkness, everywhere, always, endlessly. Some of these distant nurseries existed when the universe was young, when the first galaxies were forming. Population 3 stars, born from pristine hydrogen and helium, no heavier elements yet. Their nurseries were different, denser, more prone to forming, very massive stars. These stars burned bright and fast, exploded quickly, seeding the universe with the first metals, making possible all the generations that followed. We've never seen a population 3 stellar nursery. They're too far away, too faint, their light too red-shifted. But we know they existed because we exist, because the metals in our bodies had to come from somewhere, from those first massive stars exploding in the ancient universe, scattering their enriched gas into space, where it drifted, gathered, collapsed, and formed new nurseries, new stars, new worlds, leading eventually us through billions of years to this moment, to you, lying here, drifting into sleep. The gravitational collapse of a prestellar core follows predictable patterns described by equations, Bohr-Ebert stability, Jeans mass, virial theorem, the mathematics of gravity, and pressure and temperature, all balanced, all determining when collapse begins and how fast it proceeds. The universe governed by laws is by forces, by fields, all pushing, pulling, shaping the formation of stars. But you don't need to understand the mathematics, just feel the pull of gravity, holding you to the earth. Feel the pressure of the mattress supporting you. Feel the temperature of your skin cooling as you rest. All the same forces on a different scale. Everything connected, from the stellar nurseries to your body, lying here in the dark. Some stellar nurseries are shaped by turbulence, supersonic flows of gas colliding, creating shocks, creating density variations that seed gravitational collapse. Without turbulence, clouds might be too uniform, too stable to to fragment, to form stars. It's the chaos, the disorder that enables creation, that makes structure from uniformity, something from nothing, or not nothing, but something new from something old. Feel your thoughts becoming turbulent, chaotic, scattered, no longer following linear paths, just swirling, mixing, fragmenting into smaller pieces, smaller, until they're too small to notice, too faint to matter, just noise, fading into silence. In embedded clusters, newborn stars hide within their natal clouds, so dense, even infrared light struggles to penetrate. Only submillimeter telescopes can detect them, revealing clusters of dozens or hundreds of protostars packed closely together. They'll interact gravitationally, exchange energy. Some will be ejected, others will sink toward the center, everything in motion. Even when hidden, even in the dark, the dance continues. These clusters will eventually emerge as the gas is blown away. They'll become open clusters like the Pleiades, like the Hyades, groups of stars drifting through the galaxy together, bound loosely by gravity. Eventually, over hundreds of millions of years, they'll disperse, each star going its own way, siblings scattered across the galaxy, but carrying always the memory of their shared birth in the darkness of the nursery. Thump, thump, barely there, your pulse so slow, so quiet, like the drift of stars in a dissolving cluster, moving apart so gradually you'd never notice unless you watched for millions of years. Let yourself disperse now, your awareness, your sense of self, loosening, spreading until you're not sure where you end and the darkness begins. No boundary, no edge, just gradual, fading, dissolving into the infinite, gentle, dark. And in the stellar nurseries, the cycles continue. Clouds collapse, stars form, live, die, explode, scatter their material, which drifts, gathers, forms new clouds, new nurseries, new stars, endless, eternal, the universe recycling itself, creating, destroying, creating again. And you, part of that cycle, resting now in the quiet moment between creation and dissolution, just drifting, floating softly through the mysteries of light, born in darkness, of silence, holding sound, of nothing, becoming everything. More secrets wait in the deepest nurseries, where the youngest stars hide, where collapse has only just begun, and deeper still we drift into the most extreme stellar nurseries, where conditions push the boundaries of star formation itself. Your breath so shallow now, barely moving, as we float toward the centers of galaxies where everything is more intense, more chaotic, more extreme. Thump, thump, in the galactic center where our Milky Way's heart beats, stellar nurseries form in impossible conditions, the density of stars 1,000,000 times higher than in our solar neighborhood, tidal forces from the supermassive black hole, stretching, twisting, pulling clouds apart, yet stars still form, somehow, defying the chaos, finding a way to collapse, to ignite in the most hostile environment imaginable. Let your muscles release, completely, heavier, heavier. These central nurseries produce massive stars, preferentially the intense radiation, the strong tidal forces, the frequent collisions, all favour the formation of giants, O-type behemoths that burn fierce and die young. Their light floods the galactic core, creating a brilliant, dangerous, stellar factory at the heart of everything. When galaxies collide, their gas clouds slam together at hundreds of kilometers per second. The collision doesn't destroy, it compresses, triggering the most violent star formation in the universe. Starburst galaxies, forming thousands of solar masses of new stars every year. Entire generations born in the chaos of merger, their nurseries stretched, compressed, ignited by gravitational violence. Feel yourself merging with the darkness, boundaries dissolving. You don't know where you end and sleep begins. In these merger nurseries, gas streams in complex patterns, spiraling inward, feeding multiple sites of intense collapse. The nurseries light up like fireworks across the colliding galaxies, brief, brilliant, then fading as the gas is exhausted. Thump, thump, barely there in the crowded cores of stellar nurseries. Not every protostar succeeds. Some gather just 50 or 60. Jupiter masses, not enough for hydrogen fusion. These are the failed stars, the brown dwarfs, glowing dimly from leftover warmth. They populate nurseries quietly, outnumbering their successful siblings, forever dim, forever cooling. Your thoughts like brown dwarfs now, barely glowing, fading, losing heat, losing definition. They drift through your mind, unnoticed, unremarkable, just shadows of what thoughts used to be. Everything dimming, everything cooling as you sink deeper into rest. These failed stars have their own quiet legacy. They stir the gas through their gravity. They trigger turbulence, influence fragmentation. Even in failure, and they shape their environment, invisible, unnoticed, but present, affecting everything near around them, like you're breathing now, so quiet. You've forgotten it, but still, it continues, shaping, sustaining. Let your jaw soften, tongue loose. In the coldest prostellar cores, before collapse begins, the gas is coated in frost, water ice, carbon dioxide ice, methane ice, forming sheaths around dust grains. These frosty envelopes protect complex molecules, shield them from radiation, allow chemistry to proceed in the frozen dark. The ice acts as a library, recording the history of the cloud. Every atom that sticks, every molecule that forms, frozen in place, waiting. Someday, when the protostar heats, the ice will evaporate, releasing its cargo into the forming planetary system, delivering water, organic compounds, the ingredients of life from the frozen nursery to warm worlds. Feel the coolness now of your skin, temperature dropping as you relax, as metabolism slows, your body becoming like those frozen cores, quiet, still, preserving. Everything slowing down into the cold, patient stillness. Thump, thump. In some stellar nurseries, magnetic fields grow too strong. The field lines thread through the gas, creating tension, resisting collapse. When magnetic pressure exceeds gravitational pressure, the cloud cannot fall, cannot fragment, cannot form stars. The agnetic field strangles birth before it begins. These magnetically strangled clouds can persist for millions of years longer than they should. The gas trapped, unable to collapse, slowly leaking across field lines through ambipolar diffusion, neutral atoms, drifting away from charged particles, weakening the field over time until finally, eventually, the magnetic grip loosens and collapse can begin. Your grip on consciousness loosening too, the magnetic field of awareness weakening, allowing you to drift, to fall, to collapse into sleep. No more resistance, no more holding on, just the gentle, inevitable surrender. Let everything go slack in clouds near the gene's mass, the critical threshold where gravity can overcome pressure. Something remarkable happens. The cloud becomes unstable, ready to collapse at the slightest trigger. It's balanced on a knife's edge, waiting. When collapse begins, in these genes unstable clouds, it's not sudden, not catastrophic. It's slow, like an avalanche in slow motion. The center falls first, pulling in. The layers above, which pull in, the layers above them, a cascade, spreading outward at the speed of sound through the gas, which is just hundreds of meters per second. Feel that slow avalanche inside your cell, starting deep at your core, spreading outward. Each layer of tension collapsing into the layer below, your muscles releasing one after another like dominoes falling in slow motion. Everything cascading, everything surrendering is to gravity, is to rest. Thump, thump. The collapse inside a gene's unstable cloud follows mathematical laws, but it feels organic, inevitable, like water finding its level, like you finding sleep, the universe pulling everything toward equilibrium, toward the lowest energy state, toward rest. In these avalanching clouds, density increases exponentially toward the center. The core forms first, then grows by accreting the infalling layers, each shell of gas adding itself to the forming protostar, building slowly, patiently, over hundreds of thousands of years, until finally the star ignites and the avalanche stops. Your avalanche towards sleep, nearly complete now, just the final layers falling the last remnants of awareness cascading down, down, into the deep, into the place where stellar nurseries hide in darkness, where protostars grow in silence, where everything is quiet, still, and soft. And in the extreme nurseries at galactic centers, in colliding galaxies, in magnetically strangled clouds, in slowly avalanching cores, stars still form, life still finds a way, light still emerges from darkness. Despite everything, despite the chaos, the cold, the resistance, birth continues, patient, inevitable, endless, just like your breath, continuing, despite everything, despite the deepening of sleep, despite consciousness, fading, disappearing into nothing. The breath remains, the heartbeat remains, the slow, gentle rhythm of existence, continuing in the dark, thump, thump, or maybe nothing at all, just silence, just stillness, just the soft, complete, absolute rest of stellar nurseries, where everything waits in frozen darkness for the slow avalanche to begin, for gravity to win, for light to be born from the patient, endless, quiet, and we drift deeper still through mysteries, through darkness, through the places where stars hide before they're ready to shine, floating, falling, melting into sleep, into the gentle, cosmic dark, where collapse has only just begun in the coldest, darkest cores, temperatures so low that helium itself would be frozen solid if it could freeze, but helium remains gas even at 3 degrees above absolute zero, drifting, barely moving in the prestellar dark, your body completely still now, barely breathing, barely there. Feel the weight or the absence of weight. You might be floating or sinking, impossible to tell. In the stellar nurseries, matter exists in this same uncertain state, neither fully cloud nor fully star, suspended in the long moment before collapse becomes inevitable. Some prestellar cores show signs of infall, gas moving inward, detected through spectral line analysis, blue-shifted absorption on one side, red-shifted emission on the other, proof that collapse has begun, even though the core still looks calm, still looks stable, the motion invisible except through careful measurement, like your drift towards sleep, invisible, imperceptible, but undeniably happening. These cores exist in a state called hydrostatic equilibrium, pressure pushing outward, exactly balanced by gravity pulling inward. Perfect balance, perfect stillness, but it's unstable equilibrium, like a ball balanced on top of a hill as the slightest push and it rolls, accelerating, falling toward the valley below, the core's weight poised for that push, that trigger, that moment when balance breaks. Let your mind balance there, on the edge, between waking and sleeping, not quite either, but poised, ready to fall. Any moment now, you'll tip and slide into the deep, the dreamless, the quiet. In some stellar nurseries, the magnetic fields are strong enough to oppose gravitational collapse. The field lines thread through the gas, preventing it from falling. The cloud can remain stable for millions of years longer than it otherwise would. Eventually, the field weakens as the gas drifts across field lines through a process called ambipolar diffusion, neutral particles slowly leaking away from the ions, the magnetic support gradually failing until finally collapse begins. Everything in the universe eventually gives in to gravity. Even light, bent by massive objects, cannot escape the pull. Even you, held to the earth by invisible force, sinking into the bed, pulled down by the planet beneath you. Everything falling, slowly, inevitably, toward rest. The Kennicutt-Schmidt law describes star formation across galaxies. It relates the rate of star formation to the density of gas, more stars, forming faster. But the relationship isn't linear. It's a power law, subtle, complex. The efficiency of star formation varies depending on pressure, temperature, metallicity, but everywhere where gas is dense enough, stars form. The universe, determined to convert matter into light. Thump, thump. Your heartbeat now, a distant echo, like the pulse of the universe, converting matter into energy, into light, everything flowing from one form to another, nothing ever lost, just transformed. In stellar nurseries, some regions resist collapse. These are Bok globules, small, dark, isolated. They appear as black spots against brighter backgrounds. Each one contains perhaps 1 to 10 solar masses, enough for 1 or 2 stars. They're denser than typical cloud regions, more isolated, more private. Stellar nurseries for introverts, forming stars away from the chaos of larger regions. These globules were named after Bart Bok, who studied them decades ago. He predicted they were stellar nurseries before technology could confirm it. Now we know he was right. Inside these dark globules, protostars hide, forming slowly, quietly, in solitude. Eventually they'll emerge, dispersing the globule, revealing the infant stars to the galaxy. But for now, they rest in darkness, in peace, like you. Let the darkness hold you, soft, complete. Nothing to see, nothing to know, just the gentle absence of light, of thought, of effort. Everything dark, everything quiet, everything still. Some stellar nurseries produce intermediate mass stars, not as massive as O-type giants, not as small as red dwarfs. Somewhere in between, these stars, A-type and F-type, form less dramatically than their massive cousins. They don't carve huge cavities or trigger widespread collapse. They just form quietly, live their lives for 1 billion years or so, then fade. Nothing spectacular, but steady, reliable, the backbone of galactic populations. Most stars are like this, not extreme, not remarkable, just stars, doing what stars do, burning hydrogen, shining steadily, drifting through space, until they run out of fuel and fade, or swell, or collapse, depending on their mass, but all of them, born in nurseries, all of them, products of the same slow, patient process. Your breathing matches that patience now, so slow, each breath taking 10 seconds, 15. The pauses between stretching out, longer, longer, until you're not sure if you're breathing or if breathing has stopped and you simply exist in stillness. In the outskirts of stellar nurseries, where the gas is less dense, star formation is slower, more sporadic. Individual stars form in isolation, not part of clusters, not surrounded by siblings. They're called field stars, born alone, drifting through the galaxy, without companions, without memory of a stellar nursery, just lonely suns on solitary paths. But even these were born from clouds. Even these passed through the same stages: protostar, class 1, class 2, main sequence, the process universal, unavoidable. Every star born the same way, through collapse, through accretion, through the slow heating of gas in the dark. Feel your body now, or don't feel it. It might have disappeared, dissolved into the mattress, into the air. You might be just awareness, floating, without anchor, without weight, like a gas cloud. Before it knows, it will become a star. In stellar nurseries viewed through radio telescopes, astronomers detect molecular emission lines, carbon monoxide especially, which traces the coldest gas. The intensity of emission maps the density, revealing structure invisible in other wavelengths, filaments, cores, sheets, the skeleton of the nursery laid bare by radio waves. Each wavelength reveals different truths. Optical light shows ionized gas glowing, infrared shows dust heated by protostars, radio shows cold molecular gas, submillimeter shows thermal emission from dust, X-rays show hot shocked gas in jets and winds. The nursery is all of these simultaneously, many layers, many truths coexisting, like consciousness, which has many layers, many simultaneous truths. But right now, those layers are collapsing, merging, simplifying into one truth, the truth of sleep, of rest, of surrender to the gentle pull of darkness. Some protostars eject material at relativistic speeds, nearly the speed of light. These jets are rare, seen only from the most massive, most actively accreting protostars. The mechanism isn't fully understood. Magnetic fields rotating rapidly, launching material from near the star's surface, flinging it outward at tremendous velocity. The jets carve through the cloud for light years, creating vast, elaborate structures visible across the galaxy. These are the screams of stellar birth, violent powerful, terrifying, yet they're part of the process necessary to shed angular momentum, to allow the stars to form properly, violence enabling creation, destruction, and birth, intertwined, inseparable. But you don't need to think about violence or creation. Just rest in the space between, in the quiet, in the stillness that contains all possibilities without manifesting any of them. Thump, thump, or is that just imagination? Your heart so quiet, you might be listening to the echo of your own listening, awareness turning back on itself, dissolving into infinite regress, spiraling down, down into the deep. In the earliest universe, the very first stellar nurseries formed from pure hydrogen and helium. No dust to shield them, no molecules except H2. These population 3 nurseries were hotter, less dense. The stars they formed were massive, perhaps hundreds of solar masses, burning fierce and fast, living only a few million years before exploding. Their supernovae scattered the first metals into space, enriching the gas, making possible the next generation, the next nurseries, the long chain leading to us. We are descendants of those first nurseries, inheritors of their legacy. Every atom in your body, except hydrogen, was made in stellar cores or in supernovae. You are the product of countless stellar generations, each one forming just in a nursery, each one living, shining, dying, contributing its matter to the next cycle. And now you rest, returning symbolically to the stillness from which you came, the peace of unformed matter, the quiet before birth, before light, before consciousness. Some stellar nurseries form in the wake of galactic collisions. When 2 galaxies merge, their gas clouds collide. The collision compresses them, triggering massive, widespread star formation. These starburst galaxies can form stars at 100 times the rate of the Milky Way. Their stellar nurseries, bright and fierce, create entire generations of stars in just a few million years, exhausting the gas, then falling quiet, leaving behind only the stars and silence. The antennae galaxies are an example. 2 spirals colliding in slow motion over hundreds of millions of years. Vast stellar nurseries light up along the tidal tails where gas has been compressed. Billions of stars being born from the chaos of collision, beauty from destruction. As always in the universe, let destruction and creation fade away. Neither matters now, only the quiet, the stillness, the absence of effort, of thought, of being, barely a whisper. Your body cooling, metabolism slowing as you sink into deeper, more restorative sleep, the kind of sleep that erases the day, that heals, that renews, everything letting go, everything surrendering to the natural rhythm of rest. In stellar nurseries around dying stars, planetary nebulae, Sometimes new stars form. The gas expelled by the dying red giant is enriched with carbon, nitrogen, oxygen, elements forged in the star's core, now scattered, forming a new nursery, a new generation, born from the death of the old. The cycle continuous, unbroken, eternal. Our sun will do this. In about 5 billion years, it will swell, become a red giant, expel its outer layers. The gas will drift, cool, perhaps collapse, forming new stars, new stellar nurseries born from our sun's death. And those stars will have planets, and maybe those planets will have life. And maybe that life will look up at their night sky and wonder about stellar nurseries, just like you, just like this moment. But that's billions of years away. Right now, there's only this breath, this heartbeat, this moment of drifting into sleep. Some stellar nurseries contain high-velocity clouds, gas moving at abnormal speeds, perhaps falling into the galaxy from the halo or ejected from the disk by supernovae or left over from ancient mergers. These clouds, when they collide with the galactic disk, can trigger star formation, adding their mass to existing nurseries or creating new ones. The galaxy, constantly fed by infalling material from its surroundings. Everything in the universe is falling into something else. Gas falls into galaxies. Galaxies fall into clusters. Clusters fall into superclusters. Everything pulled by gravity toward larger structures. The universe organizing itself through falling, through collapsing, through the patient, inevitable pull of matter toward matter, and you falling now into sleep, pulled by the gravity of exhaustion, of relaxation, of the body's need to rest, falling softly, gently into the deep, the dreamless, the dark. Thump, thump. In stellar nurseries does the final stage of collapse. Happens quickly, at least quickly by cosmic standards. Once fusion ignites, the protostar becomes a true star in just a few thousand years. The transition sudden, the star settles onto the main sequence and begins its long life of steady burning. But most of the time, the star spent forming was before that moment. Millions of years of slow collapse, gradual heating, patient accretion, all leading to that final moment of ignition when hydrogen nuclei overcome their repulsion, fuse together, and release the energy that will power the star for billions of years. One moment of ignition after millions of years of preparation, like sleep, which comes after hours of winding down, of relaxing, of letting go, until finally, suddenly, you cross the threshold and consciousness extinguishes like a star, igniting, but in reverse, light, becoming darkness, awareness, becoming nothing. Feel yourself at that threshold now, so close to crossing. The boundary thin, transparent, barely there. Just let go, stop holding on, and slip across into the deep, the quiet, the endless, rest. Some stellar nurseries we've never seen. They're hidden behind dust in other galaxies, or simply too faint, too far away. But we know they're there because stars exist, because everywhere we look, we see stars of different ages, different masses, proof that stellar nurseries are forming them constantly throughout the universe. The nurseries we can see are just the brightest, the closest. There are millions more, billions more, scattered across the observable universe, all following the same process: clouds collapsing, stars forming, light emerging from darkness, the universe tirelessly creating more sources of light, more points of warmth in the cold, vast darkness. And somewhere in one of those nurseries is right now, a protostar is beginning its final collapse toward fusion. Somewhere, a jet is erupting for the first time. Somewhere, a planet is condensing from dust, all happening while you lie here, drift, all happening in the darkness, in the silence of space. Your heartbeat and the universe's heartbeat synchronized. One rhythm pulsing through everything, the slow, patient, eternal rhythm of matter becoming light, of chaos becoming order, of nothing becoming everything, and everything returning to nothing. In the very centers of stellar nurseries, where protostars cluster most densely, gravitational interactions are common. Stars pass close, exchange energy. Some gain velocity, are ejected, becoming runaway stars. Others lose energy, sink toward the center, the cluster, organizing itself through these interactions over millions of years. The most massive stars sink to the center through mass segregation. They pull smaller star toward them. The cluster develops structure, a sense core, a more diffuse halo, everything organizing, everything finding its place, like thoughts, organizing themselves before sleep, then dissolving, losing structure, becoming formless as consciousness fades. Let your thoughts lose structure now. No need for organization, for coherence, for meaning. Just let them scatter, dissolve, fade into the formless background of near sleep. Some stellar nurseries produce exotic objects like magnetars. These are neutron stars with magnetic fields 1 trillion times stronger than Earth's. They form from the most massive protostars, at least 8 solar masses, stars that will explode as supernova, leaving behind collapsed cores, spinning rapidly, generating immense magnetic fields. But the magnetar itself doesn't form in the nursery, only its progenitor, the massive protostar that will one day collapse and become something strange, something extreme, all determined by the initial mass gathered in the nursery in those first few million years of formation. Everything determined by those early moments of collapse. The star's mass, its composition, its fate, all decided before fusion begins. The universe writing each star's destiny in the stellar nursery where it's born. Thump, thump, or maybe no thump at all, they're just silenced, deep, complete. Your heart's still beating somewhere, but you're no longer listening, no longer aware of your body, of the room, of anything. Just darkness, just peace, just nothing. In stellar nurseries, at the moment of ignition, when fusion begins, the protostar stops collapsing. Radiation pressure from fusion balances gravity. The star reaches equilibrium and settles into billions of years of stability. The violent, chaotic, unpredictable nursery phase ends, replaced by the calm, steady, predictable main sequence. But that stability will end too. Eventually, the star will run out of hydrogen. It will evolve, swell, or collapse, depending on its mass. It will die, one way or another, and its death might trigger new stellar nurseries, the cycle continuing: birth, life, death, rebirth, endless, eternal, the universe, never stopping, never resting. But you can rest, you can stop, let go, surrender to the stillness. The universe will continue without you for a while. The stellar nurseries will keep forming, stars will keep igniting, galaxies will keep turning, all happening while you rest in the dark. Feel the darkness now, complete, total, enveloping you, like the darkness of a molecular cloud before any star has formed, before any light has emerged. Just potential, just waiting, just the slow, patient stillness before creation. Thump, thump, or not. You're beyond noticing, beyond caring, just floating now in the space between thoughts, in the space between breaths, in the space between moments, the space where nothing happens, where time stops, where consciousness just dissolves into pure, simple existence. And in that space, in that stillness, stellar nurseries drift, clouds of gas waiting to collapse, protostars gathering mass, waiting to ignite the universe in the quiet moment before birth, holding its breath before releasing light into the darkness. You're holding your breath too, or maybe breathing so slowly it's the same as not breathing. Everything paused, suspended, balanced, on the edge, between being and not being. In the deepest stellar nurseries where the youngest protostars hide, the darkness is absolute. No light penetrates, even infrared is absorbed, scattered, lost. Only the faint thermal glow of dust grains, barely above absolute zero, invisible to every telescope, except the most sensitive, the stars there, forming in complete privacy, in total darkness, unknown, unseen, until they emerge millions of years later into the light. And that's where you are now, in the complete darkness, the absolute privacy of deep sleep, unknown, even to yourself, consciousness extinguished completely, your body, your mind resting in the deepest, most restorative just darkness, far from light, far from thought, far from awareness. The stellar nurseries continue their work, gravity pulling, gas collapsing, dust swirling, jets erupting, all in silence, all in darkness, all in the patient, unhurried rhythm of cosmic time, where 1,000,000 years is just a moment, where your lifetime is less than a heartbeat, where everything that matters to you is just a flicker in the endless night. But that flicker is enough. You are enough. Your rest is enough. There's nothing more you need to do. Nothing more. You need to be. Just rest. Just drift. Just let the darkness hold you forever. Or just for tonight. It doesn't matter. Time has stopped, meaning anything. Thump, thump. The universe breathes. You breathe. The same breath, flowing through everything, connecting everything. The stellar nurseries, the collapsing clouds, the forming stars, the dying suns, all breathing the same breath, all pulsing with the same slow, eternal rhythm. And we'll keep drifting, floating together through the mysteries. 100 star nurseries mysteries, looping softly, endlessly through the night. The gas clouds turning so slowly you'd never notice. The protostars gathering mass, grain by grain. The jets carving through darkness, silent, patient, eternal. The universe keeps turning, the soft cradles of star nurseries where light is born in silence, where darkness holds the seeds of stars, where patience is measured in millions of years, and everything is slowly, softly drifting toward light. And we'll keep drifting, floating together through the mysteries, 100 star nurseries mysteries, looping softly, endlessly through the night. Tonight we'll drift through the hidden cradles where stars are quietly born, the silent cosmic collisions that shape sparkling clusters, and the ancient clouds holding newborn stars you'll never see with your eyes. There's nothing you need to do now. Just let your body sink, heavier, heavier. Feel the mattress holding you, every muscle softening, your heartbeat slowing, thump, thump, matching the rhythm of space itself, shoulders melting down, jaw releasing, each breath pulling you deeper, deeper into the calm, the quiet, the dark,